Hello team, welcome back. And in this section, we will learn about the Kubernetes networking concepts. First, we will start with the Kubernetes networking overview and we will see how network works within Kubernetes cluster. As a part of this lecture, we are going to discuss the Kubernetes network and Kubernetes network model. Very first, let's start with Kubernetes network. Kubernetes network or Kubernetes network model define that how network behave or how network will work between the pods. We are very well aware that within the Kubernetes we will create the containers and that container are basically wrapped up in a single unit called pod. And within a single pod, if you want, you can have the multiple containers as well. So as we are aware that pods are the basic object of Kubernetes and networking model in Kubernetes or network in Kubernetes basically define that how that pods which are running within my Kubernetes cluster they will behave and how they can communicate. In Kubernetes, many network implementations are available. Whenever you will search for the Kubernetes network, you will get a Kubernetes official document page and you will see a multiple network models are available for the Kubernetes. If you remember, then whenever we have done the setup of HA Kubernetes cluster, we used the network called Calico. So we downloaded the Calico YAML from internet and then we executed these Calico YAML. Just like the Calico, there are multiple network implementation available for the Kubernetes. But if you are using the Kubernetes with kubeadm, then Calico is best supported network for the kubeadm. Kubernetes basically impose the following fundamental requirement on any networking implementation. Whatever the networking implementation you are going to use in Kubernetes, but here listed fundamentals will be the part of that network. And first is that pod on a node can communicate with all the pods on the all nodes without any net. So if we have a multi-node Kubernetes cluster and any pod want to communicate with the other pods, then if the network allows, then the pod can easily communicate to the other pods without using the network address translation. They don't use network address translation or in short called net, and they can directly communicate with the other pod over the IP or the local host. In Kubernetes system, multiple agents are in the running state, and agents on any node like the system daemons or the kubelet can communicate with all the pods on that particular node. That is also a basic fundamental of any network plugin or any network whatever you are going to use in Kubernetes. One more thing that every pod gets its own IP address, right? So whenever we are creating the pod, that pod must have their own IP address so that the other pods can communicate to that particular pod either by IP or the DNS. We will talk about the DNS shortly, but right now you can understand the pod can communicate by each other either by the IP or by the DNS record. So here we have a node 1 and here we have a node 2. Within a node 1 and within a node 2 we have the multiple pods. Let's assume that within a node 1 we have a pod 192.168.0.2 and another pod 0.3. Similarly, we have the another pod 0.4 and in the node 2 we have the pods which have the IP like 192.168.1.2. So you can see each pod have the unique IP. The IP won't be shared within the pods if they are part of a same Kubernetes cluster. And if any pod want to communicate with the another pod, they can communicate via IP address or the DNS record. So the pods which are the part of different node, they can communicate to each other via IP address. The pods which are part of same node, they can also communicate to each other via IP address. So all the pods which are a part of a single Kubernetes cluster, they can communicate to each other, right? And that communication can be set up via IP address or the local DNS record. We will talk about it, but this is the medium of communication between the pods. And any network, whatever the network you are going to use in Kubernetes, that network must provide this functionality. That is the basic fundamental of Kubernetes network model. So thank you team. See you in the coming lecture. Hello team, welcome back. And today we will discuss about the CNI plugins in Kubernetes. We will see what are the CNI plugins and how CNI plugins are helpful in creating the Kubernetes network. As a part of this lecture, we will learn the CNI plugin concept, selecting the network CNI plugin, and install the CNI network plugin in Kubernetes. First, start with the CNI plugin introduction. CNI plugins are the Kubernetes network plugin. As I told you in the previous lecture that many network implementations are available for the Kubernetes, and CNI plugin are the component which provide these implementations. So in the Kubernetes we have the multiple network implementation, and these implementation are basically imposed by the CNI plugins. CNI plugin provide the connectivity between the pods as per the Kubernetes network model. So we have already discussed about the few fundamentals of Kubernetes network model. CNI plugin will basically provide these fundamentals and additional feature as per the network plugin. Multiple CNI network plugins are available for the Kubernetes. If you want, you can go to the browser. In a browser, we will search for the Kubernetes network. You can see we are getting the kubernetes.io concepts network administration, cluster administration, and cluster networking in Kubernetes. Let's click this, and here we have the cluster networking concepts. Let's scroll a bit, and here we are getting a separate section how to implement the Kubernetes networking model. And these are the plugins available for the Kubernetes networking model, and they are listed over here with the little descriptions. You can learn about it and you can see what are the specific plugin and what are the features they plugin are providing. So we have the ACI, Antaria, AOS. Just scroll a bit and we are getting the Calico. This is the plugin we are using in our Kubernetes cluster. So different network implementations are available in these plugins. You can learn about these plugins and you can select the network plugin which is best for your Kubernetes cluster as per your program need or as per your business need. Now let's discuss about the selection process of network plugin. We have seen that there are multiple network plugins available for the Kubernetes networking, and selection of the CNI plugin depend on your business need. So you can do one thing, you can go through the documentation of this plugin and you can go through the your business need. You can compare that what is the plugin which is close to your business need and you can use that. So as I told you that you may need to go through the Kubernetes networking documentation to get the idea about different network plugins. The HA setup which we are using the Calico network plugin. And why we are using the Calico network plugin? Because Calico network plugin supports the kubeadm very well. The kubeadm network support with the Calico is best. So that we are using the Calico because we are using the Kubernetes setup by a kubeadm. If you want to install the network plugin, you can go through the plugin documentation because each plugin have their own way to install the plugin. There is a note as well and you need to take care this very seriously. Kubernetes node will remain not ready until you install the network plugin, and user won't be able to run the pods. If you are not using any network plugin in your Kubernetes cluster, the nodes which are the part of your cluster, they will be not ready and you won't be able to execute any kind of pod creation or any kind of object creation in your Kubernetes cluster. So network implementation is very necessary for your Kubernetes cluster. So team, if you have any question, you can ask me. Thank you team. See you in the coming lecture. Hello team, welcome back. And today we will discuss about the DNS in Kubernetes. We will see what are the DNS in Kubernetes and how DNS are helpful in Kubernetes network. So in this lecture, we will discuss about the DNS in Kubernetes cluster, and we will also discuss about the pod domain names, and then we will see a short labs on the DNS in Kubernetes. First, discuss about the DNS in Kubernetes. So Kubernetes virtual network uses the DNS which allow pods to locate other pods and services using the domain name. So whenever we are creating the Kubernetes cluster, we are also creating the network so that the pods can communicate to each other. And the value which are basically allowing the pods to communicate each other, or the value which allow the communication between the pods and the services. That is called the domain name or the DNS record. We have not discussed about the services till date, but services is very important object in Kubernetes, and in coming section we will discuss the services from basic to advanced. DNS in Kubernetes run as a service in kubesystem namespace. So whenever you are using the Kubernetes cluster, you can go to your kubesystem namespace and you can identify if any DNS service is running in your kubesystem namespace or not. KubeADM and Minikube both use the core DNS. All the pods in the KubeADM cluster are automatically given a domain name like pod ip dot namespace name dot pod dot cluster dot local. So whatever the pod running in your Kubernetes cluster, that will have the default name record like this. It will have the pod ip and pod ip will be hyphen separated. Then we have the dot namespace dot pod dot cluster dot local. Let's assume the pod which are running in your Kubernetes cluster that have the IP 190.168.0.20 and that is running in a default namespace. Then the DNS record for that particular pod will look like 190-168-0-20. So your DNS record will look like this. First, it will separate out your IP address with a hyphen, then put a dot, and it will put the namespace. In my case, the namespace is default, so I'm putting IP dot default. Then you need to put pod dot cluster dot local. This is a complete DNS record, and you can communicate with your pod on this particular DNS record in Kubernetes cluster. Let's go to your Kubernetes cluster and see a hands-on demonstration on DNS. So we are in Kubernetes cluster. You can see we are in Kubernetes single node cluster, which is in a mini cube, and we will execute the get pod commands. And this time we will execute the get pod command on a namespace kube system. Hit enter, and here you can see a pod is running for the core DNS. See, there is a pod for the core DNS which is running in your kube system namespace. If you want to get the services which is running in a kube system namespace, you can execute a command kubectl get services. Hit enter and see the two services are running and the DNS service is also running in my kube system namespace, right? So the core DNS pod is also running and the DNS service is also running. Now we will see how the pods can communicate to each other by a DNS record. Let's create a directory mkdir and called Kubernetes networking. Go to the Kubernetes networking directory and create a file pods-dns.yaml. Go to the insert mode, and I have created a basic YAML file for this lecture. You can see here I am creating the two pods. The first pod is the nginx pod, and the pod name will be nginx-node name, and the second pod is the alpine pod, right? Let's do one thing. Let's copy this and paste it here. You can see the nginx is a pod and the alpine version is also a pod. I will save this and execute the apply command kubectl apply -f pods dns.yaml, and we will see it create the both of my pods. We will execute the get pod command. So we are executing command kubectl get pods -o wide, and see both of my pods are in the running state. Now let's get the number of pods running in my Kubernetes cluster. So we will execute command kubectl get pods -o wide, and these are the two pods which are running, front-end app and nginx node name. This is the IP of your nginx. Let's copy this and execute curl on it. Curl and provide your IP. Hit enter, and you can see I'm getting the response which is the nginx default web page. Now let's execute the curl on this IP and replace the dots with hyphen. Put dot default dot pod dot cluster dot local. Hit enter and see it is not able to resolve this particular host. Why we are not able to resolve this particular host? Because we are trying to access this DNS from the host machine. We are not trying to access this DNS from the Kubernetes pod. So we'll execute a command kubectl exec -it provide my pod name, which is front end app, and put sh. Hit enter. You can see we are inside the pod. Let's do one thing. Let's execute apk update because I'm using the Alpine and Alpine have a default package apk. So we will update the package first. The package update is done. Now we need to install the curl. So we will execute apk add curl. Hit enter. It will install the curl and it's done. If you want to verify the curl version, you can execute a command curl hyphen version, and we are using the curl version 7.77.0. Right. Now let's clear out the console and do one thing. Let's execute the curl, the IP. What was the IP of your pod? I don't remember. So we will exit out the command, and this is the DNS record which we was trying to access. What I will do, I will copy this DNS record, go to the pod again, and execute the same command curl, then this DNS record. Hit enter and see. This time I'm able to access the nginx page. And how this become possible? Because earlier we was executing this curl command outside my pod. I'm executing this command from a host machine where the Kubernetes is running. But here I'm executing the curl command on this DNS record from one pod to another pod. Right now I'm inside the Alpine pod and I'm trying to access the pod which have a IP-6, which is the nginx pod, right? So this is the way how the pods can communicate to each other by a DNS record. And this is not just specific to the Calico network, that is specific to the any network which you are using within your Kubernetes cluster. So all the fundamentals which Kubernetes impose as a network model on the different implementation, that is mandatory to the network implementations or the CNI plugin to apply these fundamentals or the basic Kubernetes network approach as a part of that Kubernetes CNI plugin. So team, that's all for the day. If you have any question, any doubt, please let me know. Thank you team. See you in the coming lab. Hello team, welcome back. And today we will discuss another very important concept in Kubernetes networking called network policies. We will see what are the network policies, what are the port selectors in network policies, and how port selector will impact the traffic on the pods. We'll also learn about the ingress and egress network traffic. We will learn about few other selectors like from and to. We will also learn the role of ports in Kubernetes network policy, and then we will do a hands-on demonstration on Kubernetes network policy. So first, let's start what is network policy. So in Kubernetes network policy are used to control the traffic flow on pods. Network policies control the traffic flow on pods at IP address level or at the port level. So you can restrict the network traffic specific to IP addresses, or you can restrict the traffic on a specific port in the pods. Like the pods, services, deployment, network policy is also an object in Kubernetes. So whenever you want to create the network policy, first you need to define the template, then you need to create the network policy object in Kubernetes. So network policy control the traffics on the pods, and pods can communicate using three identifiers. And first identifier is other pods that are allowed. So the pods which are allowed to communicate to a specific pod, only these pods can communicate. So if you have a pod A and there is a set of pods B, C, D, and E. So out of B, C, D, and E, if only two pods are allowed to communicate with pod A, then only these two pods can communicate to pod A. And that identifier is the other pod that are allowed. The another is namespace that are allowed. Within the network policy, you can also define the namespace, and the pods which are belongs to that namespace can only communicate to the other pods. And the another identifier is the IP blocks. You can define the IP ranges within your network policy, and on the basis of that IP range, the pods can communicate to each other. The purpose of network policies is to build a secure network by keeping the pods isolated from traffic they do not need. So till now we have seen that all the pods can easily communicate to each other because within the Kubernetes we have not worked on any kind of network layer till date. So by default the traffic from pods are allowed from any to any, and that is also called non-isolated pod. It also means then by default the pods in the Kubernetes are the non-isolated pods. But we can isolate the pod applying the network policy on these pods. And how we can apply the network policy on the pods? Let's look into that. So to apply the network policy on the pods, you need to create a network policy, and these are few components of the network policy. First component is the pod selector. Pod selector determines to which pod in namespace the network policy will be applied. So within the network policy, you will define a field called pod selector, and within that pod selector, you will define the label. All the pods which are matching that particular label are the candidate of this particular network policy. So as I told you, pod selector can select the pod using the labels. If you are defining the pod selector in the network policy and that is empty, it means that don't have any matching labels, then it will contain or it will select all the pods within that particular namespace in which namespace you are creating that network policy. So here is the sample definition or manifest of the network policy. So this section is about the definition where we are defining the API version, the kind of object, metadata, and the namespace. And this section we was talking about. We was talking about the pod selector. Here we are defining the pod selector. Within the pod selector, we are defining match labels, and this is the label, right? Whenever you will create this particular network policy, this particular label will be matched on the labels on the pods, and all the pods which have this particular label, this particular network policy will be applied on all of these pods, right? So this is the way how network policy applied on the pods. The first thing is the pod selector. Network policy apply on both kind of traffic, ingress and egress traffic. What is ingress traffic? All the incoming network traffic that is coming into the pod from another source, that is called the ingress traffic. And in opposite, all the outgoing traffic that is leaving the pod to another destination, that is called the egress traffic. So network policy is basically applied on both kind of traffic. Network policy is applied for the ingress traffic as well and the egress traffic as well. You need to define the policy type whenever you are creating the network policy, and that is completely optional. You can define egress and ingress both, or you can define any of them, either the ingress or either the egress. That all depends on your business needs. Another selector we discussed is the to and from selector. Like we have seen the pod selector, in the same way we have the from and we have the to. From selector means that select ingress traffic that will allowed on the pod. So whenever we are putting the from within the network policy, we are basically applying the network policy on the ingress traffic. From selector only and only select the ingress traffic that will be allowed on the pod. The traffic which is coming on the pod, only that traffic will be allowed from the from selector. To selector, in the opposite way, select only the egress traffic. Egress means the traffic which is leaving the pod to a destination, and all the rules which you will define within the to selector that will be applied on the egress traffic from the pods. So if we have the pod selector basically select pods to allow traffic from and to. The syntax will be look like this. You will define the ingress, you will define the from, that is the selector, and within the from you can define the pod selector match labels client, match labels role client. It means all the ingress traffic on the pods which are matching this particular label role equals to client will basically follow this particular network policy rule. In the same way, if you have the another selector which is the namespace selector, that means select namespace to allow traffic from and to, and the syntax will be look like this. Instead of the pod selector, this thing will be just replaced with the namespace selector, right? And the another component was the IP block, which select an IP range to allow the traffic from and to, and syntax will look like this. You can define the ingress from IP block, and you need to define a CIDR range, which is CIDR range of your IPs. Here we are defining the IP 172.17.0.0 with a CIDR range 60. It means the IP will be allowed from a range 172.17.0.0 to IP range 172.17.255.255. So all the pods which have this particular IP range, it means the IP of the pod which are falling in this particular range, they will be allowed by this particular network policy, where we are defining the IP block with a CIDR range. If you have any doubt, any question regarding this CIDR range, you can Google around it and you can learn more about the IP CIDR range. Another component of network policy is the ports. Port specify one or more port that allow traffic. So if you want to accept the traffic only and only port 80 on TCP protocol, you can define a network policy like this. Ingress from ports TCP protocol port 80. You can define the multiple ports over here and ingress traffic on your port on which this particular network policy will be applied, only and only accept the traffic on port 80. Otherwise it will reject all the traffic which is coming on any other port. In the same way, if you want to define the ports on the egress, you can define 2, right? And within the ports you can define the ports. With the ports you can also define a range of port. Over here you can see within the egress we are defining a range of port from 32,000 to 32,768. It means the outgoing traffic from a port on which this particular egress policy is applied, that will allow a traffic to outer world if the protocol is TCP and traffic is going between these two port range. In the coming lecture, we will also see hands-on demonstration on network policy. We will create a network policy, we will create the pods, and we will see how network policy will block the traffic and allow the traffic on port and from port. So thank you team. See you in the coming lecture. Hello team, welcome back. And in previous lecture, we have discussed about the network policies in Kubernetes. And today we will see a practical lab on network policies. We will create the pods and we will see the connectivity between the pods. After then, we will create the network policy and we will again verify the connectivity between the pods. So let's go to the Kubernetes cluster. So team, for this lab, I'm using the Kubernetes HA cluster. This is my master machine and this is my worker machine. So if you want to check, you can execute a command kubectl get nodes, and we can see we have a master node and we have a worker node. So this is not the mini cube what we are using for this lab, but this is a HA machine. You may ask the question why we are not using the mini cube for this lab. Because mini cube setup is not compatible for the network policy. If you will execute this lab on minikube, you will identify that network policy whatever you are creating in your minikube, that is not applied on the pods, because to apply the network policy, network needs an agent and minikube network don't have that agent. Within the HA we are using the Calico network have that agent, so that network policy will be applicable on my HA setup. Very first we will create a directory mkdir and name it network underscore policy. Let's go to this directory network policy, and over here we will create a file called network policy -pod. So we are creating a file network -pol -pods.yaml. Go to the insert mode and we will get the code from my Visual Studio code editor. So here is a sample file which I created for this lab. You can see we are creating the two pods. First is this and another is this. The first pod is the Nginx pod and this is going to be created in a namespace called network-policy. Even the both of my pods are going to be created in a namespace network-policy. We are not using the default namespace over here. The labels are attached with both of my pod. My first pod, the Nginx pod, have the label app frontend, and my second pod, busybox pod, have the label app client. Within the specification, we are defining the containers. Over here, my Nginx container name will be Nginx and the image will be Nginx. Second pod, I'm using busybox and I'm using the radial busybox plus image with the curl tag. The command I'm providing sleep for 3600 second. What I will do, I will copy this, paste it here and save my file. But before creating this file, we will verify if network-policy namespace is present on my cluster or not. So execute a command kubectl get namespace, and we can see the namespace is not present on my machine. So what we will do, we will create the namespace first. To create the namespace, you will execute a command kubectl create namespace network-policy. This is the name of your namespace. You can see within the YAML as well, we are using the network-policy. If you want, you can change this name to anyone, but make sure you will use the same namespace name in your YAML files. Hit enter. It is saying namespace is created. Let's get the namespace again. And yes, we are getting the namespace. After creating your namespace, let's clear out the console and execute the get command again with one more parameter, show labels. Hit enter, and you can see these are the labels which are attached with my namespace. My namespace network policy have the label Kubernetes IO metadata name network-policy. Let's attach one more label to my namespace. So I am attaching one more label to my namespace, and label will be role equals to test-network policy. Why I am attaching this particular label with my namespace? Because I want to show you the ingress traffic rule or ingress network policy rule with a from namespace selector. And to select the namespace, we need some kind of labels on my namespace, so that we are attaching this particular label. Hit enter. Let's execute the get command again and see the label is attached with your namespace. Role equal to test-network-policy. Let's clear out the console and create the pod. So we will execute kubectl apply -f and define your file name, which is network-pol-pods.yaml. Hit enter and see both of the pods got created. Let's get the pods. Kubectl get pods -o void and define your namespace, in which namespace the pod got created. In my case, I created my pod in a namespace network-policy. You can see both of my pods are in the running state. The busybox pod is in the running state, and Nginx pod is also in the running state, and these are the IP address of my pods. Now what I will do, I will try to access my Nginx pod from my busybox pod. For this, I will execute a command kubectl exec -n define your namespace, then define your pod name, then define --, and define the command which you want to execute. I want to execute curl command on this particular IP, like this. Please make sure you will provide the space between the commands and the IP. Hit enter, and you can see this particular command is executing successfully, and we are getting the Nginx default page. And over here we are getting the curl status as well. Now, up to this point, we have not used any network policy in my namespace network-policy, so that all ports are able to communicate with all ports. It means ports are non-isolated. As I told you in the earlier lecture, that by default ports are non-isolated, and ports will be isolated only and only if you apply the network policy in your Kubernetes cluster. So I will clear out the console and create one more file, vi network-policy.yaml. Go to the insert mode and let's try to understand the network policy manifest. So here I have created the network policy manifest. First we are defining the API version, which is network.k8s.io.v1. Then we are defining the kind, which is network policy. Within the metadata, we are defining the name of my network policy, sample network policy, and the namespace. In which particular namespace this policy will be created. So we are defining the network hyphen policy namespace, which we just created for this lab. Within the specification, we are defining the pod selector, and match labels we are defining app frontend. You can see this is the same match label which we have defined with my nginx pod. So this network policy by default will be applicable on the nginx pod, and we are defining the policy type ingress and egress. For the ingress, we are defining the from identifier, and then we are defining the namespace selector. Right, you can see we are defining the namespace selector. It means this ingress policy will be applicable on the namespace which will be matched with this particular selector. Within the match label, we are defining role test network policy. This is the same label which I applied on my namespace. Right, then we are defining the ports, and we allow the ingress traffic on a protocol TCP on port 80 because nginx by default listen on port 80. So what I will do, very first I will just copy up to this particular point of line, paste it here. So we are not defining any ingress and egress, although this network policy will be applicable on the pods, but as we are not defining any ingress and egress rule, so this will make the pods isolated. It means none of the ingress and egress traffic will be allowed on a pod which are matching with this particular label. In my case, that is the nginx pod. Let's save this and create the network policy kubectl apply hyphen f network hyphen policy.yaml. Hit enter. You can see the network policy got created. If you want, you can check kubectl get network policy hyphen n, define your namespace hyphen o void. Hit enter and see we are getting the network policy, and this is the pod selector app front end. Now let's do one thing. Let's try to execute the exact command again. So this is the command we executed before the network policy, and we was able to access my nginx pod on this particular IP. After the network policy, let's try to execute this again, and you can see this command is not working. It means I'm not able to curl my nginx from my busybox pod. And why this is happening? Because we have created a network policy, and by a pod selector that network policy is applicable on my nginx pod, right? But we have not defined any egress and ingress rules, so that by default none of the ingress or egress traffic is allowed on the nginx pod. Let's press Ctrl C to exit out. Open the network policy file again. Clear out this file. Now copy the complete file where we are defining the ingress rule from a namespace and on port TCP 80. Let's copy this, paste it here, save this, execute the apply command again. Hit enter. You can see it is saying policy configured. Let's get the status again, and you can see my network policy is running. Now let's try to execute the exec again, and you can see this time we are able to successfully access my nginx from my busybox pod. So this is the way how network policy work within the Kubernetes cluster. Instead of the network selector or namespace selector, you can use the IP range, you can use the pod selector. So you can practice around the network policy, but we have explained the concept that how network policy work in Kubernetes and what is the importance of network policies, right? So by network policy, you can allow and block the traffic within your Kubernetes cluster on the pods, and you can use the multiple selector to allow and block that traffic either by the pod selector, by the namespace, or by the IP range, or by a port as well. So thank you team. See you in the coming lecture. Hello team, welcome back. Hello team, welcome back. And in this section, we will learn about Kubernetes services. Hello team, welcome back. And in this section, we will learn about the Kubernetes services. Kubernetes Kubernetes services are very important for access the application in Kubernetes. So first we will discuss about the overview of the services, and in the coming lectures we will dive deep in services, and in the coming lectures we will learn more deep concept of the Kubernetes services. For today we will discuss what is service, we will discuss about the service routing, and then we will discuss about the endpoints in Kubernetes service. So what is Kubernetes service? Till date, we have seen that we can create the pods, and within the pods we can create the till date we have seen that we can create the pod, we can put the securities on the pod, we can till date we have seen that we can create the pod, we can create the containers within the pod. On on the top layer of the pod, we can create the deployment, replica set, and a lot of things we have seen, right? But how but we have not seen that how user will access these pods. Although we can access the application which is running within the pod by a local Kubernetes cluster, but how end user will access these pods? How end user will access my application? So Kubernetes service are used to provide the access of pods from the outer world. Whatever the application running within your pods, Kubernetes service provide the connectivity between these applications to the outer world. We can mention that Kubernetes services are the abstract layer between the pods and client, because the communication which is established between the pods and the client, that is being done by the services. Services in Kubernetes provides a way to expose application as a set of pods. It doesn't matter that application is running in a single pod or you are executing application as a multiple pod. Suppose you are executing a deployment which have the 5 replicas. It means 5 pods are executing the same application. It means 5 pods are executing the same application. Service provides a way so that we can expose a application as a single unit to the end user. End user doesn't need to End user don't need to care the number of pods, number of replicas will not be exposed to the end user. End user end user End user is aware of a particular URL on which your service will be accessible. It doesn't matter, and it has nothing to do with end user that a single pod is executing that application or 100 pods are executing that particular application. Let's discuss about the service routing. How service routing works. So whenever you are executing the service, and that service is exposing the application to the outer world or to the client make a request to the service directly. Client will not make the request to the pod. Client will make the request to the service, which route the traffic to port in load balancer fashion. Let's understand this. Suppose this is a client and there's a service. Now we are executing our application, and there are multiple pods are running for my application. Suppose n number of pods are running for my application. The end user or the client will hit the service. The end user or client will the end user or client want to access the application, so eh, they will try to so they will hit the given they will hit the given DNS or given URL. That URL is directly exposed to service, and further service service will route that particular traffic to the any of the pod. It will work in a load balancer fashion. There could be the multiple algorithm which Kubernetes apply for load balancing between the pods and the services. So service may send your request to port number n. It may also send your request to port number 2 or port number 1. It doesn't matter. It's not fixed that service will always interact with the single pod. No, service will interact the number of pods. If multiple pods are executing the application, then service will interact with these pods in a load balancer fashion. The general The common load balancing mechanism which service will use is a round robin. It means first service will send the request to pod 1, next request will be sent to pod 2, next to pod 3, pod 4 and pod n. This is called the round robin, right? Whenever service are rotating the request to each number of whenever the service will rotate the request to each pod. Then what are the endpoints? So endpoint is a backend entity that will connect the service and the pod. Endpoint is a thing we can also understand that endpoint is entity which will we can also understand that endpoint is a entity to which the service route the traffic. Each pod have the endpoint associated with the service. So generally endpoints are the combination of pod IP address and the pod port, right? And that endpoint is directly exposed to the service. So if three pods are running my application and I will create the service which basically and I will create the service which basically have the selection criteria of all three pods, then the IP address and the port, then the IP address and the port on which the application is accessible. They will be they will be associated with the service in a comma separated fashion. So here is the sample. So here I am showing. So here we can see a sample. Here we are Here we are getting a endpoint of a service called nginx-svc. And you can see whenever we are getting the endpoints, we are getting the three columns, name, endpoint, and age. So you will get the service name, then you will get the endpoint. Here we are getting the multiple IPs and the port 80. It means there are three IP. It means three pods are running it means three pods are running on which this particular service is working and the total age is 21 minutes. So endpoint is a connectivity. So endpoint is a backend entity that will associated. So endpoint is a backend entity that is associated with the service, but endpoint is a combination of pod IP and pod port. So that's all about the service overview. In the coming lecture, we will see the implementation of service and the labs on Kubernetes service. So thank you team. See you in the coming lab. So thank you team. See you in the coming lecture. Hello team, welcome back. Welcome to Kubernetes training and today we will see how we can use the services in Kubernetes. So today we will learn that what is the service types and how many service types are available in Kubernetes. We will learn about the cluster IP service type. Then we will learn about the NodePort service type. Then we will see the load balancer service type, and in last we will see the hands-on demonstration on Kubernetes services. So very first, let's discuss what is service type. So each service has a type. Whatever the service you are creating in Kubernetes, that must have a type. By default, the service type is cluster IP. Service type defines how and where the service will expose the application. So basically, service type defines the set of rules that how and where the service will be exposed. There are four types of the services. First is the cluster IP, second is the node port, third is a load balancer, and fourth is the external name. External name and load balancer are not covered or not a part of Kubernetes certification exam. So you can avoid these services type if you are just preparing for the Kubernetes certification exam. Otherwise, you can also practice on these two types of services as well. Very first, we will discuss about the cluster IP service. What is the cluster IP service in Kubernetes? So right now we are pretty much clear that service is used to expose the application to the outer world. Now the types defines that how that service will be exposed to the outer world. First is the cluster IP, and cluster IP service expose application within the cluster network. So whenever we have a need to expose the application within the cluster network, not outside the cluster network, I'm saying within the cluster network, then you can use the cluster IP service. Now you may ask the question, then what is the use of cluster IP services? Although the end user is not able to communicate with my service, but what is use of it? So you can use the cluster IP services whenever the client is other port within the same cluster. It means whenever a port want to communicate with the other port, you can use the cluster IP service for that communication. Now we can also understand that the communication between the pods are by default enabled. So why we want the services to access the pods from a pod? So right now we are just dealing with the single namespace so that the communication between pod is easily available. But what if your pods are belong to the different namespace? In that case you need to use the service, right? In that case the pods which are part of namespace A, and if they want to communicate to the part of namespace B, then they need to use the cluster IP services to communicate with the other namespace pods. And there could be the multiple scenarios whenever you need the communication between the pods, right? If you have a simple application of front end and back end, then front end want to communicate with the back end, and you can expose that particular communication by the cluster IP services. So here is the services, and here we have the different pods like pod 1, 2 and n. So service can communicate to pod n, service can also communicate to pod 2 and pod 1. And here is the client, which is a pod itself. So pod will make a request to the service, and service will forward that traffic to the pod. That is called the cluster IP service type, and cluster IP service type is only and only used to open the communication between the cluster network itself. Another one is the NodePort. NodePort service expose the application to the outside cluster network. The cluster IP expose the application within the cluster network only, but NodePort service expose the application to the outside of the cluster network. So you can use the NodePort whenever client is accessing the services from the outside of cluster network. So suppose this is a cluster, and here we have a service. This service is basically connected with the three pods, pod 1, 2 and 3, and here we have the client which is not from the Kubernetes cluster. So that is a outer client which is not using your Kubernetes network, and if they want to access the application which is running on your pod, then you need to create the node port service in that case. And third service type is the load balancer service. So load balancer service is also expose application to the outer world, but load balancer service need the cloud ILB or cloud load balancer. It means this kind of service will only and only applicable if you are using the Kubernetes on a cloud, on public cloud, and that public cloud supports some kind of load balancers, right? If that cloud have the load balancer, like the AWS have the load balancer, Azure have the load balancer, GCP have the load balancer, then only and only you can use the load balancer service type, because in this service type service will create a load balancer, and that load balancer will directly connect to the service. Although in the backend load balancer will connect to the node port, and node port will connect to the pods, right? On the in the backend the node port service will create, but a load balancer will also create, and client can directly access your application on that particular load balancer. So here we have the cluster and we have the service. These are few pods which are connected with your service, and suppose client want to access your service by a load balancer, or you are creating a load balancer service type. In that case the client will access the cloud load balancer, and that cloud load balancer will redirect the traffic to your service, right? The last is the external name service. External name service will also use the load balancer service type. The only and only difference in the external name service, you need to create the C name which will directly access the service in Kubernetes. In the coming lab, we will see hands-on demonstration on the services. We will see how we can create the cluster IP kind of service and the NodePort kind of service. So thank you team. If you have any doubt, any question, you may ask. Thank you team. See you in the coming lab. Hello team, welcome back. And today we will see a lab on services in Kubernetes. We will create the pods and we will create the service in Kubernetes, and we will see how the client can access the application running in a pod via service. So let's go to the cluster. So here we are on our cluster, single node cluster, that is the minikube cluster. I will create a directory mkdir and call it Kubernetes k8s underscore services. Let's go to this directory Kubernetes services, pull ll, and no file is present over here. Now we will go to the Visual Studio Code. Now first we will create a pod file. So I will create vi svc-pods.yaml. In this file, what we will do, we will define the pod definition and we will create the pod first. Let's go to the Visual Studio Code, and here I have created a deployment YAML. You can see this is a deployment YAML. The name of my deployment will be nginx-server. I'm attaching this particular label with my deployment. Within the specification, I'm defining that 3 replicas will be created, and within the selector, I'm defining a match label app frontend. That match label is also defined with the pod template. Over here, we are executing the nginx image on port 80. We will copy this, paste it here, save it, and execute it. kubectl apply -f svc-pods.yaml. Hit enter. You can see the deployment is created. I will copy this name. You can execute kubectl, describe, paste it, hit enter, and here we can see that my deployment is created. Replicas 3 desired, 3 updated, and 3 total, and all 3 are available. That is executing on port 80, right? And here is the last message. Clear out the console. Let's execute a command kubectl get pods -o void. You can see 3 pods are running, right? And they pods are the part of my deployment. All the pods are running on different IPs. Now what we will do, we want to create a service. So how we can create a service? Let's create a file vi and call it ClusterIP hyphen services, or say svc.yaml. First we will create a cluster IP kind of service. Let's go to the Visual Studio Code again, and here is the YAML which I created for the cluster IP service. We will define the API version, which is v1. Then we will define the kind is a service. Within the metadata, we will define the service name. Within the specification, we are defining the type cluster IP. It's optional. If you will define the service type explicitly, then that is great. But if you will not define the type, by default service will take the type cluster IP. Then we are defining the selector, and within the selector we are defining the label on which particular pods this service will be applicable. So this service will be applicable on the pods which have the label app frontend. You can see this is the same label which we have attached on my replicas. If you want to see, you can go back to the cluster. Let's save the file empty, and over here, once you are getting the get ports -o void, let's define ---- show labels. Hit enter. See, we are getting the label app frontend port template hash. Port template has the label which is attached by the deployment, but app frontend is the label which we have attached by a YAML file. So in the same way, we are defining the match label within my service. Then we are defining the port. Here we are defining the protocol. Then here we are defining the port of my container, and we are defining the target port. Target port means on which particular port the service will be accessible. Open the file again which we created for the cluster IP. Go to the insert mode and paste the file over here. Let's save it and execute the service kubectl apply -f cluster IP svc.yaml. Hit enter and you can see the service is created. You can copy this name and describe this kubectl describe service. Here is the service. The service name is this, namespace is default. This is the selector and this is the IP. Over here you can see we are getting the endpoints, right? And target port is 8080 TCP. What are these endpoints? So these endpoints are the IP address of your ports. See, this is the IP address of your port. This is one and this is this one. And you can see over here we are getting the port 8080. It means we made a mistake. We need to define the target port 80 and service port 8080. So you need to open the file again, ClusterIP svc.yaml, and you need to update this. The target port should be 80 and if you want to access the service on port 8080, you can define the access port over here. Let's save this, apply the service again and get the service details again. This time you can see the target port is 80 and all the endpoints are accessible on port 80 and the service port is 8080 TCP. Let's clear out the console and let's try to access your service from here. So we will execute curl, define your service name, port 8080, hit enter, and it is saying could not resolve the host. It is not able to resolve the host. Why we are not able to access this service? Because this is a cluster IP kind of service and cluster IP service will only and only accessible from a Kubernetes network, but we are outside of the Kubernetes network. So first what we need to do, we need to create a temporary pod. So let's create another file and call it temppod.yaml. Hit enter, go to the insert mode, and here I have created a sample YAML for the busybox, radial busybox plus curl image. I will copy this and paste it here. The pod name will be pod svc test. The name of your container will be busybox and this is the image what we are using. Let's save this and execute this. kubectl apply -f temppod.yaml. The pod is created and pod name is pod svc test. Let's execute a command kubectl exec, define your pod name, -- define the curl and define your service name like this on port 8080. Hit enter and see we are able to access the nginx. So this is the way how we can create the cluster IP kind of service and that service will access the other ports within the Kubernetes network only. You can see outside the Kubernetes network that access is not allowed. But within the Kubernetes network, whenever I'm accessing the service from a pod, that network is allowing the traffic. So this is the way how the cluster IP service works. Now clear out the console and let's see how the NodePort will work. NodePort service mean I would be able to access the service from outside the Kubernetes network. So we will create a file vi nodeport-svc.yaml. Hit enter, go to the insert mode, go to the Visual Studio Code and here I have created a NodePort service type. You can see there's no much difference. This is the API version is same kind of service. This is the name, you can define anything over here. And in the type of service, I have changed the cluster IP with the NodePort. Selector is same, I'm selecting the pods which have the label app equals to front end. Then we are defining the ports. The port is TCP. Within this port, within the service port, you can define anything. The target port is 80 because my containers are running on 80. And here you need to define the node port. Node port will always have a IP of the 5 digit, right? If you won't define the node port IP over here, it will assign a random IP to your service. But if you will define a IP over here, then it will assign the defined IP to the service. So we are defining an IP. I will copy this, paste it here, save my file and execute my file. kubectl apply hyphen f and nodeport.yaml. Now we have saved the file. We will create the service by kubectl apply hyphen f nodeport svc.yaml. Hit enter and we can see the service is created. Now once you create the service, let's describe your service. So we are getting the service name, the namespace is default. Over here we are getting the service IP, the port is 80 and the target port is also 80. The node port is 30099 and these are the endpoints. Let's try to access your service. So you can execute localhost and define your service port 30099. Hit enter and see we are able to access the Nginx page. But it's not very impressive. Let's try to access the service on your cluster IP. So you can access the service on your master node cluster IP or your worker node cluster IP as well. If you are using the DigitalOcean machine like me, then you don't need to worry about it. The service will be directly accessible. But if you are using the AWS machine to execute this lab or the GCP machine to execute this lab, within AWS, you need to make sure that all the inbound rule will be you need to make sure that the all inbound rule will be allowed. It means your machine IP will be allowed in the inbound rule. But if you are using the GCP machine, the Google Cloud machine, you need to make sure that your security group will allow the traffic from the internet on your machine. Now I will go to my DigitalOcean machine and I will get the IP of my droplet. So this is the IP of my droplet. I will copy this, put it here, and I will try to access this on port 30099. Hit enter and you can see we are able to access the Nginx. So that traffic is basically routing to the node port service and node port service is further routing the traffic to the pods. You can see multiple time I will be able to access my service by the node port. So this is the way how you can expose your application to the outer world. This is the way how you can make your Kubernetes application to accessible to the clients. So that's all for this lab team. If you have any doubt, any question, you can ask me. Thank you team. See you in the coming lecture. Hello team, welcome back. And in last labs, we have seen that how we can create the service. Today we will see how we can discover the service. Suppose you have a need that some of your pod want to access your service, then how these pods can discover the service, how these pods or the services can communicate to the other services. So today we are going to discuss about the service DNS names. We are going to discuss about the service DNS and namespace connection, and then we will see a hands-on demonstration on the service discovery in Kubernetes. Very first, let's start with the service DNS names. So each and every service, whatever you are creating in your Kubernetes, that must have the DNS name. Kubernetes by default define the DNS for your service. DNS means the domain name service that allow applications within the cluster to easily locate the service. Because if each and every service have their own specific DNS, then that will be easy for the other Kubernetes object to communicate by the services. The fully qualified name of the services have the following format. This is the name format for your service in the Kubernetes. In the last section, we have seen the DNS for the pods, and this is the DNS format for the services. We have the service name, then dot, we have the namespace name, then dot, we have the SVC, dot, we have the cluster domain, dot, we have the example. The cluster domain dot example is the domain of your Kubernetes cluster. If you are defining a specific domain to your Kubernetes cluster, that is the domain of your cluster. Otherwise, by default, Kubernetes will allow cluster.local in your domain name. So the service fully qualified domain name will be like service name dot namespace dot svc dot cluster dot local. What is the relation between the service DNS and the namespace? So service fully qualified domain name can be used to reach the service from within any namespace in the cluster. It means if you are using the service fully qualified domain name to access the service, then from any namespace you can access your service. It doesn't matter that you are trying to access the service from a same namespace in which that service belongs to, or you are trying to access the service from the cross namespace. Pods within the same namespace or the Kubernetes object within the same namespace can use the service name only. They can use the service name only to access the services. But the Kubernetes object or the pods that belong to the different namespace, they must need to use the fully qualified service domain name to access the service in Kubernetes. In the coming lecture, we will see a hands-on demonstration on the service discovery in Kubernetes. Thank you, team. See you in the coming lab. Hello, team. Welcome back. Welcome to Kubernetes training. And in the previous lecture, we have discussed about the discovery of services in Kubernetes. Today, we will see a short lab on the service discovery, that how we can access the service object from within a same namespace or the cross namespace. So let's go to the Kubernetes cluster. So we are in the Kubernetes cluster, and in some previous lab, we have executed some services. Let's see how many services are running in my Kubernetes cluster. So we will execute kubectl get services -o void. Hit enter. And these are the services which are running in my cluster. So if you remember, this is the Nginx service we created in the last lab, and this is the Nginx service NodePort we also created in the last lab. This service is a ClusterIP service, right? If you will execute the kubectl get pods -o void show labels, then you can see these are the pods which are running as a part of the deployment, and this is the pod svc.test we executed to access the cluster IP services. Let's see that. So we have executed the command like kubectl exec. See, this is the command we executed. Pod svc test --curl nginx service, which is this service, port 8080. See, so we was able to access the service on a service name only. Let's hit enter and see we are able to access the service. Let's do one thing. Let's create one more pod. We will create a file. We will clear out the console, create a file vi, and call it dns-pod.yaml. Hit enter, go to the insert mode, and I have defined a separate file for the DNS service pod. This is the pod file, and here we are again creating the busybox plus curl, but this time we are creating this pod in a separate namespace called service-namespace. I will copy this, put it here, save my file. But if we will execute kubectl get namespace, we don't have that namespace. So what we need to do, first we need to create that namespace. Kubectl create namespace and define your namespace name. In my case, that is the service-namespace. Let's define this. Hit enter, get the namespace again, and the namespace is created. Now we will execute the kubectl apply -f, define the file name which is dns-pods.yaml. Hit enter, the pod is created. The pod name is svc test dns. After creating the pod, let's execute command kubectl get pods -o void show label, and we are not getting our newly created pod. So what we need to do, we need to define the namespace as well. -n service -namespace. Hit enter, and this is the pod we created in the different namespace. Now let's try to access my service again, the cluster IP service. So we have executed a command kubectl exec pod svc test. This is the pod which present in a default namespace. Curl defining my service name port 8080, and we are able to access the service. What is the pod name which I'm executing in the different namespace? That is the svc test DNS. Let's copy this, clear out the console, repeat the same command but replace the pod name over here. Also, you need to define the namespace explicitly, which is service hyphen namespace, right? Hit enter and see it is not able to resolve the service. Why it is not able to resolve the service? Because this service is not executing within the same namespace in which the pod is running. So it is not able to discover this particular service, right? While the earlier command, which was pod svc test, was able to discover the service and it is working. So what we need to do, we need to define the fully qualified name of my service. So we will define kubectl exec hyphen a and namespace, define your pod, then define service dot, define the namespace in which the service is running. So service is running in the default namespace dot svc dot cluster dot local. Then define the port, hit enter, and this time we are able to access my service. So this is the service DNS, and this is the relation between the namespace and the service DNS. Whenever the service and the request port is part of the same namespace, you don't need to define the complete DNS of your service. But if the pod which is working as a client and the service are in the different namespace, then you need to use the fully qualified domain name of your service to access the service. So team, if you have any doubt, any question, you may ask. Thank you team. See you in the coming lecture. Hello team, welcome back. And today we will discuss about the service management via Ingress controller. We will see what is Ingress controller and how Ingress controller manage the services for the outer world traffic. So today we will discuss about the Ingress. We will discuss about the Ingress controllers. We will discuss about the routing to a service by Ingress controller, and then we will discuss routing to a service with a name port by Ingress controller. These are the things we are going to discuss, and then we will see a short lab on Ingress controller to use the Ingress controller in practical way. So what is Ingress? We are already aware that Ingress is a traffic which is coming to the, so all incoming traffic which is coming to a pod is called the Ingress traffic. But there is one more thing called Ingress controller, and that is used to manage the external access to the service in Kubernetes. So we can assume here we have an external client which want to access my service. So once the external client will send the request, if Ingress controller is in place, that request is directly received by the Ingress controller. Then Ingress controller will send this request further to the service or services. When I'm saying service or services means Ingress controller will send the request to a single service or multiple services. We will look into it that how Ingress controller will manage the multiple services within a single object. But here the external client is not directly dealing with the service, which we have seen till the last lab. We was accessing the service on a specific port. But once you will in place the Ingress controller, external client or the client is not directly dealing with the service, they are dealing with the service via Ingress controller. So Ingress controller is object between the client and the services, and it is providing a abstract interface to manage the more secure traffic and provide some additional functionality between the client and service connectivity. Apart from the NodePort service, Ingress is capable of many more things. So as a one way, whenever the client connectivity is open for the service, that is a NodePort service or the load balancer service. So definitely the NodePort service is going by Ingress if Ingress is in place. But apart from the NodePort service, Ingress is capable of many more things like Ingress provide the SSL termination at Ingress level. Ingress also provide the load balancing features, and Ingress also provide the name-based virtual hosting. Name-based virtual hosting means you can define the different services for different resource path. We will discuss about it. First, let's see the Ingress controller. So in order for the Ingress resource to work, the cluster must have the Ingress controller running. Variety of the Ingress controller is available in the Kubernetes to provide the multiple mechanism for external access of the services. So like the multiple network CNI plugins are available for the Kubernetes, in the same way multiple Ingress controllers are available in the Kubernetes to provide the different mechanism between the connectivity of the service and the external access. User can deploy any number of Ingress controller. There's no limitations. You can deploy n number of Ingress controller in your Kubernetes. Basically, the Ingress controller or Ingress define a set of routing rules, and each rule will have a specific path which is connected to a specific backend, and request matching to a path will be routed to the associated backend. So what we are saying that this is the Ingress controller, and within the Ingress controller you can define the multiple rules. So here we are defining a one rule. This is a one rule, right? Within this rule you can define the multiple paths. So over here you can see we are defining a specific path, and that path is basically connected to a specific service. So this test path is basically connected to a service named test, which is accessible on port number 80. So this is the Ingress. The API version is the networking k8s.io.v1. The kind is Ingress. Then we are defining the metadata, and within the specification, what we are defining? We are defining a rule. Within the rule, we are defining a path, test path. Then we are defining a backend service. So each rule has a set of paths. You can define the multiple rules over here, and each with a backend. It means each rule which have a path must have the backend. Request matching to a path will be routed to the associated backend. So here all the request which is matching with this particular path, they all will be routed to the test service. It means suppose you have a request like http colon, like your website name is www.testsample.com. Now you are defining a resource path like this, test path. So all the requests which will follow this particular URL, they will be basically entertained by the this particular service which is named test and which is accessible on port 80, right? So this is the Ingress controller. With the help of the Ingress controller, you can control the traffic flow of your Kubernetes service, and you can provide the resource path based traffic access to your client, and that all the requests will be served by your Kubernetes cluster. Then what is the named port? If service use the named port, it means within the service we can define the port name. And if service is using the named port, then Ingress can also use the port name to choose which port it will route the traffic. What I am saying, this is a Ingress and this is a service. Over here you can see within the service, this is the section which is basically for the ports. We are defining the port, and within the port we are defining the name which is nginx-port. That name must be matched with your port name within the service. Here we are using the service nginx service. It's my mistake. Basically over here the name should be nginx service instead of test. So let me correct it. This is not a test. The name is nginx-port, right? This is your service name. If service is using the named port, then Ingress can also use the named port. What is the benefit of this approach? So in future, if the port of your service is going to change but the name remains same, then you don't need to change the Ingress rule, right? Same Ingress rule will work. It just require the port name on which it want to route the traffic within the service. So in the coming lecture, I will show you a hands-on demonstration on the Ingress controller. Thank you, team. See you in the coming lab. Hello team, welcome back. In the last lecture, we have discussed some theory and some concept of the ingress. Today we will see how we can actually implement the ingress and how actually ingress will work inside the Kubernetes cluster. For this, we have created some YAML files. So I will describe each and every YAML file. Then I will show you how we can actually execute the ingress inside the Kubernetes cluster, and what is the benefit of the ingress over the load balancer and the NodePort. So team, over here I have created a folder called Ingress controller, and here I have few files. So first I will describe each and every file, then I will show you how we can execute these files with the help of the ingress, and what is the use of the ingress in Kubernetes cluster to access the services. So first I will show you nginx deployment YAML. So over here I have created a simple YAML file. What this particular YAML or the manifest file will do, this will create the deployment of the nginx, right? So you can see I'm using the API version apps v1. The object type of this particular manifest is the deployment. Then I'm taking the metadata. The name which I'm defining of my deployment is nginx official deployment. It means I'm going to use the nginx official image. Inside the specification, I'm defining only one replica. If you want, you can increase the number of replicas over here. Then I'm defining selector, and inside the selector I'm defining match label, and match label will be app nginx official. So this particular will execute a single replica of app which have the label this. After this I'm defining the template of my pod, the metadata, labels, and label should be app nginx official. This is the same label which I have defined over here inside the selector, right? We have already discussed about the labels, selectors, and each and everything. Now inside the specification I'm defining the definition of my container. So I'm defining the name of my container is nginx official, and I'm using nginx latest image, and my container will basically execute on port 8080. So what I will do, first I will copy this complete content, go to my terminal, put ls. Then we can see we already have many files over here. So what I will do, I will create a new directory mkdir and call it ingress controller. Right now I will go to ingress controller, put ls. So I don't have any file inside the ingress controller. What I will do, I will keep all the files which I'm using in this particular lecture in this particular directory. So I will create a file called nginx deployment.yaml. If you want, you can use any name. I'm just using this so that it will be more clear to us which is nginx official and which is nginx custom. Now I will paste my content over here. I will save my file, put ls. Then you can see my deployment file is being created. So what I will do, I will clear out my console and I will execute that particular deployment file. So kubectl create -f and define your file name, which is nginx deployment.yaml. What this will do, this will create the deployment with this particular name, nginx official deployment. Now if we will execute a command kubectl get deployment, then we will see my deployment is running. The name is nginx official deployment. Suppose if I want to describe this particular deployment, I can execute a command kubectl describe deployment and define my deployment name. Then we can see scaled up replica set nginx official deployment this to one. It means the controller, it means the container is basically running. I will clear out the console and I will again go back to the Visual Studio. So I have created the deployment which is using nginx official image, right? In the ingress definition, we have learned that ingress will talk to the service and service will talk to the deployment. So what is my next job? My next job is create the service for this particular deployment. So I have created this particular service for my deployment nginx, right? Over here I'm taking the API version v1. The object type is service. This will be the name of my service. In the specification I'm defining the type. This will be NodePort type, right? If you are using AWS or GCP, you can define the load balancer as well. I'm using Minikube, so I'm using NodePort. I'm defining the ports, like it will access the application on TCP. The port on which the service will be accessible is the port 80, and the node port on which the service will expose the application is 31303. Over here inside the selector I'm defining the label of my deployment. See, app nginx official. This is the same label which I have used over here. Please make sure you will use the same label, otherwise this particular manifest will not identify for which particular deployment the service needs to be created. So I will copy this, go to my terminal and create a file nginx deployment -service.yaml and paste my content over here. Now I need to execute the service. So kubectl create -f and define the service. So what this will do, this will create the service for me, right, on which the nginx will be accessible. If you want to verify the service, you can verify it. Now we have done this much of work. We have created a deployment and we have created a service to access that particular deployment. Now what we will do, I will create another deployment and my deployment name will be magical nginx deployment, and over here I will use the magical nginx image which I have created few lectures back, right? That was the nginx image in which I have my own content. So over here I am defining the deployment manifest apps v1, object type is deployment, the name of the deployment will be magical nginx deployment. This will use the single replica. Inside the selector, I am defining the match label app magical nginx, and the same label I am taking inside the template. The only difference is I am taking the custom image. I am taking the custom image Anshul DevOps magical nginx latest, right? And this will also work on port 8080. I will copy this, go to my terminal, create a file magical nginx deployment dot yaml, and I will paste my content over here. So what this will do, this will create the another deployment, but this particular deployment will use my custom image instead of the official nginx image. Let's create the deployment kubectl create -f magical nginx deployment yaml, and you can see the deployment is being created. In the similar way, I will create the service for my magical nginx as well. So I have the same definition API version v1, object type is service. The only difference is I'm taking the selector which is the selector which is the label of my magical nginx, right? I will copy this, define vi magical nginx deployment -service dot yaml, paste the content over here. Now execute this kubectl create -f magical nginx service. What this will do, this will create the service for my second deployment. So we have the two deployments running on this particular minikube cluster, and we have two services running on this particular minikube cluster. Let's clear out the console. If you will execute a command kubectl get services, then you can see three services are running. One is Kubernetes, this is the default minikube service, and these two are my own custom services. If you want to access the deployment on any service, you can simply execute a command minikube service, define your service name which you want to access. Suppose first I want to access my magical nginx -URL. This will display the URL on which the service will be accessible. If I will copy this URL and execute a command curl this particular URL which is using 31304. 31304 is the same port which I have defined inside my YAML file, right? This is not randomly generated. Then you can see I'm able to access my complete HTML page. HTML head title, your title is here. Then I'm getting the custom data over here, like enroll now, the coupon code is this $10, and I'm getting the custom data like this DevOps certification training course will be prepared for you career DevOps, like this, right? We have seen that particular thing in the earlier lectures as well. What is the use of the magical nginx image? Let's clear out the console, again execute the list of services, and now suppose you want to access the service nginx official service. I will copy this, execute the command minikube service, define your service name -URL, then this will expose on 31303. See, this is exposing on 31303. If you will curl this, then this will display the content of your default nginx. See, welcome to nginx. If you see this page, the nginx web server is successfully installed. This is the default nginx. So we are using two services, we are using two deployments. Both of the deployments is running both different images. First deployment is running official nginx image, and second deployment is running nginx custom image, right? Now the question is, we have deployed the services, we have deployed the deployment, how we can deploy the ingress to access these particular deployments over the service. For this I have created a separate YAML file. So over here I have created an YAML file called ingress controller.yaml. This is the API version. You can get that particular API version from the official Kubernetes site, right now the API version which is being used inside the ingress is networking.k8s.io v1 beta 1. Earlier this the API version was extension v1 beta 1, but right now this is being changed 2 months back, right? Now we are getting the kind, the object type is ingress. Over here I'm defining the metadata. This will be the name of my ingress nginx rules, right? We have discussed that inside the ingress we need to define the rules. So inside the specification I'm defining the rules. This is my first rule, that host will be nginx official example.com. This will be my host name. And what this host will do, this host will access an HTTP request which have the path, the root directory path, and inside the backend I'm using the service nginx official service. This is the same service which is being deployed with the nginx official image, right? And this service will be accessible on port, and this service will accessible on port 80. See, the service is accessible on port 80. In the similar way, I have the second host. The host name is magicalnginxexample.com. Over here, you can see I'm defining the complete DNS, right? To access my service, I'm defining the DNS, and that DNS is basically bind with my service. Right here, I'm not defining any IP of my load balancer. I'm not defining any port with attached with my node port, right? I'm just defining a single DNS and defining the rule for that particular DNS, that where that particular DNS will route. So this will route on HTTP. The path is at root directory, and backend service which is accessible is the magical nginx on port 80. This is the same service which I have executed for the magical nginx. See, right? This is the complete definition of my ingress controller. I will copy this, go to my terminal, create command ingress hyphen controller dot yaml. You can name it anything, right? I just name it ingress controller to make it clear. In the similar way, kubectl create -f ingress controller YAML. And you can see we are getting a message nginx rules is being created. If you will describe this, you can execute a command kubectl describe and define your, and we are getting some error. Okay, execute a command like kubectl describe ingress and define the ingress name. See, I'm getting the complete information. This is the name of my ingress. The namespace is default. The default backend is default HTTP backend 80. This is the IP on which the default will be accessible. Then this has the rule which have two hosts. The first host is nginxofficialexample.com, which is accessing the path, root, and this is the service and this is the port. C, right? And second host is magicalnginxexample.com, which is also accessible the root path, and this is the service and this is the port where it will create, right? Over here we are getting the event that this is being created 25 seconds ago. Now we can access both of my container on the basis of this particular host only, right? Let's see how we can do it. Clear out the console, execute a command minikube IP. This will return the IP of your minikube, which is 192.168.99.100. Now execute a command curl, define this particular IP, define hyphen capital H space double quotes, define host colon, and define the host which you want to access. So suppose I want to access my official nginx first. This is the host name which I have defined for the official nginx, and hit enter. You can see you are getting the content of your official nginx. I'm not defining any IP, I'm not defining any node port, I'm just defining the IP of my current server and defining the host which I want to access. If the same thing you are executing on the Kubernetes cluster which is accessing over the GCP or over the AWS, and you have enabled the inbound traffic on your EC2 instances, then you can access your application by simple this particular domain, right? Hit this particular domain over the internet and you will be able to access your service. You don't need to put any IP or anything else. I'm just accessing the HTTP request on a terminal so that I'm executing the curl command or the curl utility. Let's clear out the console, and suppose we want to access the magical nginx image. So I can simply put this particular host, right? I can simply remove the nginx official host and put the magical one, and you can see I'm getting the magical one. By this particular example, we can easily understand that how the ingress is working. We are accessing the ingress from the external traffic, right? From the internet. Ingress is routing the traffic to the corresponding host. That corresponding host is routing the traffic to the service, and service is routing the traffic to the deployment, and deployment is routing the traffic to the pod is routing the traffic to the container. This is the complete life cycle which is executing inside the Kubernetes. This is so simple. This is not a tough, right? Although they have a lot of steps, but the implementation is quite simple, right? I'm repeating myself. Over the internet, I'm accessing the service by HTTP or HTTPS. That service is basically sending the request to the ingress, right? Ingress is identifying which host the user is trying to access, and that will send that particular request to host. Host will resolve itself on the service and the service node. Service will send the request to the deployment. Deployment send the request to the pod. Pod will send the request to the container, and container will fulfill the request because actual application is running inside the container. So this is the ingress inside the Kubernetes cluster. So thank you team. Thanks for your time. If you have any doubt, any question regarding this particular lecture, then please let me know. I will happy to answer your questions. Hello team, welcome back. Welcome to this new section about data storage in Kubernetes. And in this section, we will learn about the Kubernetes data storage management. Today, we will learn about an overview of Kubernetes storage. So we are going to discuss about the container file system. Then we will discuss about the volumes in Kubernetes. Then we will look into the persistent volumes, and then we will look into the volume type. So this is just an overview lecture and we will do a touch base on all these topics. So let's start with the container file system. The basic idea of container file system is very necessary whenever you are working with the Kubernetes storage, because ultimately pod is executing the container and you must be aware with the basic configuration of containers. So basically the file system or the files which are present in a container, that file system in container is ephemeral. It means the files in the container file system will only and only exist as long as the container exists. As soon as you will destroy the container, the file system within the container will also destroy. And whenever you will create the container again, the file system will be created again. So as I told you, data in the container file system is lost as soon as you will delete the container or recreate the container. In Kubernetes, container will basically execute within the pod. So here we have a pod and that pod is executing a container. Within that container, you will have the multiple files. You can have the file 1, file 2 and file n. As soon as this container or this pod will be recreated or deleted, the files which are present within your container, they also be lost. But sometimes you need the file to exist. So this kind of implementation is necessary. So this kind of implementation is helpful whenever you are working with the stateless application where you don't need to maintain the state of your application. But if you are working with the stateful application where the application need to maintain the state of application and the data which is generated by the application is very necessary and crucial part of your application, then this kind of implementation is not worthy, because the data which is generating within the application within the container, that is being removed as soon as the container removed. So there must be a solution to address this problem. And the solution which exists in the Kubernetes is the volumes. Many application needs a persistent data. Persistent data means the data will exist even after your application is recreated or deleted. Volume in the Kubernetes allow to store the data outside the container while allow container to access the data at runtime. With the help of the volumes, what you can do, you can export the container file system into the external storage. In Kubernetes, like you can demand the resources, CPU and memory in the same way you can demand the storage as well. So storage will be assigned to the container at runtime, and that external storage is not dependent on the container lifecycle. If your container is deleted or recreated, the external storage will be maintained, although the container file system will be recreated. So let's understand this. So here we have a pod. Within the pod, we are executing the container, and within the container, we will have the multiple files like file 1, file 2, and file n. Somewhere on my node we have the external storage, and what we will do, we will attach this particular external storage with the container by the volumes. Then the replica of these files which are present within the container, they will be created in the external storage itself. And this replication between the files is the real-time replication. It means as soon as the file will change in the container, the same file will be update or change in the external storage. There is very minimal replication delay between this approach, and this is almost real time replication. Whatever you will change in the container, the same thing will be changed in the external storage. The delay is as minimum, even you cannot identify the replication delay or the response delay in the external storage. We have discussed about the volumes. Then what is the persistent volume? So volume offer a way to provide external storage to container within the pod container specification, right? So we have already discussed that volume is a way. With the help of the volumes, what we can do, we can provide an external storage to the containers to replicate the file system, right? And that volume will be attached within the specification of your pods and containers. Persistent volume are a bit more advanced than the volumes. Persistent volume provide a bit more advanced functionality as compared to the volumes. Like persistent volumes allow user to treat storage as an abstract resource and consume it using the pods. It means like the pods and deployment, you can create the object or resource of persistent volume in the Kubernetes, and that resource will be attached with the container at runtime. Whenever you will define that resource in the or that persistent volume in the container spec manifest. So here we can understand the attachment of the persistent volume with the pod or containers. Here we have a pod, and within that pod we are executing a container. Within that container, what we can do, we can define the persistent volume within the specification. But to claim that persistent volume or to attach with that persistent volume, container need one more object that is called persistent volume claim. Shortly we will discuss what is persistent volume claim and how persistent volume claim will work with the pods. This persistent volume claim further contact with the persistent volumes. Persistent volume claim will check if the persistent volume is present or not. And that persistent volumes will finally attach with the external storage. So what happened at runtime? This persistent volume claim, right? That is a resource in the Kubernetes, and that resource will be attached to the containers, right? That resource, the persistent volume claim, the persistent volume is attached with the containers. That resource is an abstract resource. So as soon as you will delete your container, that resource is still present within the Kubernetes. And once this particular container or pod will be recreated, the same persistent volume will be attached to that container. But this persistent volume have some definition, some specification, that it will attach the fresh persistent volume or it will attach the formatted persistent volume. We will discuss about it shortly. So this is the way how Kubernetes will attach the external storage to the pods or containers via persistent volume. Then we need to understand that what kind of volume types are available in a Kubernetes. In the Kubernetes, there is a variety of the volume type, and we need to understand the use of each volume type. Volume and the persistent volumes each have a volume type. Either you are creating the volume or you are creating the persistent volume in Kubernetes. These volume must have a type, because that volume type will define how and where the volume will be attached within your pods or containers. Volume type determine how storage will be handled. There are multiple volume types supports in the Kubernetes, and first is NFS, which is network file system. Kubernetes supports the NFS or network file system volume. Another is the cloud storage. Kubernetes support the volume creation and the volume storage in the variety of the public cloud providers like AWS, GCP, Azure, and there are many more in the list. Another is the config maps and the secret. We have already seen about the config map and the secret, how we can attach the volume with the help of the config maps and the secret at runtime to the pods and containers. And another way is the file system on the Kubernetes node. It means it will create a file system on the node on which the container is or the pod is running. So team, this is the overview of the storage in Kubernetes. In coming lectures, we will learn about the volumes, persistent volume and the volume type, and we will also see the labs on all these topics. So thank you team. See you in the coming lectures. Hello team, welcome back. And today we will discuss about the use of storage in Kubernetes. We have already seen the overview on the storage, and today we will see how we can use that storage in Kubernetes. So in this lecture, we are going to learn about the volumes and volume mounts. We will also see the sharing volumes within the containers. And then we will discuss about the common volume types. And finally, we will see a hands-on demonstration lab on volumes, volume mounts, and sharing the volumes between the containers. So let's start with the volume and volume mount. So as we are already aware that volume is something which will help us to make the data persistent in Kubernetes. So volume is something that user can define within the pod specification. So if you have some storage volume available, you can define that volume within the pod specification, and whenever the container will execute as a part of that pod, they start using that particular volume, whatever you have defined in the pod specification. Volume specify the volume types and where the data is actually stored. Within the volume, you can define the volume name, the volume type, and the other parameters regarding the volume like size and retention policy. There could be the multiple things. And we will discuss all these things shortly. Then what is volume mount? Volume mount is a container specification. The volume is a pod specification and volume mount is a container specification. Volume mount within the container specification refers the volume in a pod and provide a mount path. So let's understand this with this simple manifest. Here we have highlighted the volumes and we have highlighted the volume mount. So here we are defining the pod. This is the name of your pod, and within the pod specification we are defining the volumes. You can see this is the volume. This has a name, sample volume, and a host path. This is a volume type, right? The host path is a volume type and the path is slash data. Then we have defined the volume mounts, and that volume mounts within the container specification. And over here, what is the name of your volume mount? That basically is referring the name of your volume and defining the mount path, which is the slash output. So what this particular specification will do, once you will execute this manifest, it will create a volume object called sample volume, which will associate with the slash data directory on your node, right? And once that particular volume will be mounted with the volume mounts within the container will create a output directory within the slash data directory on your host machine, right? And it will start using that particular directory. Once you will restart the container or you will recreate the container, the output directory which is present on your host machine, that will not be override. Only the container file system will be deleted. The directory or the data which is present on your host machine within the data output directory, that will not be deleted. Now let's discuss about the another volume type, which is empty dir. Right? What is empty dir volume? So basically empty dir volume is a dynamic volume that created when the pod is assigned to a node, right? And the empty dir persists as long as the pod running on the node. So in the earlier manifest we have seen, we have defined the host path. Similar to the host path, you can also define the empty dir. That is a dynamic volume creation. Kubernetes will create a volume dynamically whenever the pod will start, and that volume will only and only exist until and unless the pod is running. As soon as you will delete the pod, the same dynamic volume will also be deleted. Then what is the benefit of the empty dir? Although this is following the same practice which container is following, container will also delete the file system once it destroy. Though the same thing is happening with the empty dir, it is destroying whenever the pods is destroying. So what is the benefit of the empty dir? The benefit is multiple container can refer the same empty dir volume. It means whenever you are creating the empty dir volume within the pods, that empty dir volume is shareable. That will be shared between the multiple containers which is the part of that particular pod. It means multiple containers in the pod can read write the same file in the empty dir volume, though the volume can be mounted at the same or different path in each container, right? It means within the same pod you can define the multiple containers, and all these containers can refer the same empty dir by this particular functionality. All these containers can refer the same file system. It means the file system is basically shared between the containers, and this approach have a multiple benefits. We will discuss about it. First, let's see the manifest definition of the empty dir. So over here you can see we are defining the volumes, and within the volume we are defining the name of my volume, which is cache volume, and then we are defining, instead of the host path, we are defining empty dir and curly braces. The same volume will be used with the volume mounts like this, right? There is no change in the volume mount, but the only change is the type of volume is changed. Let's discuss about the sharing the volume. So as I told you that empty dir is a volume which will be dynamically created. It means user can use the same volume mount to share the same volume to the multiple containers within the same pod, and that is the empty dir volume. This is a very powerful feature in Kubernetes, right, which can be helpful in the multiple business use cases. I'm just taking one example where you can transform the data of one container, where your container 1 can generate the data and container 2 can transform that data to some other form. So you can use these kind of approach in the data processing, data mining, and multiple business needs. Host path and empty dir, both volume types support the sharing volumes. So it is not necessary that only the empty dir is the sharing volumes. No, host path is also the sharing volumes. Here is the sample manifest which I created for the sharing volumes. You can see here we are creating a volume called volumes name cache volume empty dir. Then my container one, which is PV recycler, that is using that particular volume, and that is mounting the path cache in that particular volume. Now I have the container 2, which is PV recycler 2, and that is also mounting the same volume, but this time the mount location is changed. That is mounting the volume in the cache temp, right? Shortly I will show you the practical lab on it so that it will be much more clear how these things will work and how these things will be helpful in the runtime business needs, right? But this is the way how you can create the volume and how the volume will be shared between the multiple containers within a single pod. So team, that's all about the volumes, volume mounts, and the sharing volumes. In the coming lectures, we will see a lab or hands-on demonstration on the volume, volume mount, and the sharing volumes. So thank you team. See you in the coming lecture. Hello team, welcome back. And today we will see a hands-on demonstration on host path and empty dir. We will see how we can create the volumes and use the volume mounts with the host path and empty dir in Kubernetes. So very first, let's go to the Visual Studio Code and understand the manifest for host path. Then we will execute the manifest in Kubernetes and see the actual implementation. So team, here I have created a sample manifest named hostpath volume mount.yaml. You can see this is a pod kind of resource. The name of my resource is hostpath-pod. Within the specification, I'm defining the volumes first. So in this volume first, I'm defining the name of my volume, which is hostpath-volume. Then we are defining the type of my volumes. This time the type is host path. So we need to define the path of this particular volume. Please make sure this is the path which will present on your Kubernetes node, right? Once I will execute this particular pod, then this is the path which must be exist on my Kubernetes node. Then we are defining the containers. Within the container, I'm defining the container name, which is again host path-pod, or you can change it anything. Over here I'm using the image which is busybox image. Then I'm using a command in this image, and what this command will do, this will execute a shell command echo, and this will print a statement, hello team, this is sample file for host volume and the date into a particular directory output.txt. Then you can see I'm using the volume mounts, and within the volume mount I'm keeping the name, and name of my volume mount is same as my volumes, and this I'm mounting at a path slash output. So this is the sample host path volume mount YAML. What I will do, I will copy this. So I am in my Kubernetes cluster, single node cluster, which I'm using right here. I will create a directory mkdir k8s.storage. I will go to this directory which I just created, and here I will create a file vi host path volume pod.yaml, and I will paste this YAML, right? So we are hosting that particular volume output into a local directory or node at a particular location var temp. I will save this and first verify if var/temp is present on my box or not. So /var temp. Yes, this directory is present on my box, and right now over here we have few files, minikube and some random generated directories. Now what I will do, I will create kubectl apply -f host path volume.yml. Oh, right now I'm inside the temp, so I need to go to the directory which is kate_storage, right? And here I will execute a command kubectl apply -f, and now I will provide my YAML file name which is host path volume_pod.yml. Hit enter. So there is some kind of error, and I believe that is related to the YAML formatting. So here is my YAML. I will format this first. So there is an indentation error, and I believe the command should be at the same level of image like this. I will again copy this, update the file, and now I will save the file. Let's execute the kubectl apply again, and you can see the pod is created. The pod host path pod is got created. Let's list out the files present at a location which we have defined at a node level, which is var temp. So I will go to ls var temp, hit enter, and over here you can see one more file is got created named output.txt. This file was not present earlier, see, but this is created recently. If you will cat this file var temp output.txt, then we can see in this file the same line is being printed again and again. Hello team, this is sample file for host file. Then it is printing the timestamp, right? You can see over here we have printed the same thing. Let's get this again, and we are getting one more time. Why this is printing again and again? Because if you will describe your pod, the container is restarting. And why the container is restarting? Because we have not defined any restart policy. And as soon as the container is completed, it will restart your container. If you will again get the file, you will get the more data. Now let's do one thing. Let's delete your container. So I will execute kubectl delete host path YAML. Hit enter. Oh, I need to define -f as well. And you can see the pod deletion is in progress. Let's wait until the pod deletion will be done. The pod deletion is done. Let's clear out the console and verify the var temp location again. So I will execute ls var temp. The output.txt is still present. And if you will open this file, I will open cat output.txt. You can see the file data is still present. So by this way, with the help of the volumes, you can persist the data which is being generated by the containers. And now once again, whenever you will start the same container or the same pod, let's start the pod again, you will see the same file output.txt will be referred in this pod. If you want to see, I can show you. If you want to check, I can show you. Let's execute the cat again and see. We are getting the earlier data as well and new data as well. This is the last line earlier in this particular file, but these are the new entries, and these 4 or 5 are the earlier entries, right? So you can see whenever we are restarting the pod as well, even we are deleting the pod and recreating the pod, the same file which we have mounted, that is being assigned as a file system in the containers, and container is starting by reading this particular file from the temp.txt. So this is the way how you can mount the container file system on the host machine using the host path. Let's clear out the console and delete your container. Now we have seen about the host path, and we have seen that even we are destroying the pod, even we are deleting the pod, but the mounted location persists. And whenever we are recreating the pod, the same mount location will be assigned as a file system in the container. So if you want to reuse the data, you want to work with the stateful application, these are the approach which will work for you. Now let's see and look into the another approach, which is empty dir. So here we have created the empty dir volume file. We created a pod. The pod is redis. The name is redis-empty dir. Within the specification, I'm defining the container, and in container specification, I'm defining the name of my container, which is Redis. Image, I'm using the Redis image. The volume mounts, I'm using the volume mounts Redis hyphen storage. You can see for with the same name, I'm creating a volume, and you can see with the same name, I'm creating a volume over here, and this volume is the empty dir. It means this is a dynamically created volume, and the mount path, what I'm defining is the data slash Redis. Let's copy this file, go to your Kubernetes cluster and create empty dir hyphen pod or empty dir volume pod .yaml. Hit enter, paste it here, and save your file. Now let's do one thing. Let's execute your empty dir volume.yaml. So you can see there is a difference. We are not defining any host location to mount this location, right? That is the difference. So this empty dir will create a location dynamically on the host machine. So I will do kubectl apply -f empty dir volume.yaml. You can see the pod is created. If you want to describe this, you can describe like kubectl describe, define your pod specific, define your pod name, and here we are getting the status that started the Redis container. We are getting the other information as well, that these are the mounts from the Redis storage, and the volume is a empty dir, right? Size limit is unset, and these are the other information. Now let's do one thing. Let's clear out your console, execute a command kubectl get pods -o wide, and we have only one pod running in my Kubernetes. Let's exec this particular pod, kubectl exec -it, define your pod name, Redis empty dir. What we are doing, we are going inside this particular pod. Execute the command bin bash. Hit enter, and you can see we are inside the root Redis empty dir. It means we are inside the pod. If you will put ls, we have the Redis. Let's go to the Redis. ls, we don't have anything. What is the volume mount we have created? We have created the volume is a data Redis. So what we will do, let's go to the /cd data Redis. Data, now I'm inside the Redis pod and I'm in a directory data Redis. Over here, let's execute a command and we will create a file. So we'll execute a command echo hello team and write a message, this file is created for testing. I will save this content in a file test file.txt. Hit enter. Now you can see the file got created. If you will put ls, the file is here, test file.txt. pwd, this is a location data Redis. Let's exit out your container, and I'm inside my Kubernetes. Let's go to the exec mode again and check if file is there. So we'll go to the Redis, put ls, and file is here. Exit out again. Now what we will do, we will delete this pod and recreate this pod. So I will execute the same command, kubectl delete -f empty dir volume.pod. It is deleting the pod. Recreate the pod again. Now the pod is deleted. Let's execute get pods -o wide. No pod is present. Let's recreate the pod. The pod is created again. Now what we will do, we will go to the pod again, exec redis empty dir bin bash, go to the directory redis, put ls, and the file is not present. So empty dir is a dynamic volume and it will persist as long as the pod is persist. As soon as you delete the pod, the data which is present within the empty dir is also deleted. This is not like the host path. So we have seen that the empty dir data will only and only persist until the pod is persist. Now let's do one thing. Let's open one more terminal, exit out from this particular pod, execute a command minikube IP. This is my IP, right? This is the IP of my cluster, and I will create a SSH connection with my cluster. SSH root @ my IP. Hit enter. Provide the password of my node, and I'm inside my Kubernetes cluster. You can see, right? Let's clear out the console. So I'm inside my cluster. Let's execute a command kubectl get pods -o wide, and I have only one pod running, which is empty dir. Let's do one thing. Let's start watching this particular pod. So I will start watching this pod. I will copy the pod name and execute a command kubectl get pod name, which is mtdir hyphen hyphen watch. So here is my one pod which is running, right? Pod is in the running state. That command is interactive command, so this will not terminate your session on this particular node. Now what I will do, I will exec my pod again. No change in my watch status. Over here we will go to the directory cd redis. Now within my pod, what I will do, I will create another file, touch test file2.txt. Oh, there's a mistake in command touch, put ls, and the file is created. There is no change in the watch status. Let's do one thing. Let's identify the number of process running within my container. ps-aux. So the ps is not found. So what we need to do, we need to install the ps package. What I will do, I will get apt get update. We will execute the apt get update first. It will update the packages within your container. Then we will execute a command apt get install proc ps. So you can see the package is installed. I will clear out the console. Now execute the ps-aux again, and we are getting the Redis process. So why we are doing all this stuff? I am doing all this stuff so that I can show you that whenever we will delete the pod, and only the empty dir will be deleted. If you are deleting your container, if you are restarting your container, destroying your container, then the empty dir will not be deleted. If you will put ls, the directory, the file is still present over here. So we are watching the pod over here, and as soon as we will kill the Redis process, you can see we have exit out from the container because container is got killed. And over here you can see there is no ready container, and we are getting the status is completed. Let's wait for a few minutes, and what it will do, it will recreate the container. See, going into the crashing loop back off and again getting the status running. So over here what is done, it just recreated your container, it has not recreated your pod. If you will go to your container again, see we are able to exit the container. Let's go to the Redis, put ls, and the file is present over here. It means until unless the pod is present, the empty dir mount is present. Over here, by killing the main process, we just terminated the container, we not terminated the pod. By a watch command, we can see the pod age is still 10 minutes, but the container of that pod got crashed in between and recreated. So it means it doesn't matter that container is restarting, deleting, or whatever happening with the container, but as long as the pod will persist, the data which is defined within the empty dir will also persist, right? So these are the two ways we have seen with the host path and the empty dir volume. So today we have seen a lab on the host path and empty dir volume. Team, if you have any doubt, any question, you can ask me. Thank you, team. See you in the coming lecture. Hello team, welcome back. In last lab we have seen hands-on demonstration on host path and empty dir. Today we will see a lab on shared volume. We will see how we can share the volume between the containers within the same pod. So before going with the Kubernetes execution, let's first understand the manifest file. So here we have created a manifest file for a pod, and that pod will execute multiple containers and use the same shared volume. So in the metadata, we are defining the name of my pod, and I will call it shared multi-container. Within the specification, first I'm defining the volumes, and I name my volume HTML. The volume type is empty dir. It means this volume will be created dynamically once the first pod will start. Within the container, we are defining two container. The first container is Nginx container, and second container is the Debian container. We are using the official Nginx image. Within the mount volumes, we are referring the volume which we created HTML, and we are mounting a location user share Nginx HTML. If you remember, then at this particular location, we got a file index.html. Index.html is a default file which you will see whenever you will create the Nginx container and you will curl that particular container or curl that particular pod. So in previous lab, we have multiple times executed the nginx container or nginx pod, and we tried to access the nginx pod. Then on browser, we got a page, welcome to nginx. At this particular location, user shared nginx HTML. You will get that particular file which will display on your browser, and that file is index.html file. We are mounting this particular location from nginx container to this particular volume, which is a empty dir volume. Then we are creating the another container. The image we are using the Debian base image. It is also referring the same html volume, and the mount path what we are using over here is the html. Then we are executing a command. Then we are executing a shell command. You can see this is a shell syntax and -c for the command, and this is the command what we are executing. We are executing a loop while true do date, and that date is appending in a file html index.html. Sleep for 5 seconds and again repeat. So what it will do, it will print the current date in the index.html file after each 5 seconds, right? And that index.html is present within the container at this particular location, and that location is basically mounted in the shared volume. So what actually is happening over here, in real time, nginx index.html file will be replaced with this particular file. And why that file will be replaced? Because this is the container location which is mounted at this particular volume, and at the same at the same volume we are creating another index.html file, right? So that file will be overridden, and once you will try to access your nginx, you will get the content of this particular file instead of the nginx html file. Let's copy this and go to your Kubernetes cluster. Within the Kubernetes cluster, we will go to the directory create as storage, and here we will create a file common volume-pod.yaml. Over here we will paste this content and save my file. Now what we will do, we will execute this particular YAML file. So we will execute kubectl apply -f common volume pod.yaml. The pod is created. See, the pod named shared multi-container is created. I will copy this. Now what we will do, we will describe this pod kubectl, describe the pod name. Oh, there's a mistake in the kubectl. Hit enter and see, we are getting the complete description. This is the IP of my pod. Here first the nginx container is running. This is mounting this particular location at mount location html. Then the Debian is running and it is mounting, and it is also mounting the html location as the html mount. What I will do, I will clear out the console and get the number of pods running in my Kubernetes. Here is the IP of your pod. Let's try curl and your IP of your pod. And see, we are getting the date content. What the Debian container is basically printing within the index.html. Although at this particular IP, we are accessing the nginx container. Why? Because nginx container is the web application which is accessible on port 80. Debian is not a web application, but we are getting the data of my Debian container. Why this is happening? This is happening because both of the container are sharing the same volume path and they are reading the same file. The file which is being overridden by the Debian container, nginx container is basically reading that particular file because this particular location is mounted with the HTML. If you want to confirm, I can show you. So execute a command kubectl exec -it, define your pod name --bash. Oh, we need to define the double hyphen over here. We are inside the pod. Now it is saying that default container is the nginx container out of nginx and Debian container. So within the nginx container, if we will go to a directory user nginx html ls, you can see index.html file is over here. If you will append something in this particular file, so let's append something. So we will put echo custom statement, and I will append that particular statement within this file index.html. that is appended. If you cat index.html, see the custom statement is appended over here. Let's exit out your container. We are exit out and we are inside the Kubernetes. Let's try to curl the IP again and see we are getting that statement over here as well, and it's proved that the nginx is using the same file which is being written by the Debian container, right? Because they are sharing the shared volume. So team, this is the way how the shared volume work within the Kubernetes, and there could be the multiple business needs or runtime requirement of the shared volumes. I'm just sharing a basic example. So team, we have seen the implementation and use of the shared volume. If you have any doubt, any question, you can ask me. Thank you team. See you in the coming lecture. Hello team, welcome back. And today we will discuss about the persistent volume in Kubernetes. So we have seen few labs on the volumes, but persistent volume is an important concept, and we need to understand the persistent volumes, the persistent volume claims, and the related terminology. So we will start learning about the persistent volume. Today we will cover about the persistent volume, then we will cover the storage classes, then we will cover the persistent volume claims, and then we will see resizing of persistent volume claim. So let's start with the persistent volume. What is persistent volume? So persistent volume in Kubernetes is an object which allow user to treat the storage as an abstract resource. So till date we have seen the volume mounts and we have seen the volumes. So volume and volume mounts are basically the specification which we have defined within the pod specification and the container specification. But persistent volume is altogether a Kubernetes object, which is a Kubernetes object like the pods, services, deployment, replications, right? And it will provide the storage as a resource to the pods. Persistent volume is a resource in the cluster, just like the node is a resource in the cluster. Persistent volume use a set of attribute to describe the underlying storage resources, like it is a disk storage or it is a cloud storage, which further will be used to store the data. With the help of the persistent volume, you can define the storage either on the local disk, it means the Kubernetes node disk, or either on the cloud disk. There could be the multiple flavors available in the persistent volume. You can create the external disk with the multiple public cloud providers. So here is the sample manifest for the persistent volume. You can see the persistent volume is not defining in any kind of object like the pod or the container. That is altogether a separate resource in the Kubernetes. Like we define the pods, services, replication, we can create the persistent volume in Kubernetes. Persistent volume have their own specification like the metadata and the labels. Within the specification, you can define the capacity. Like over here, we are defining capacity storage 1 GB, and we can also define the access mode, which could be the read write only, read write many, read write once, like that. Then we are defining the persistent volume type. Over here, we are defining the host path type persistent volume. It means this persistent volume will be created on the Kubernetes node, and this is the path of your volume where it will mount the storage location. The storage class is an important factor in the persistent volume, and right now we are taking the storage class name as a local storage. We will talk about it shortly, but this is the way how you can define the persistent volume in Kubernetes. And persistent volume is altogether a new resource or new object in the Kubernetes, that is not just a specification syntax for the Kubernetes pod and other resource definition. Within the persistent volume, we have used the storage class names. So let's understand the storage class. What is a storage class in Kubernetes? So storage class allow the Kubernetes administrator to specify all type of storage service they offer on their platform. So as I told you, you can create the persistent volume with the multiple types. You can create the local disk, or you can create the persistent volume on a multiple cloud services. But somebody need to control that where the user is creating the persistent volume, right? And that control is given by the storage class. The Kubernetes administrator can specify all type of storage services which is supported within your Kubernetes cluster, and that thing is being done by the Kubernetes storage class. So here is the definition for the storage class, and you can see storage class is another Kubernetes object which is on the API version storage.k8s.io v1. Within the metadata, you can define the name of your storage class, and within the provisioner, you need to define the provisioner where this storage class will be provisioned. Whenever you are defining the no provisioner, it means this storage class will be provisioned on your local machine. It means on your Kubernetes cluster node where this particular object is created. Volume binding mode wait for first consumer. Volume binding mode means whenever this particular volume, the storage class, whatever we are creating, this will be bind with the pod. So here we are defining wait for first consumer. Once the first pod will be created, which refer this particular storage class, once that particular pod will be created, only and only this particular storage block will be assigned to pod. Until that particular storage block will not be reserved. In the similar way, we can define another kind of storage class. Suppose admin could create a storage class called slow to describe the inexpensive storage for general development use. Your development team want to create the multiple pods, they want to create the multiple instances of your application, and your application have a need of the external storage. Then in that case, the Kubernetes administrator need to make sure that the storage will be available, and the storage whatever we are using for this particular kind of use, that will be inexpensive. So you can create a storage called name slow or something like that, and you can create that particular class on a cloud storage. So over here we are defining the syntax for AWS EBS class. You can see the kind is storage class. Within the metadata we are defining the name, then we are defining the provisioner AWS EBS. To start with this class, you need to install the plugin in your Kubernetes cluster, and you need to authenticate your Kubernetes cluster with the AWS plugin. Then we are defining the parameters. The type of the disk will be IO1. The input output operation per GB performed will be the 10, and FS type, which is file system type, will be ext4. Similarly, if we want to create some fast kind of disk for the input output operation of replication in some kind of performance environment, we can create the storage class like this. Here we are defining the another syntax. Although you can define the same storage class on the AWS, but we are defining the another syntax for the GCP, so that you will be aware that what kind of storage class you can provide in the Kubernetes cluster and what could be the syntax look like. So here we are defining another storage class named fast. The provisioner is Kubernetes IO GCEPD. It means persistent disk on the GCP. Then we are defining the parameter type, which is a disk type, which is PD-SSD, and allowing topology failure domain beta Kubernetes zone. And this disk will be created in a zone US Central 1A. So we can create the persistent volume, and within the persistent volume, we need to define the storage class. And by this, we can create the storage classes. Then within the storage class, you will get an option allow volume expansion. What is this allow volume expansion? So allow volume expansion field is accept only boolean value. It will accept either true or false. And this property of the storage class will define whether the storage class supports the ability to resize after they are created. So once you will create the storage class, this property within the storage class will define that storage class is resizable or not. All cloud disks supports this property. So all the public clouds which are supporting the storage class functionality in Kubernetes, they supports this allow volume expansion property. The syntax of this will look like this. Over here you can see the tag allow volume expansion we are highlighting, right? And that needs to be true if you want to resize your storage class in future once that is being created. There's another term called reclaim policy. What is the reclaim policy? So persistent volume reclaim policy, this defines how the storage class will be reused when the persistent volumes associated with the persistent volumes claims are deleted. So we have not discussed about the persistent volume claims. Over here the PVs are denoting the persistent volume, and PVCs are defining the persistent volume claims. Shortly we will discuss about the persistent volume claims, but as I told you in the storage overview that the external disk is attached with the pod with a persistent volume claim, which will attach with the persistent volume. So what happen? So this property persistent volume reclaim policy will define that what will happen with the storage class, right? What will happen with the storage class once the persistent volume claims are deleted? There could be the three options. First is the retain. It means keep all the data. The storage class will keep all the data. If the persistent volume claim is deleted, the storage class will keep all the data, and it all depends on the Kubernetes administrator that they need to clean up the disk before its reuse, or they want to keep it like that. The second is the delete. It means delete underlying storage resource automatically, support for cloud resource only. That supports for the cloud resource only. It means once the persistent volume claims are deleted, it will delete the underlying storage resources as well. Whatever the storage resources is attached with the persistent volume claims, they also being deleted within a storage class. And third is the recycle. It means automatically delete all data in underlying storage and allow persistent volume to be reused. That is my favorite, and that is the most reusable reclaim policy. Whenever you are using the recycle, so whenever you are deleting the persistent volume claims, you are creating the persistent volume claims, it will simply delete all the data and reuse your persistent volume with a fresh disk. So here is the syntax look like. Within the persistent volume object, you can define the persistent volume reclaim policy. Right here we are defining the recycle. The last in this is the persistent volume claim. So we are discussing about the persistent volume. We have discussed about the storage class, which is directly associated with the persistent volume. But what is this persistent volume claim? So persistent volume claim is a request for storage by a user. So whenever user is basically trying to attach the persistent volume with the pod, with the resources, they can request that particular persistent volume via persistent volume claims. Without persistent volume claim, you cannot attach the persistent volume with your resources, either container or pods. Persistent volume claims define a set of attribute similar to the persistent volumes. And whenever you will assign the persistent volume claim with a resource and you will create that particular resource, the persistent volume claim by default look for the persistent volume that is able to meet the criteria what is being defined within the persistent volume claim. If that is not found the persistent volume, it will create a persistent volume automatically and bound that persistent volume with the resource. And here is the definition for the persistent volume claim, or the manifest for the persistent volume claim. Persistent volume claim again is an object in the Kubernetes that will have their own name and own specification. Here we are defining the persistent volume claim local storage. Once you will attach this particular persistent volume claim with your pod, first what it will do, it will try to identify the persistent volume which is matching with the same specification which is defined for this particular persistent volume claim. If it will find out the persistent volume, it will attach that persistent volume with the resource. Otherwise, it will create altogether a new persistent volume dynamically and attach that persistent volume with the resource. So we can understand this like this is my pod. We can call it pod 1. Now over here somewhere we have the cloud storage. Within the cloud storage, we have booked some kind of disk, and this disk is basically being booked by the storage class. Now what is the final objective? Final objective is this pod want to use this particular disk, right? So how the functional flow will be executed? So this storage class is basically attached with the persistent volume. Over here you will have the persistent volume. This persistent volume is basically attached with this particular storage class, and here what you will do, you will create a persistent volume claim. That persistent volume claim will be used by this particular pod. And once this particular pod will be created, what will happen, it will go for the persistent volume claim. This persistent volume claim will start search for the persistent volume on the basis of the defined policy. If it will find out the persistent volume, it will directly attach that particular persistent volume with this particular pod. But if it will not find out the persistent volume matching with the persistent volume claim properties, then it will create altogether a new persistent volume. It will create a dynamic persistent volume, and that persistent volume will be attached this particular persistent volume claim, and that will be attached with the storage class on the basis of the property. So this is the complete way how this thing will work. In the coming lecture, I will show you lab on the persistent volume and persistent volume claim. If you have any doubt, any question, you can ask me. Thank you, team. See you in the coming lecture. Hello, team. Welcome back. And in last lab, we have discussed about the persistent volume. Today, we will see a hands-on demonstration on persistent volume. We will see how we can create the storage class, how we can create the persistent volume and persistent volume claims, and how we can use these in a pod. So very first, we will start with a storage class manifest. So here in my Visual Studio Code, I have designed a YAML file or manifest file for the storage class. We are defining the API version, the kind of object, then we are defining the metadata, and we are defining the storage class name local-storage. Over here, the provision is no provisioner. It means this storage will be created on my local machine where I'm executing the Kubernetes. You can see the volume binding mode is waste for first consumer, and allow volume expansion is true. It means we can resize the volume if required. So what we will do, I will copy this and go to my Kubernetes cluster, and within the Kubernetes cluster we will go to a directory k8s storage, and over here I will create a file vi local volume.yml or local volume hyphen sc.yml. Hit enter. I will go to the insert mode and paste my YAML file over here. Let's save this and execute kubectl apply -f local volume sc.yml. And you can see the storage class local-storage is being created. If you want to get, you can execute a command kubectl describe and define your storage class. Over here we are getting the complete description that this is the volume binding, reclaim policy is delete, allow volume expansion is true, and this is the provisioner what we are using. Once you will create the local storage, what next we need to create? We need to create the persistent volume. So here I created the another YAML for the persistent volume. You can see the API version is v1, the kind is persistent volume. This is going to be the name of my persistent volume, my hyphen persistent hyphen vol, and the storage class what we are using is the local hyphen storage, which we just created. Right over here we created the local storage class. You need to remember one thing: if you are using this persistent volume and you are using this storage class, if this class is not default created, then persistent volume will create the storage class. Over here you can see the persistent volume reclaim policy is a recycle. We are getting a storage of 1 GB, access mode is read write once, and host path is var temp. I will copy this, create a file my persistent volume.yml, paste my content over here and save the file. Let's execute kubectl apply -f and define my persistent volume.yml. You can see the persistent volume is got created. What you can do, you can describe this. So I will execute kubectl describe the persistent volume, and over here we are getting the details of my persistent volume. This is a host path, the source is a host path, the path is this, and event is none. Capacity is 1 GB, read access mode is read write once, reclaim policy is recycle, and status is available. Storage class is this, and this is the name of my persistent volume. You can clear out the console and you can execute a command kubectl get pv-o white. Hit enter. Oh, that should be -o, not 0. Hit enter. You are getting the my persistent volume, the capacity, the access mode is RWO, and the reclaim policy is recycle. The status of your persistent volume is available and claim is still not present. This is the storage class which is in use, reason is null, and age is this, volume type is a file system. After this, what we will do, we will create the persistent volume claim. So here we have defined the persistent volume claim definition, which have the metadata, and in the metadata the name is mypvc. Within the specification, we are defining the storage class, which is local storage, the same thing. Access mode is read write once, which is like the persistent volume. And within the resources, we are requesting a resource of storage 100 megabyte. This persistent volume claim will fulfill the property of the existing persistent volume, right? Which is this. So this will not create the separate persistent volume, and it will use the existing persistent volume. So I will execute vi my-pvc.yaml and hit enter. Paste the file and save it. Let's execute kubectl apply -f mypvc.yaml. Hit enter. We are getting the error and it seems some error in my file. So I will open the file again, and yes, this M should be capital. This should be 100 capital MI. Let's save this and again execute the apply on your persistent volume claim. The persistent volume claim is created. Let's execute a command kubectl describe and define your persistent volume claim object. Like this, hit enter. Here we are getting the description that this is the persistent volume claim, the namespace is default. This is the storage class and the status is pending, right? The volume type is file system. The reason is waiting for first consumer, age is this, from persistent volume controller and waiting for the first consumer to be created before binding. Let's clear out the console and get the status of your persistent volume again. Over here we can see there is no change in this volume, and if we will execute a command kubectl get pvc-o void, then we are getting the persistent volume claim and status is still pending. Why the status is pending? Within the description we have seen that it is waiting for the first consumer to be created. So next what we need to do, we need to create some resource which will consume this particular persistent volume claim. So we need to define a pod. Over here I have created a sample pod. You can see this is a pod name will be my pv-pod. The restart policy is never. This is a busybox pod, and this is the command what we are executing as a part of this pod. Hello team, this is persistent volume claim, and this thing will be saved in a file which is present within the output directory, and file name will be success.txt. Within the volume mounts, I'm defining the mount path output and defining the name pod volume, and we are defining the volume with the same name. And within the volume we are dealing with the persistent volume claim, and within the claim name I am defining my vpc. This is the my persistent volume which we just created. So what I will do, I will copy this pod file and create my vpc pod dot yaml. Go to the insert mode and save it. Let's save your file. Execute kubectl apply -f my pvc pod.yaml. Hit enter and see the pod is created. Now let's get the status of your persistent volume and persistent volume claim again. So first I will get the status of my persistent volume, and over here you can see the things are a bit changed. See, the name is same, right? The capacity is same, the access mode is same, and the reclaim policy is also same. Over here you can see these things are similar, but the status is changed. Over here the status is available, but after creating the pod, status is bound. The claim was empty, but right now we are getting the claim default my vpc, right? Storage class is same, reason is same, and these things doesn't matter. So as soon as we created the resource which is using this particular vpc what we just created, right, then the status of my persistent volume is changed from available to changed to bound, and claim is also defined that this is being claimed by the default namespace, and my vpc is the persistent volume claim. Let's hit the enter and get the status of your vpc this time. and this is also changed, right? You can see earlier the VPC status was this, right? And this time the status is this. Earlier the status was pending, and right now we are getting the status is bound. The volume was empty. Right here we are getting the volume my persistent hyphen volume. The capacity we are getting 1 gig, and the access mode we are getting read write once. Rest other things are the same. So as soon as you create the resource on your persistent volume claim, the resource, the persistent volume claim and persistent volume will be updated. Now let's do one thing. Let's see if we can update the persistent volume claim. So we will execute a command kubectl edit pvc and define your pvc name, which is my pvc. Hit enter. And over here within the storage, what you need to do, you need to go to the storage, go to the insert mode, and you can change the storage size. I'm changing it from 100 to 200 megabyte, and I will save it. As soon as I save it, the persistent volume claim is changed, right? So we have already seen that how we can update the persistent volume claim, and we can resize the persistent volume claim. Now let's see what happen if we will delete the persistent volume claim. So first get the status of your persistent volume, then get the status of your persistent volume claim, and now delete the pod first, because pod is using that particular persistent volume claim. So kubectl delete -f my pvc-pod.yml, and now we will delete the persistent volume claim. Now we will get the status of persistent volume claim again, and status is still showing bound with my persistent volume. Let's delete your persistent volume as well. So kubectl delete -f my pvc.yml. This is your persistent volume claim file. Hit enter. Get the status of your persistent volume this time, and status is again changed from bound to available, because the reclaim policy is recycle, right? So this is the way how you can work with the storage class, persistent volume claim, and how you can use these resources within your pods, how the reclaim policy works, how you can update the persistent volume sizings as well. If you have any question, any doubt, you can ask me. Thank you, team. See you in the coming lectures. Hello, team. Welcome back. And in this section, we will set up the Kubernetes cluster on GCP. So we are going to set up a self-managed Kubernetes service on Google Cloud Platform. What does it mean by self-managed? Self-managed means we will set up the Kubernetes cluster manually. We are not going to use the Google Cloud Kubernetes service, which is called GKE, Google Kubernetes Engine. So Kubernetes is also available as a platform service in Google Cloud, in Microsoft Azure and AWS, where all the administrative work needs to be done by the cloud provider, and you just need to worry about your application setup. But today we will see how we can set up a self-managed Kubernetes cluster, where we have the more control on our Kubernetes cluster as compared to the Kubernetes as a service on public cloud provider. So today we will set up the Google Cloud account, and we will see how the Google Cloud account will look like. So first we will open the browser and we will search for the Google Cloud Console. We will get a link console.cloud.google.com. Once you open this link and sign in your account, you will by default render on this particular page. Here is the dashboard which will display your project information, your Google Cloud Platform status, some monitoring, billing and other things. From a Google Cloud, from here you can verify that what is the Google account you are using right now. And once you will set up the Google account first time, you need to submit your credit card details so that Google Cloud can start your billing account. Please make sure Google also provide the $300 free credit. So once you are creating a Google Cloud account first time, so for a practice, Google provide a credit of $300. So you can use that $300 credit in your account. The amount may be differ in your local currency, but the total amount is lump sum of 300. Within the Google Cloud, what we will do, we will spin up the VM instances. So you need to go to the compute and you need to click on the compute instances. So to create the server in Google Cloud, you need to click over here in the navigation menu, and you need to go to the compute section. Over here we are getting the compute engine, Kubernetes engine, and VMware engine. So here we are going to set up a self-managed Kubernetes service. So we will create the compute engines. If you want to create the Google managed Kubernetes service where the Google will do all the administrative work, then you need to go with the Kubernetes engine. In the coming section, we will talk about it. But today we will see how we can create the self-managed Kubernetes engine on GCP. So from here, you can see we are getting the multiple options, that we are getting the VM instances, instance template, and other things. I'm not going to explain each and everything over here. We will focus on the Kubernetes setup. You can do one more thing. You can click this pin icon so that the compute engine resource will be available in the recently visited items. Same thing you can do with the network. And over here, we are getting the application network, networking, and VPC network. Pin this as well, right? Because we are going to work on both of these items. Now you can go to the compute engine and click on VM instances. If the compute engine API is enabled on your project, then you will get a default page like this. Otherwise, it will render you on a API gateway page and it will ask you to enable the compute engine API. You need to enable that API. So once you will create the VM instances, they will be listed over here. From here, you can select your project and you can create a new project from here. Right here, I am working on the project Kubernetes-GCP, and this is the project ID. To work with the Google Cloud or to set up the Google Cloud machines, there are two ways. Either you can set up the Google Cloud SDK and authenticator on your local box, right? Or you can directly log in your Google Cloud and create the VM instances from the UI. You can see over here we are getting the options to create the VM instances or perform any other operations on the VM instances. So this is a basic overview of the Google Cloud Console and Google Cloud Shell. In the coming lecture, we will set up the self-managed Kubernetes cluster on Google Cloud with the help of KubeADM. So thank you team. See you in the coming lab. Hello team, welcome back. And today we will see how we can set up the Kubernetes cluster in GCP. For this setup, I have created some manual instructions and I will attach all these manual instructions in the next lecture so that you can also follow the same command. In this setup, we are going to create the 3 node setup where one node will be a control node or the master node and other 2 nodes will be the worker nodes. So let's open the instructions, and here I have documented all the instructions. These instructions will be available as a text direction in the coming lecture and you can follow the similar kind of commands. Now the question is where we need to execute these instructions. So you need to open your Google Cloud account. Once you will open your Google Cloud account, Once you will open your Google Cloud account, you need to select the correct project where you want to create the Kubernetes resources. In my case, I'm going to use this project Kubernetes-GCP, and this is already selected. Then I need to open the Cloud Shell. I will open the Cloud Shell and open the Cloud Shell in a new tab. Let's wait until the Cloud Shell will be ready. So my Cloud Shell is ready, and right now I don't want the UI editor, so I will close this and I will directly work with the console editor. You can see over here it is getting the my account @cloud shell. Then the project is already selected by default. Once you will open this Cloud Shell first time, it may possible that project is not selected. In that case, you need to execute this particular command gcloud config set project and define your project ID. Where we can get the project ID? We can get the project ID from here, right? This is your project ID. So let me open that command again. And the same is mentioned over here, set project ID in Google Cloud. So let me open that command again, gcloud config set project, copy the project ID and set it. So it will ask for the authorization. Click on the authorize and it is updating the properties. You can see the selected project will start displaying over here. Why we are doing this? We are doing this so that whatever the command we will execute in this Cloud Shell, they default execute in this particular project what we selected, right? They are not going to execute in other projects. Once you will set up the project ID, you need to set up the zone, right? We need to set up the compute zone where the compute instances will be created. So right here I'm executing a command gcloud config set compute zone and I'm setting a default zone US East 1B. If you want, you can choose another zone. You can go to the Google and you can search for the zones available in Google Cloud. So you can see the zone property is also updated, right? So we have selected two things. Now, next what we need to do, first we need to create the VPC. VPC means virtual private cloud network. So over here, if you will go to the Kubernetes cluster, open up your project, you can see this is my project. Go to the menu bar, go to the VPC network and click on the VPC network. So you can see a default network is available in the Google Cloud project, and these are the regions and the associated IP addresses. What we will do, let's minimize this. So we have only one network and 28 subnet in that particular network. What we are doing, we are creating a separate network for my Kubernetes cluster. So we will execute this particular command, G Cloud Compute Network create. This is going to be your network name. Then the subnet mode will be custom. In the Google Cloud, you can create two kind of network, the custom network and the auto network. Once you will set up the auto network, it will set up the subnet for your network. Once you will set up the custom network, it will not set up the subnet for your network. So we'll execute this command. Let's wait. Now we need to wait for some time, and we are getting a message created. The name of my network is K8s-cluster, right? And we are also getting some instructions that instance on this network will not be reachable until firewall rules are created. As an example, you need to create the internal traffic instances between the SSH, RDP, ICMP by running the below commands. Let's leave it right now and we will set up these things separately. So we have created the network. Now what we need to do, we need to create the K8s node subnet, right? This is the name of your subnet in this particular network which we just created. To create the subnet, what you need to do, you need to execute a command, G Cloud Compute Networks subnet create, define your subnet name, hyphen hyphen network, define your network name, and hyphen hyphen range. Over here you need to define the IP with the CIDR range as well, which will be the defined IP and CIDR range for this particular subnet. So I will copy this and put it here. Before this, you can verify if the network is created or not. So you can click on refresh. Let's minimize this and see K8s cluster network is created. The default network has the 28 subnet, but my network don't have any subnet. So we will copy this and paste it here, hit enter. Now it is asking that in which region I want to create my subnet. By default, it is taking Asia Southeast 1. If you want to create your network in this particular region, you can press Y, otherwise you can press no. So I am pressing no, hit enter. Why I am pressing no? Please make sure your subnet will be in the same region as you are going to create your machine, right? So I am going to create my machine in US East, right? So I will create the subnet in US East. For the US East, what we need to do, we need to choose a number 22. If you are going to create the subnet in some other region, you can choose the number accordingly. I will click 22, I will enter 22 and hit enter. Now it will create a subnet in my network K8s-cluster in the US East 1 with the IP range 10.240.0.0 CIDR block 24. You can see the subnet is created in a region US East 1, and this is the network, this is the IP range, and this is for IP v4 IPs only. If we will go back to the VPC network and refresh this, minimize the default, you can see one subnet is there in the region US East 1, and the subnet name is K8s nodes, and this is the IP range, and this is the gateway. If you want, you can open your subnet and you will get the subnet details from here. Let's go to the VPC again. Once you will set up the network, what we need to do, we need to create the firewall rule that allow the internal communication across TCP, UDP, ICMP, and IP to IP, right? The same message we was getting earlier. If we will go to the Cloud Shell, we was getting that message over here once we created the network. So what I will do, I will clear out the console and execute this command. To create the firewall, I need to execute a command, G Cloud Compute Firewall Rules create, define your firewall, define what kind of traffic we are allowing. So we are allowing TCP, UDP, ICMP, and IP. Within the network, we need to define the network name, and within the source range, we need to define the IP range. This is the same IP range which we defined for the subnet, right? So I will copy this, paste it here, and hit enter. This will create the firewall rule. You can go to your cloud console and go to the firewalls. Right now, the firewall rules are allowed for the default network only. You can see over here we are getting the default network type. Shortly, we will get the firewall for my custom network as well. So you can see the firewall rule K8 as cluster allow internal is created, and this is allowing for the TCP, UDP, ICMP and IP. Let's refresh this. Here we are getting the new firewall, right? This is the priority and this is the network. This firewall is created in the network which we created. If you want to open, you can open this firewall and you can review the properties. Once the firewall is created for the internal communication, as we are going to create the Kubernetes cluster which will use this network, so we will also have the external traffic. So we need to create another firewall for the external traffic as well, right? Which will allow the SSH, ICMP and HTTPS traffic. So we will execute a command G cloud compute firewall rules, create, define your firewall rule name and allow the traffic. We are allowing the traffic on TCP, TCP 2020, TCP 6443 and ICMP. This is the network, and this is the source range. Over here you can see source range is 0.0.0.0 with the setup block 0. It means all IP. All IP ranges will be covered in this source range. It means anyone can make the external call to this cluster. So I will copy this, paste it here and hit enter. This will create the another firewall for the external traffic. Let's wait, and it is saying the firewall is created. Let's go to the firewalls, refresh your firewalls again and see the external is also being created for the IP range 0.0.0.0 site range 0. Next, what we need to do, now we have done the network kind of setup. Because network is necessary to create the VM instances, now we will create the VM. First we will create the controller VM or the master node. To create the VM, we need to execute the commands G cloud compute instances create, define your instance name. I'm defining master -node. Define the async type of instance. Boot disk will be attached with this instance. The boot disk which will attach with this instance is 200 GB. That will also, it will have the IP forwarder ability. The image I'm using is the Ubuntu 18.04 LTS. It means long time support image of Ubuntu. The version is 18.04. The image project will be Ubuntu OS Cloud. The machine type what I'm using is the N1 standard 2. That is a 2-core CPU machine. The private network I'm using 10.240.0.11. That is the same network IP which I choose over here, right? Within the scope, I'm defining compute RW, storage RO, service management, service control, logging, writing, and monitoring. The subnet, I'm defining K8 as node, which we created upside. The zone, I'm executing this machine in US East 1B. And the tags which I'm attaching with my instance is the network name, the node name itself, and the controller. I will copy this, put it here, and hit enter. It will create the instance for me. Let's go to the cluster and open the compute instances, VM instances. So over here you can see the instance name master node is in the creation. This is in progress. And over here we are getting a message that this instance creation is in progress. See, the instance creation is in progress. You can directly click this link to identify the instance status, or you can go to the VM instances to verify the status. So the instance creation is in progress. We have to wait until the instance will be created successfully. The instance creation is done. You can see this is the name of your instance, the zone US East 1B, the internal IP which we defined, and external IP attached with my instance is 24.139.26.70. If you will open your instance, you will get all the details of your instance. This is the instance details. The machine type is N1 standard 2, which we chose. This is the network interface, K8s cluster, and the subnet is K8s-nodes. This is the image, right, which we chose, Ubuntu 18.04. By default, these access are disabled and these access are enabled. And this is a Google generated service account which is attached with my instance. We are not going to discuss about the service account, right? So we have created the master node. In the similar way, we will go to the instructions and we will create two worker nodes. For this, we will execute a for loop for 0 and 1. If you want to create 3 node, you can define like this. If you want to create 4 node, you can define like this. I'm just going to create the two worker nodes. The command will be same, G cloud compute engine create worker node. Worker node name will be dynamic, which will the worker node 0 and worker node 1. The similar instructions I'm going to execute with the worker node. I will copy this, go to my cloud console, clear out the console and execute this. Hit enter. It will create the two worker nodes. So you can see we are getting a message that creation is in progress for the first and creation is in progress for the second one. Over here you are getting the name as well, worker node 1 and worker node 0. If you will go to the VM instances, refresh your web page, you can see two worker nodes are also being created on IP 0.20.0.21. After that, what we need to do, we need to install the Docker on controller VM and each worker VM. For that, we need to execute these commands. It means we need to make an SSH connection with these machines. So Google provide a very nice way to create the SSH connection in your browser. For this, you need to click this particular SSH link. So this is going to create the SSH connection with your master. This is going to create the SSH connection with the worker 0. And this is going to create the SSH connection with the worker 1. So let's wait until the SSH connection setup will be done. So you can see I'm on my master node. The connection with worker 0 and worker 1 is still in progress. And we can see the connection is in progress with the worker 1 and worker 0. Let me zoom it a bit, right? I will clear out the console. So over here we have the master node. We will execute the commands, and these are the commands: sudo apt update and sudo apt install docker io. Let's execute these commands first. I'm executing on the master node. This will update the package and install the docker. Same command I need to execute on the worker node. This will update the package and install the docker, and same command I need to execute on the worker node 1. This will update the package and install the docker. Let's go to the master and install the docker io. Similarly, hit enter to install the docker io on worker 0, and similarly hit enter to install docker io on worker 1. So here is the setup for the master node. Master node installation is done. Worker node 0 installation is about to complete, and worker node 1 installation is also about to complete. Let's go to the commands again, and now we will execute rest of these two commands. So team, from here, from step 9, these are the same commands which we have seen in the earlier setup as well, where we have done the setup of my Kubernetes cluster on the DigitalOcean machine. The only difference is over here we are doing the setup on the Google machines, and earlier we have done the setup on the DigitalOcean machine. The command will be same, but the environment setup is different, right? Over here we need to create the network, then we need to create the firewall rules. These all things we didn't do in the DigitalOcean. So these are the extra effort which we need to put with the public cloud provider, and it may vary from cloud to cloud, right? Let's execute rest of the two commands as well. Execute on the master first, execute on the worker 0, and execute on the worker 1. So you can see on master it is completed, on worker 0 it's also completed, and on worker 1 it's also completed. Let's go and do the next step. It is saying install kubeadm, kubelet, kubectl on the controller VM and each of the worker VM. So we will again execute first two commands and execute on the controller first, then execute on the worker 0, then execute on the worker 1. On the controller it's completed. We will execute rest two commands, which is installing the kubelet, kubeadm, kubectl, and holding the all three versions. Let's paste it here, paste on the worker node 0 and paste on worker node 1. All the commands which we are executing over here, the all commands will be available in the coming lecture as a text direction. So you don't need to worry about it. So you can see only the installation command is executed. Other command is not executed. I will clear out the console and execute the other commands again. So we are getting kubectl and kubeadm kubectl are on hold. Do the same thing over here on the worker node 1. We are getting that all three versions are on the hold, and worker node 0 as well. We are getting that they are on the hold. Clear out the console. Now let's move with the next setup. It is saying create the controller node of a cluster and execute the below command on the master node. So over here you can see we are doing the initialization of my kubeadm. So we'll go to the master and do the initialization of my kubeadm. Hit enter. It is pulling the config images, and shortly it will do the setup. You can see the initialization is done, and it is asking to start your cluster, and you need to execute the below commands. right? What I will do, I will copy this and execute all three commands as well. It's done. Let's go to the console again. It is also saying to execute the same command, and on the worker node we need to execute the join command. So on my master node I'm getting a join command, kubeadm join, and there's a token. I will copy this command, the join command, and execute that command on my worker node 0. Okay, so we are getting a command that it is not running as a root user. So before executing the join command, you need to put sudo and then paste the join command. Hit enter and it is joining the cluster. Let's wait, and the join is done. On the worker node 1, let's put sudo and paste your command. It is joining the cluster and done. Now go to your master node, clear out the console and execute a command kubectl get nodes. Hit enter and we can see that one master node is the part of cluster and two worker nodes are also the part of my cluster, right? The status of my cluster is not ready. Can you guess why the status is not ready? Because we have not defined any network for my Kubernetes cluster. So we need to go to the commands again and we need to go further. So we have executed up to this point. Now on the control node we need to install the Calico network. So we will curl the Calico YAML first. On master node it is done, and on the master node we will apply that particular, and on master node we will execute that Calico YAML so that it will create the Calico YAML network. Let's hit enter and the network is created. If you want, you can execute a command kubectl get pods -n, which is namespace cube system, and see these are the pods which are running in my cube system. The Calico pods are still in the initialization. Let's wait, clear out the console. After wait 20 or 30 seconds, let's execute the get pod command again, and all the Calico pods are also in the running state. Now let's get the node status again. So we'll execute kubectl get nodes and see all are the nodes are in the ready state. So this is the way how we can set up the self-managed Kubernetes cluster in GCP. Why we are calling it self-managed? Because we have set up that cluster manually and we have full control on that cluster, that what needs to be executed, what could be the configuration of master, what could be the configuration of my worker, and if we want to set up any other extra plugin we can also do that kind of thing as well. So we have done the setup. Thank you team, see you in the coming lecture. Hello team, welcome back. Welcome to this new section, troubleshooting Kubernetes cluster. So in this section we will learn about the few basic concepts of troubleshooting the Kubernetes cluster. We will see if your Kubernetes cluster is not doing well, then how we can troubleshoot the Kubernetes cluster issues. We will also see how we can verify the cluster and node level logs. We will see how we can troubleshoot the application which are executing within the Kubernetes cluster. And we will also see how we can verify the container logs in Kubernetes. So if you are using the self-managed Kubernetes cluster, then troubleshooting is very necessary for the Kubernetes administrators, because you are managing your cluster and if anything is going wrong within your cluster, then you need to make sure to debug that issue and you also need to make sure to fix that issue. So the troubleshooting concept of Kubernetes are very necessary for the Kubernetes administrators. If you are working as a developer and you are not owning the Kubernetes cluster, then you can skip this section because these skills are required for the Kubernetes administrator who are managing the cluster. So thank you team. From the coming lecture, we will see how we can troubleshoot the basic problems within the Kubernetes cluster. Hello team, welcome back. And today we will see how we can troubleshoot the Kubernetes cluster and identify and eliminate the basic problems from Kubernetes cluster. As a part of this lecture, we are going to discuss about the Kube API server troubleshooting. Then we will see how we can verify the node status, and then we will see how we can check the system parts in Kubernetes. In last, we will do a hands-on demonstration on the Kubernetes setup which have a single master and two worker nodes. So as we are already aware that Kubernetes API server is the main part of the Kubernetes master plane, or that is also called the controller, because Kubernetes complete functionality work on the REST API, and if API server is down, then you hardly able to execute anything on your Kubernetes service, right? So if Kubernetes API server is down, user won't be able to use kubectl or kubectl interact with the cluster. In that case, you are completely blocked. So if your API server is down, generally user get these kind of errors. The connection to the server localhost 6443 was refused. Did you specify the right host and port? And the possible fix for this particular problem is make sure the Docker and Kubernetes services are up and running on your master node. So Docker and Kubernetes both are execute as a system service on your master node, and you need to make sure that if you are getting these kind of errors on the Kube API server, then both of the services should be running on your master node. If any of the service is in the failed state, you can restart that service to recover this particular problem. But if you are getting the error in the restarting as well, then you need to debug and fix the issue. How we can check the node status in Kubernetes? Actually, we have executed that command multiple times. So if you want to check that how many nodes are part of your Kubernetes cluster and what is the health status of these nodes, you can execute a very simple command kubectl get nodes. This will display the all nodes which are the part of your Kubernetes cluster. Also, it will display the state of these nodes in your cluster. User can use the kubectl describe node to get more information about the node. Suppose you have a multiple nodes as a part of your Kubernetes cluster and you want to get the information or you want to get the more details about your node. Then you can execute a command kubectl describe node and define your node name. If any of the node is having the problem, suppose the node is in the failure state or node is in the not responding or not ready state, it may be because the services or the Kubernetes services on that node is down. In that case, you can execute a command sudo systemctl status kubelet, and if this service is running, then you need to identify the networking. But if the service is in the failure state or in the stopped state, you need to start that service on the worker node. Each node which are the part of Kubernetes cluster run the kubelet and Docker services. So you need to make sure that both of these services, the Docker and kubelet, must be in the running state on each node which is the part of your Kubernetes cluster. You can check the service status using a command sudo systemctl status kubelet. Kubelet is a system level service, so you can get the status, right? If service is down, then you can start the service using a command sudo systemctl start kubelet, and you also need to enable the service. Why we need to enable the service? Due to any reason, if your node will restart or reboot, in that case the services which are enabled on your node, they must be auto started on the restart and reboot. But if service is not in the enabled state, then you need to manually start the service on that node. So we will enable the service on the Kubernetes node. Due to any reason in future, if that node is going to reboot or restart, so that all of the services will be available by default. And for that, you need to execute a command sudo systemctl enable kubelet. We have created the Kubernetes cluster using the kubeadm, and we have seen that the several component which are the part of your Kubernetes cluster, either the control plane node or the worker node, they execute within the kube system namespace. So we need to make sure that all of the pods in the kube system namespace should be in the running state. Over here, this command will list all the pods which are running in a namespace kube system, and hyphen n over here within this command is used to specify the namespace. If you want to get the details of the failed component, you can execute a command kubectl describe pod, then define the pod name hyphen n kube system. Over here, kube system is the namespace name. So let's create the connection with your Kubernetes cluster and let's see if we are able to create the cluster status. So let's make the SSH connection with your Kubernetes master node and verify few commands which we discussed today. So over here we are in the Kubernetes master node. Very first we will identify the status of my cluster. So we will execute a command kubectl get nodes, and you will see that there are the three nodes in this particular cluster. Two are the worker nodes and one is the master node. The status of each node is the ready state. Let's create a connection with your worker node. So over here in this second tab, we will create the connection with my one of my worker node. So I will SSH one of my worker node. So you can see this is K8s worker node 01. This is this node, right? Now let's verify the status of the Docker services and the kubelet service on my worker node. So we'll execute sudo systemctl status docker, and we can see the Docker service is in the running state. And here we are getting the other information that the process ID and the memory is being consumed by the Docker service. Similarly, we will press Ctrl C and verify the status of my kubelet service. So we'll execute the same command and replace the Docker with the kubelet. So you can see the kubelet is again in the running state. Let's do one thing. Let's clear out the console and stop the kubelet service. So we will stop the kubelet service on worker node 1. So we'll execute a command sudo systemctl stop kubelet, hit enter, get the status again, and we can see the status is not in the running state. The service is in the dead state or inactive state. Let's go to the master node and verify the status of nodes again. It is still saying the node is in the ready state. Let's wait for a few seconds and we will verify the status again. We will clear out the console and get the status again, and see it is saying that the worker node 1 is not in the ready state. Why the worker node 1 is not in the ready state? Because the kubelet service on that node is not active, that is dead. So if you are getting any node in the node ready state, then you need to make sure that the Docker and the kubelet services must be in the running status on that particular node. If you want to start that service, you need to execute a command sudo systemctl start kubelet, right? Get the status again, and service is in the running state. Let's press Ctrl C, clear out the console, and we also need to enable the service. So we will mention enable over here, right? Get the status again, and there is no change in the status of your Kubernetes or kubelet service. So this enable is basically enabled the service. We can get this over here, and what this enable will do, it will auto start my service on the reboot and restart of this particular node. Let's press Ctrl C, go to your master node and get the status again. Node is again back to the ready state. So if you are getting any issue within the nodes, then you can execute this particular command. Again, if you want to specify or describe some node, you can execute a command kubectl describe node and define the node name. Suppose I want to describe my worker node 1 like this. Hit enter. That should be kubectl. And you can see we are getting the complete state of my node. Here we are getting the status of my node, the role, the name, the labels, annotations, and we are getting the network unavailability, memory pressure, disk pressure, PID, and the ready state. We are also getting the system information that this is the Ubuntu machine, kernel version is 5.4073 generic. We are getting the kubelet version, we are getting the kubeproxy version, and here we are getting the other information about this particular node. So this is the way, if you want to describe any node or you want to get the status of any node, you can execute the kubectl describe command. Similarly, if you want to list out the pods which are running within the kube system namespace, you can execute a command kubectl get pods -n kube system, and these are the pods, and all pods are in the running state which are working or running in your kube system namespace. So these are the pod of the Calico network, these are the pod for the DNS, these are the pod for the DNS services, the etcd pod, and the kube API server pod as well. Here we have the kube controller, proxy, and scheduler. So these are the Kubernetes component pods which are running within the kube system namespace as a service or as a pod. If you want to describe any pod, so you can execute a command. First, let's get the number of pods running in the kube system. And suppose you want to describe this kube API server pod. So what we will do, we will copy this pod name and execute a command kubectl describe pod, define the pod name and define the namespace -n, namespace is kube system. Hit enter, and here you are getting the complete details about your kube API server pod, right? You can see this is the namespace, the name of pod, priority class name, start time, labels, annotations, the IP of your pod, and here we are getting the commands which you can execute with this particular pod. The command is the kube API server, and these are the commands which is work with this particular pod. Here we are getting the liveness probe, here we are getting the readiness and startup probe. We are also getting the volumes, which volumes are attached with this particular pod. So these are the volumes which are attached with this particular pod. So this is the way how we can describe any specific pod. So team, we have discussed almost all of the commands which we discussed today to troubleshoot the Kubernetes cluster. Thank you team. See you in the coming lecture. Hello team, welcome back. Hello team, welcome back. Welcome to Kubernetes training, and today we will see how we can get the cluster and the node level logs. So due to any reasons, if we are facing some issues in the cluster or if we are facing some issue in a specific node, we need to debug that particular node. We have seen few things in the earlier lecture to get and debug the node. Today we will see how we can get the logs of the cluster and the nodes. So we will try to get the service logs, the Kubernetes service logs. Then we will try to get the cluster component logs as well. We will see a very short hands-on demonstration on the service logs and the cluster component logs. So we are aware that on each node we have the two services which are very basic. First is the Docker service and the second is the kubelet service. If you want to get the logs of the Docker service or the kubelet service to identify the issue, then how we can get the logs of these services? For that, you can use the journalctl command. And to get the service logs, you can execute a command sudo journalctl-u and the service name. So if you want to get the logs of the kubelet service, you can execute the command sudo journalctl-u kubelet. And if you want to get the logs of the Docker service, similarly you can execute a command sudo journalctl-u docker. By default, in the self-managed Kubernetes service, the cluster component have the log output which redirect to a specific location where log. By default, the Kubernetes cluster component have the log output that redirect to a specific location where log. And you can easily get the API server, scheduler, and the controller manager log within this particular location where log kube API service where log, and the file would be look like where log kube API server.log, kube scheduler.log, kube controller manage.log. But we are using the kubeadm service, and we have seen multiple times that kubeadm is executing each and every component as a pod. API server, scheduler, DNS, network, everything is executing as a pod. So generally the cluster which set up by the kubeadm that don't generate the component log at the where log location, but you can identify and get these logs as a pod log because each and every component is running as a pod within the kube system namespace on the master node. So you can execute the command like kubectl logs -n kube system and the pod name, by which you can identify and get any node of any component which is a part of your Kubernetes cluster. Let's see a very basic hands-on demonstration on this. So here we are on the master node, and if we want to get the logs of my kubelet service, then we need to execute a command sudo journalctl -u and define the kubelet, which is my service name. Hit enter, and these are the logs we are getting for my service. So earlier we are getting some failure logs as well, and then we are getting the other logs for my kubelet service. You can see over here we are getting the total number of lines, total 154 number of lines of logs over here, right, within this file. So using this way we can get the service logs. If you want to tail the service logs, then you can execute the same command, but you need to define the number of lines, how many number of lines you want to tail. Suppose we want to tail 100 number of lines. So you can see we are getting the logs for the 100 number of lines, right? Press Ctrl C to exit out, clear out the console, and these lines was the last 100 line of my kubelet service. Suppose if you would execute the same command on my worker node where we stopped the kubelet service, let's hit enter, and see over here we are getting the stopping kubelet as well, right? Then we again started the kubelet, so that we are getting the started kubelet logs as well. And if you want to follow the logs, you can execute a command sudo journal ctl -u kubelet define -f. It means follow the logs. It will follow your logs. So let's ssh my worker node in the another terminal. So I will ssh my worker node 1, ssh the IP of my worker node, right? You can see I am here inside my worker node 1, and see we are following the kubelet service logs. Let's execute sudo system ctl status kubelet. Hit enter, the service is running and no new line in my logs. Let's do one thing, exit out and stop your kubelet service. Hit enter, go to the previous terminal and see we are getting the logs that stopping kubelet the Kubernetes node agent is this, right? The log are basically being generated over here, and then we are getting stopped kubelet the Kubernetes node agent. See, if we will check the status again, the service is stopped. Let's do one thing, let's start the service again. So instead of the status, we will mention start, hit enter, go to the logs and see we are getting the kubelet service starting log. So this is the way how we can get the logs of your services using the journal ctl, how you can tail the logs, how you can follow the logs. Let's go to the master node and I will clear out this command. So on the master node we will get the all kubernetes component. So as we are using the kubeadm to install the kubernetes, and kubeadm basically will execute all the components in a pod. So we will execute a command kubectl get pods -n and the namespace name. So you can see all the components are executing as a pod, and if you want to get the logs of any pod, you want to get the logs of the scheduler, proxy or the etcd or api server, and suppose we want to get the logs of my etcd, in that case we need to execute a command kubectl logs, define your pod name, -n define your namespace, hit enter, and here we are getting the logs of my etcd. So this is the way how we can get the logs of my kubernetes component as well. So this is all about the cluster logs or the node logs. Thank you team, see you in the coming lab. Hello team, welcome back, and today we will see how we can troubleshoot the application in Kubernetes. So till date we have not discussed about the troubleshooting application in Kubernetes. So today we are going to discuss how we can check the pod status, how we can execute the commands in the container, and then we will see a very short hands-on demonstration. So basically throughout this course we have seen the pod status multiple times, and we use the command kubectl get pods. Kubectl get pods will basically list out all the pods and the status of your pods. If you want to describe the pod, user can execute a command kubectl describe pod and the pod name, and this command will basically provide you the complete information about your pod, that what are the volumes, network, containers, and each and everything which is required, and each and everything which is attached with your pod. This command will display all the information regarding that pod. If you want to run a command within the container, you can execute a command kubectl exec. So if you want to execute a command within a specific container, it may possible that the multiple container could be the part of a single pod, right? You can execute, then you need to execute a command kubectl exec pod name -c, then define your container name and then define the command after --, right? If a single pod is a part of your if a single container is a part of your pod, then you can skip -c container name and directly execute the command within the pod. But if multiple containers are the part of your pod, then definitely you need to use the container name specifically, then in which container you want to execute the command. Please make sure that kubectl exec is not used to execute the software in a container which is not the part of the container. You can only and only execute the things which are the part of your container using the kubectl exec command. Let's see a very short hands-on demonstration. So here we have created the connection with my master node, and if you want to get the number of pods running in my Kubernetes cluster, we will execute a command kubectl get pods, and there is no pod running in the default namespace on my cluster. If we will execute and specify a namespace like kube system, the kube system namespace is basically managed and created by the kubeadm, then these are the pods which are running in the kube system. But but no pod is running in the default namespace. Let's do one thing. Let's create some file. So we will create some file like deployment.yaml, and we will put some deployment manifest over here. You can see I have mentioned some deployment manifest over here, and 3 replicas of this deployment will be executed. It is executing 2 pods. First is the Ceph server pod and another is the Ubuntu 18.04 pod. Right? Both of the pod will sleep for three. Both of the pod will sleep for the 3600 second. I will save this. To execute this, I will execute kubectl apply -f and the file name. Hit enter. The deployment is got created. Get the number of pods again, and you can see 3 pods are running. Right? Ceph server this, Ceph server this, and Ceph server this. And each pod have the 2 container, and right now none of these container are in the running state or in the ready state. After some time we will again get the status. Let's get the status again and see both of the container from this particular pod are in the running state, and now all the pods are in the running state. If you want to describe any pod, that what are the containers running within that pod and what are the configuration of these containers, you can execute a command kubectl describe pod and define the pod name. Suppose we are describing the first pod and hit enter. It will display all the information regarding your pod. Like this is in the running state, the namespace is default, this is the pod name, the creation time and the labels, and these are the containers. The first container is the Chef server and second container is the Ubuntu, and these are the container details. Then we are getting the conditions, we are getting the volumes and the other necessary information. Let's clear out the console, and suppose we want to execute some command in a specific container like the Ubuntu container. So we will get the pod names again, and to execute the command we will execute a command like kubectl exec define the pod name. So suppose we are defining it. So suppose we are defining the pod name -c define the container name. We want to execute a command within the Ubuntu container. So we'll define the Ubuntu, the container name, define, and then define the commands. So suppose we want to list out all the file system which are present within my Ubuntu container. Hit enter and see. These are the file systems which are present within my Ubuntu container. Suppose the same thing I want to execute for my Chef server. So we will replace the container name within the same pod, Chef server. Hit enter, and these are the file system which are present within my Chef server. And now suppose you want to open the interactive terminal with the Ubuntu. So we will execute the same command, and after hyphen we will mention bin bash. And after the exec we will open it within an interactive mode. So we will define -it over here. Hit enter. So what is happening over here? Right now it is opening your Chef server container within this particular pod in a interactive mode. You can execute anything over here. Like you can go to the temp ll, and there are no files or the directory. Let's create some directory like touch test1.txt. Put ll or ls. You can see the directory is present over here. Let's exit out, execute the non-interactive command, and ls the number of files within the temp. So we'll mention temp, hit enter, and see it is listing out the text.txt. If we will get the number of pods again, and we will execute this particular command for another pod. Suppose we are executing this command for another pod, and we are executing this command for the pod 2. I will copy this and paste it here, hit enter, and see it is not listing out any file. Right, earlier it was listing out a file. Why it is not listing out any file? Because this time the container is different. This time the container is within this particular pod, and we created the file using the interactive mode within this particular pod. So this is the way how we can troubleshoot your application within the Kubernetes cluster. Right, so you can open the containers, you can verify the logs within your container, you can execute the commands from your container. So you can do all possible things which are possible with your application. So that's all how we can debug the application within Kubernetes cluster. Thank you team. See you in the coming lecture. Hello team, welcome back. And today we will see how we can get the container logs within the Kubernetes cluster. So we will see the container logging, and then we will see the kubectl logging. After then, we will see a short hands-on demonstration on the container logging. So team, whenever you are executing any application within the container logging is very necessary, and that is very important to debug the application. So we need to make sure that we should be aware that how we can get the container logs within the Kubernetes cluster. And Kubernetes cluster basically maintain the container logs, which used to get the insight of the container processing function. Container logs basically contains each and everything which is written to the standard output and error stream by the container process. So everything whatever is basically written in the standard output, that you will get within the container logs, and due to any reasons if there is error within the container process, then you will also get that particular error within the container logs. And to get the container logs in a Kubernetes, you have a very simple command kubectl logs, define the pod -c and the container name. So we have created the connection with my master node, and we will see the how many pods are running over here. So if you remember, in the last lab we have executed the Ceph server deployment, and 3 pods are running, and each pod have the 2 containers, right? The one container is the Ubuntu container and another container is the Chef server container. If you want to get, you can copy the pod name and execute the command kubectl describe pod and the pod name, and you can see the 2 containers are running over here, the Chef server and the Ubuntu. Let's get the logs of any of your container. You will execute a command kubectl logs, paste your pod name -c and define the container -c and define the container name. So suppose you want to get the Ubuntu container logs, so we will define like this, and we are getting only one log, hello from Ubuntu container, right? And how we are getting that particular log, if you will get your file deployment.yml which we used, then you can see we have only executed one command, right? Similarly, we have executed the another command using the Chef container. So if you will get the logs of your Chef container, we'll clear out the console and get the logs of my Chef container. You can see we are getting the line from my Chef container. So this is the way how you can the specific container logs within your Kubernetes cluster. If you have any doubt, any question, you may ask me. Thank you team. See you in the coming lecture. Hello team, welcome back. And in this particular section, we are going to discuss about packaging and deploying the application in Kubernetes. Although we are deploying the applications multiple times in the last lecture, but in this particular lecture, we will see how we can package these particular services. And we can package the services with the help of utility called Helm, right? So we will see what is Helm and what is the use of the Helm inside the Kubernetes cluster. So let's start with. So basically Helm is an Kubernetes based package installer. With the help of the Helms, you can package your application and you can install your application. You can also install some other plugins and other software, the third party software which is required for your Kubernetes cluster. Helm is the best way to find, share, and use software built for the Kubernetes. Helm also help us to maintain the application. As I told you that with the help of the Helms, we can package our application. So Helm will help us to maintain the application. We will see how Helm will help us to maintain the application in the coming lectures. Helm is the utility which is being managed by the CNCF, which is called Cloud Native Computing Foundation. CNCF is an organization which is working in collaboration with the Google, Microsoft, and Big Native. Helm manages the Kubernetes deployment with the help of the charts, right, which are pre-configured package of Kubernetes resources. So inside the charts, we will define the application configuration package. We will define what are the structure of my application. We will define the dependency, the values, pre-configuration which is required to deploy my application onside the Kubernetes. Inside the chart, we will define the Kubernetes deployment, the dependency for that particular deployment, the values and pre-configuration required for that particular deployment. Helm enable you easily install package, make revision and even roll back complex changes. So as I told you, Helm will help us to maintain the application. This is the best example that with the help of the Helms, you can easily install the package which is required for your application. You can make the revision of your application. You can version your application, right? And due to some reasons you are getting an issue on the new version, you can roll back your application as well. Now let's discuss why we need Helm. Although we have learned why we need Helm and what is the application of the Helm, but we are going to discuss few more points that why do we need Helm inside the Kubernetes cluster. So basically, with the help of the Helms, you can fetch, deploy, manage the life cycle of application, both third party and your own application. Sometimes you need your application in some other application, so you can make the dependencies as well with the help of the Helms. With Helm, there is a structure and convention for a software package that defines a layer of YAML templates and another layer that change the template called values. So with the help of the Helms, you can define the structure of your application. You can define different layer of the application, and these layers are in the terms of the YAML templates. So basically, till now we was using the multiple YAMLs to deploy a single application, but with the help of the Helms, we can package all the YAMLs in a single chart and we can use them. In the Helm, we have a special YAML file which is called values. Values are injected into the templates, thus allowing separation of the configuration and defines where changes are allowed. Inside the values, you can define your application name, your application version, and basically the values store the variables which is required inside your Helm package, and it will replace the variables at runtime inside your Helm package. The whole package which is being created with the help of the YAML, with the help of the values, that is called Helm chart. So it might be confusing sometimes, but when we will implement this will be pretty much clear to you guys. So just be with me. Right now I'm just explaining the Helm and the structure of the Helm. In the coming lecture I will show you how actually we can deploy the application with the help of the Helm. Essentially, you can create the structured application package that contain everything need to run on the Kubernetes cluster, including the dependencies and the application. So with the help of the Helms, you can define an Helm chart which will have your all the YAML files as a template inside the Helm. Helm chart will also have the subchart in which you can define the dependencies of your application, and it will download the dependencies at runtime. It will have the values YAML file where you can define the variables of your Helm package, right? These variables will be replaced inside the Helm package at runtime when you will package or deploy your application with the help of the Helm. Now let's discuss about the Helm CLI, or we can call it Tiller. So Helm is an CLI based tool that interacts with its backend, which is called Tiller. So basically, we will start or install the Helm on the Kubernetes. And Helm is an CLI based tool which will interact with the backend server which is called Tiller. Tiller is typically installed by sending the command Helm init and lives in the kube system namespace. So you can initiate the Tiller with the help of the command helm-init. You can go to your Kubernetes cluster and type this command to initiate the Helm, and all the information of the Helm and Tiller will basically reside by default inside the kube system namespace, although you have not configured it outside of the kube system. When a chart is installed, we have discussed about the chart in last slide, right? So when a chart is installed with the help of the Tiller, Tiller will create a release for that particular chart and start tracking it for the changes. So whenever you will deploy your application with the help of the Helm, right? Helm will create a release for that particular deployment. And whenever you will restart it, you will change it, you will update it, Helm will make the revision of that particular release. This way, Helm not only takes part in installation, but it is an actual deploy tool that manage the life cycle of application in cluster using chart releases and their versions. So with the help of the Helm, you can install the application, you can package your application, you can deploy your application, and you can manage all the revisions of your application and all the chart revisions of your applications as well. So right, so Helm is a complete tool which you can use inside your Kubernetes cluster to package and deploy your complex to complex application inside the Kubernetes. Because till now we was just deploying nginx, we was deploying the redis, we was deploying the data stack, but at runtime whenever we are deploying a complete application, it may have a lot of YAML files. Sometimes it is possible your application will have more than 100 YAML files, right? In that particular way, it is very difficult to maintain the order of these YAML files and deploy each and every YAML file via the manual system, right? So we need to package these YAML file. We need to package our application. Sometimes we have the dependencies as well. Sometimes we have the config map, configuration, services. There are a lot of things come into the picture when you deploy your application, set the production or actual application on your Kubernetes cluster. So to package that particular application, package the complex application, we will use the Helm, and to deploy that particular application as well, we can use the Helm. We was discussing about the charts so long, so let's discuss what is the Helm chart and which is called package as well. So Helm uses chart to pack all the required Kubernetes components for an application to deploy, run, and scale. So with the help of the charts, you can package your application, you can deploy your application, execute your application, and scale up your application as well. In a simple term, you can call a Helm chart is a collection of YAML templates, right? They are organized into a specific directory structure. Shortly, we will discuss the directory structure of the charts as well. Chart is a thing where dependencies are defined and configuration are updated and maintained. Please make sure the chart root have only one file called chart.yaml by the convention. This is the convention of the Helm, that the root file of the chart should be the chart.yaml. And the templates which are defined inside the chart, they are optionally subdirectories inside the chart that combine the k-test component like the services, replica set, deployment. So all the YAML files like the services, replica set, and the deployments, they come inside the template subdirectory inside the charts. As I told you, inside the charts, we have one more thing which is called values.yaml. So values are described in the values.yaml file, which is necessarily a YAML structure holding the values to match the templates, which will define the values which should match the templates. The values are like a key value pair where we will define the key as a variable and value is the value for that particular variable. That will be replaced at runtime in the template of your chart. As I told you, that values basically define the deployment values like name, labels, or any dependency thing. If you want to define the dependency for your application, suppose your application is dependent on some other application, right? So you can define a separate subchart for that, and you can define all the dependencies inside the subcharts. Another way of using the subchart is considering an inheritance mechanism. As I told you, that inside the subcharts we can define the other applications like, so we can use the subcharts as an inheritance mechanism as well, which allows fetching a standard chart with template and use it subchart in multiple parent chart that would provide the values. So you can define the parent and child relationship of your application with the help of the charts and subcharts in the help. Let's discuss about the concept of the repository. So repositories are where the Helm charts are held and maintained. So we will create a repository for the Helm where we will keep all the charts and templates and value YAML files. Sometimes the Helm packed repository as a tar.gunzip file. And if you have a chart tar.gunzip file and you want to add that particular chart as a dependency in some other chart, right? So you can directly define the gunzip file in the subcharts. You don't need to extract that particular file as well. Now discuss about the releases. If you remember, then I told you that Helm will maintain the revision. This is called release. So release is a mechanism to track installed application on the Kubernetes cluster. When an application is installed by the Helm, a release is being created. So whenever you will install application inside your Kubernetes cluster with the Helm, it will create the release for that particular application. Whenever you will do any update in that particular application, it will revision the release and define a new release for that particular application. If you want to track the release, then you can execute a command helm ls. Each would have a revision, which is helm release version terminology. If a specific release is updated, example like adding more memory in the Redis release, the revision will be incremented. As I told you, if you will update your application, then revision will be updated inside the helm release. Helm allow rollback of a particular revision, making it virtually the manager for deployment and production state handler. So team, if you have added something inside your application, Helm has already updated that particular release. And if you are finding any issue in that particular updated application, so you can roll back the release as well with the help of the Helms. So thank you team, thank you all. This is about the introduction of the Helm. In the coming lecture, I will show you how we can use the Helm and how we can use the Helm to deploy and package the application inside the Kubernetes. So thank you team, thanks for your time. Hello team, welcome back. In the last lecture, we have discussed about the application of the Helm. Today we will see how we can install and initiate the Helm and how we can deploy the application with the help of the Helm. So let's just start with. So as a part of this particular lecture, first we will download and install the Helm. Then we will initialize the Helm. And after this, we will deploy application with the help of the Helm. So let's go to the terminal. So we are on terminal and first we will check and validate the cluster. So you can see it is validating my cluster level360degree.uk and my cluster is in healthy state. One more thing I would like to mention, whenever you are executing Helm on your Kubernetes cluster, the RBAC API should be enabled on your machine, right? So first we will check the RBAC APIs, kubectl APIs hyphen versions. Hit enter. And you can see both of the RBAC API are enabled on my Kubernetes cluster. If these API are not enabled on your cluster, then first you need to enable these APIs. And we have discussed in the earlier lecture how we can enable the RBAC on the Kubernetes cluster. And now we will install the Helm on my cluster. For this, I have created this particular folder Helm. You will get this particular folder inside the code repository if you have downloaded it. And in this particular folder, I have mentioned all the commands which you can use to install the Helm. What we need to do, first we need to go to the storage googleapis.com and download the Helm version for Linux tar.gz file. Right, put ls and you can see Helm version 2.14.1 is being downloaded. I will provide executable permission to this file chmod 655 ls, and you can see this file have now read write and executable permission. Clear out the console. Next I will extract this particular tar file. Then you can see all these things, the tiller, readme.md, hem and license are being extracted at this particular directory. Let's go to this particular directory, cd linux amd64, put ls, and you can see we have the license, we have the readme.md file, we have the hem binary, and we have the tiller binary. If you will get the readme.md file, then over here we are getting some document which you can refer when you will install your hem. Let me clear out this. We are not going to follow this particular document. Next, what I will do, I will move my hem binary to my user local binary. So I will copy this particular command and hit enter. Right? If you will verify, go to cd user local bin, put ls, and you can see we have the helm binary over here. If you will execute a command helm hyphen h for the help, you will get all the commands. See, we are getting the helm commands over here. It means helm binary is basically moved into my binary directory. Let's clear out the console. Next, what we need to do, we need to create the helm rbac.yaml. So over here I have created an rbac yaml file. What this will do, this will create an service account. The account name will be helm tiller, and this particular account will be created in the kube system namespace. Then I will define role binding to this, and I will define the cluster admin role to this particular account, and this particular role binding will also create in a namespace kube system. So what we are doing, so basically helm will use a service account to execute some commands on your Kubernetes cluster for the authorization. If you will not set up the service account which will be used by the helm, then your Kubernetes cluster will not allow helm to execute any command on the cluster. So this is the helm rbac file. I will copy the content. Now first I will go to the root and I will create a directory helm, or you can create any directory, right? And the name should be anything, or let's say helm package. Go to this particular directory. Over here, let's create a file rbac helm.yaml and paste my content over here. Just save this file. Now execute this particular file kubectl create -f rbac helm.yaml, and you can see this will create an service account called helm tiller, and it will create a role binding called helm tiller as well. So we have executed up to this particular instance, right? We have created the service account and the role binding. Now what we will do, we will initialize the helm with this particular command helm init. We will define the service account name, right? And here I will define my service account name. As I have created the service account called helm hyphen tiller, right? You can see over here I have my service account name. You can create any name, right? And you will assign that particular name when you will initialize your helm on your Kubernetes cluster. So I will copy this and execute this over here. So over here we are getting few messages like creating root helm, creating root repository, local, starters, plugins, and we are getting home has been configured root helm. For the tiller we are getting the message tiller the helm server side component has been installed on your Kubernetes cluster. Here we are getting some policy as well, and we are getting some message like please note by default tiller is deployed with the insecure allow authentication user policy, as I told you in the last lecture. And we are getting some command to initialize the helm with the authorization policy, right? For this we need the certificates and we need the certificate key. I'm not going in that particular path. First I would like to explain you how we can install it, right? Let's clear out the console. So if you remember, we have created all the things, the account and binding in the kube system namespace, right? So let's execute command kubectl get pods hyphen namespace and define my namespace name, which is cube system. Here I will get all the pods which are running inside this particular namespace, and you can see a pod called tiller deploy is running over here, and this is running since last 85 seconds. It means this particular command which we have executed to initialize the Helm, that has created the pod called tiller deploy, right? And this pod is basically attached with the service account and will communicate with the Kubernetes cluster. Let's clear out this. So we have initialized it. We have verified that it is being deployed by this particular command, right? Now search for some application and install the application. So team, I believe you must have worked with the Debian based systems, right? And if you want to install some package, you have executed the command apt install then package name. In the same way, Helm will work. If you want to install something, if you want to execute something, you can simply execute Helm install then define your package name. If you want to search some application which is basically published on the Helm community repository, you can execute a command Helm search and define your application name like nginx. This will take some time, and you can see the different nginx repository are being present over here. Stable nginx ingress, stable nginx ldap auth proxy, stable nginx lego, stable nginx google cloud endpoints. So basically these are the repositories or the project which is being published on the community Helm repository. In the similar way, you can search for other thing like Helm search redis, right? And we are getting the different redis versions as well. Stable prometheus redis, stable redis ha, stable census. You can see over here we are getting the description as well. If you will go to the nginx ingress controller that use config map to store nginx proxy with ldap auth, chart for nginx ingress controller cube lego, and deprecated deploy nginx, which is the google one. If we will go with the redis, then we are getting Prometheus exporter for Redis metrics, open source advanced key value store, right? We can use this. And if you want to install any application with the help of the Helm, you can simply execute Helm install, then define your application name. Hit enter. This will deploy your application inside the Kubernetes cluster. Just be with me. See, this application is being deployed. So the same command is mentioned over here. If you want to install something, you can execute a command Helm install application name. Here we have the few notes as well. Like each installation of the Helm chart to your cluster is referred as a release. If you clear out the console and execute a command Helm ls, then you can see we are getting something is deployed. Here is the name, which is the random name. We are getting a random name like we get the random name for the Docker container. We are getting the random name extra sorted auto, right? This is being updated at this particular time. Revision is 1. Status is deployed. And which chart it is using? It is using Redis 9.1.10. App version is 5.0.5. Namespace is default. With the Helm, it is easy to have multiple releases installed on a single cluster, each with its own specific configuration. So if you want to install one more Redis, you can install one more Redis over here, right? And if you want to provide your own name to a release, over here we are getting the system generated name, then you can do that as well. Let's execute one more release Helm install and define the release name hyphen name, and let's call it test Redis, right? And we are again installing the stable Redis. Let's do this and see this is being deployed. Now let's see what output we are getting as a part of the installation. So over here we have executed the installation command. We are getting the name is test Redis Helm. At this particular timestamp, this is being created. This has config map. Two config map are being created as a part of this particular deployment. First is the test Redis Helm, and second is the test Redis Helm hyphen health. Two pods are basically created as part of this deployment. One is test Redis Helm master 0 and test Redis Helm slave 0. You can see one more secret is being created called test Redis Helm. The type is opaque. And few services are also being created. You can see a cluster IP service is created test helm hyphen headless. Another cluster IP service is created test helm hyphen master, and cluster IP services test helm slave is also being created, and they are listening on this particular port 6379 6379 6379. Over here we are getting the service IP as well. Two stateful set also being created, one is master and one is slave. We are getting the nodes. Please be patient while the chart is being deployed. Redis can be accessible on port 6379 on the following DNS name within your cluster. And we are getting some information that test helm redis master default.svc.cluster.local for the read write operation, and test helm slave for the read only operation. So if you want to execute some read write operation on your redis, you can execute this particular DNS. Few more things we are getting, that to get your password you need to execute this particular command redis password kubectl get secret, define the namespace which is default, define your secret name. Over here you can see it has been created the secret, you see, and this is the secret name. So same thing we are getting over here. Now we are getting -o JSON path, we are getting the JSON path of this, right? And we are getting base64 hyphen decode. By this we can get the password of the redis, and to connect the redis we can execute these particular commands. So let's connect to the redis. So I will open one more terminal so that these command will not be raised, and I have divided my screen on two terminals, the black terminal where we are getting the instruction and the blue terminal where I'm going to execute the commands. So you can see, run a redis pod that you can use as a client. So first what we can do, we will get the password. We will execute the same command kubectl get secret namespace default base64 decode. This will give you the password of your redis. Execute on the blue terminal and see, this is the password of my redis rjad4nbqca, right? After this my username is being printed over here. I will copy this over here. So over here we have some instruction, run a redis pod that you can use as a client. So the redis server is running, but if you want to use a redis as a client, then you need to execute something, and the command is like this: kubectl run namespace default. Then I need to define the pod name. In this case this is taking the pod name like test redis helm client rmtty restart policy. I will copy this and execute. After this I need to pass the password, paste it here. We have copied the password, and password is this. I will copy the password because right now I didn't provide this particular password in the environment variable, and I will simply paste my password over here, define a space, then I need to define the image which is this, and define the bash for the terminal. Paste it here, hit enter, and you can see right now inside my client, right? If you want to access your password, you can simply execute echo dollar redis underscore password, hit enter. See, my password is being printed. By this particular command I can connect to my redis master, hit enter, and see, I have connected to my redis master CLI. Over here just execute help, and see, I'm getting some help command over here. The redis CLI is 5.0.5, right? The help input is group command to quit, redis CLI reference, set hints, set no hints, and preferences as well. Clear out the console. Now suppose if you want to set something, some key value, so I can execute some set key. I'm taking the key as my name, and inside the value I'm taking the designation which is cloud developer engineer. Suppose in the next thing I'm taking the expression, or let's leave it. So you can see inside your redis you have set the key and the value. If you want to get the key, then I can type get unsure. It means get the value of my key, and you can see the value is being printed cloud developer engineer, right? So by this particular way we can see my redis is fully working over here. If I will exit out my pod or delete my pod, then you can see the pod is being deleted. Clear out the console, kubectl get pods, and see, no pod named which I have been created. I have created the pod with the name test redis helm client. This is being not present over here. But what about my data? Data must be present because this is working as a persistent volume claim as well. See, let's execute a command kubectl get pvc. There's a mistake in the command. Just be with me. This should be kubectl, and you can see these persistent volume are working. One is Redis data test, Redis helm master, slave, and slave one. Clear out the console. If you want to delete some services, you can execute helm ls to list out the services. And right now, two Redis deployment is running, test Redis helm and accessor baited order. Right, I will copy this, and suppose I want to delete it, I will execute the command helm delete and define my service name. Hit enter. This will delete this particular service and all the resources which is related to this particular service. If you remember, we are executing all the things in the helm in a default namespace. If you want to see what resources are running, then you can execute a command kubectl get all. As my namespace is default, so I don't need to specify my namespace. Hit the command and you can see three pods are running, which is test Redis helm master 0, slave 0, and slave 1. Three services are running, headless service, master service, and slave service. For the test helm, two stateful apps are running. If I will execute a command kubectl get pvc, then you can see these persistent volumes are also running, right? So this is the way how you can deploy the application with the help of the helm, and helm will deploy each and everything which is present inside the package for you. You remember, we have not defined anything. We have not defined that we want to deploy the pvc, we want to deploy the services, or we want to deploy the pods, and what pods we want to deploy. We just executed and installed a single package which is called stable redis, and everything is being deployed for me on the fly. Why everything is being deployed? Because these things are bundled in a package of the stable redis of the helm repository. Let's clear out the console. Type command helm ls, and if you want to delete your redis as well, type helm delete, define your helm service, hit enter, and this will delete each and everything. If you will execute a command kubectl get all, then you can see nothing is working over here. So this is the way how can you install the helm, how helm will establish the communication with your Kubernetes cluster with the service account, and how you can deploy the application with the help of the helm, and what are the components of the application you will see when you will deploy the application with the help of the helm. So thank you team, thanks for your time. Hello team, welcome back. In the last lecture we have seen how we can install the helm, and today we are going to discuss how we can create the helm chart. So we are discussing about this particular word since last two lectures. Today we will see how we can create the helm chart, how we can deploy the application with the help of the helm chart. So let's start with. So as a part of this particular lecture, we are going to discuss how we can create the helm chart. We will see the components of the helm chart. What is the use of these different components inside the helm chart? The binding of the components with each other components. And in last, we will execute the Helm chart to deploy the release inside the Kubernetes cluster. So these are the things which we are going to discuss today. For this, I have created an instruction file. Here is the instruction file. The file name is createhelmchart.md. This file will be commit in the same folder Helm, right? So you need to download this particular project code. The Git repository I have shared in the starting of this particular course. So first we will see how we can create the Helm chart. To create the Helm chart, you just need to execute this particular command. You need to execute helm create and define your chart name. So let's go to the terminal, and over here I will execute a command helm create and define my chart name. Suppose I want to create a deployment called hello world, right? I will hit enter, and you can see creating hello world. If you will put ls over here, you can see a directory named hello world is being created over here. If I would like to extract this particular directory, I will execute a command tree hello world, right? Tree command will show you the directory structure of the hello world, and you can see this is the directory structure of the hello world. See, right? This hello world is have 3 directories and 8 files. So by default, if you want to create the chart of the helm, you can execute this particular command helm create and define your chart name. It may be your application name as well, because over here you can see when we have executed this particular command helm create and define a particular name, it has been created a directory with this particular name, and inside this particular directory it has been created few objects as well. The first is the chart.yml. Second, it has created the subdirectory charts. Then it has created the subdirectory templates. Then it has again created the another text file inside the template which is node.txt. Then created the helper.tpl, deployment.yml, ingress.yml, services.yml. Then inside the templates, another directory is present test, and over here we have the test connection.yml. And at the parent directory hello world we have the values.yml. So this is the structure of this particular directory. This is the way how we can create the chart in the Helm. And if we want to deploy the application with the help of the Helm, then we need to edit this particular template as per my application. So over here I put some description as well, that name of the chart provided here will be the name of the directory where the chart is being created and stored. You can see the same thing is here. I have provided this particular name, so a directory is being created and all the charts and templates are being created inside this particular directory. Let's understand the relevance of these files and folder created for us. See, we have the chart.yml. This is the main file that contains the description of our chart. So this particular file will have the description of my chart. Then we have the values.yml. See, we have the values.yml over here. This is the file that contains the default values for our chart. It means all the default values which is required for my chart or for my application will be stored in this particular YAML file. Then we have the templates. See, we have the templates directory over here. This is the directory where Kubernetes resources are being defined as a templates. So in this particular directory, I will define all the templates, which will be the deployment template, ingress template, and the service template. Then we have the charts. You can say we have one more directory, charts, and inside the chart, first thing, this is an optional directory, and if we have any dependency in our application, then that dependency will be defined in this particular directory in the charts. Suppose we are executing an application which is a web server, but that web server requires an application backend, so we can define the another dependency of backend inside this particular charts, and this can be a tar.gunzip file. Now let's do one thing. Let's clear out the console, right? And I will open one more screen. See, we are working on the two screens. On the black screen, I will show you the structure, and on the blue screen, I will show you the files. So on the black screen, let's execute a command tree, hello world, and this is the structure of my files, right? So first, I will go to the hello words in the blue screen, cd hello words, put ls, and you can see all these files are basically present over here. We have the charts, then we have the directory chart, then we have the directory template. See, template is here. Then we have the values.ml. See, values.ml is here. First I will vi the charts. This is the structure of the chart.yml. We are getting the API version v1, then we are getting the app version which is 1.0. Over here you can define your release version. So suppose I want to define my release version dot 1.0.1, so I can edit this particular file. Then I'm getting the description. I can amend this particular description as well, and I will amend this like this is my test, right? Then we are getting the app name, and then we are getting the application version. This is the application version team, and this is the release version. If you want, you can edit the application version as well. I'm defining 0.1.13 or 12. Now save this particular file. So inside the charts.yml, I have the chart of my application. Now next thing we have is the values.yml. Let's vi values.yml. You can see this is the default values.yml file. This is saying default value for the hello world. This is YAML formatted file, declares variable to be passed into your templates. By default, it is taking the replica count, right? The replica count is 1. Suppose I'm modifying it and I'm taking it 3 replicas. Then it has the image. By default, it is taking the repository image nginx. See over here. Then it is taking the tag which is the stable release of the nginx pull policy if not present. It means it will always pull the nginx stable image if the image is not present. Then it is taking image pull secrets, define none, image override none, full name override none. Then we are getting the services. Inside the services we are getting the type which ClusterIP, the port is 80. If you want, you can amend the service as well. You can define the load balancer or anything whatever you want, right? Then we are getting the ingress. Ingress is false by default. We are not using the ingress over here. We are defining the host. Host is chart-example.local. We are defining the path and the resources. And in the resources, you can define the affinity, the limits, the request resources, and anything whatever you want. Over here, you are getting the node selectors, right? I'm not using the node selector, the tolerance, and the affinity. So inside the values, you can define all the restrictions and the image and the replica count and any other thing which is required for your deployment. I believe we are already familiar with these kind of tags and this kind of formation. I will save this particular file. I have done just one change. I have increased the number of replicas. So we have seen the chart.yml file and the values.yml file. Let's clear out the console and go to the charts, cd charts. And I believe this is an empty directory. Yes, this is an empty because till now I have not defined any dependency over here. Let's clear out this, exit out this particular charts. We are in hello world. Now let's go to the templates, put ls, and over here we have the different templates. We have the notes.txt, we have the helpers.tpt file, we have the deployment.yml, ingress.yml, service.yml, and then we have the test directory. Clear out the console and first let's get the notes. Inside the node.txt you can say this is a template, right, which will define the nodes of your application. In the last lecture when we have deployed the redis, we was getting the nodes after the deployment, right? These are the same nodes which are present over here. At runtime these things will be replaced, like you can see the release and namespace will be replaced, the json path of the port will be replaced, the status and address will be replaced, right? In the nodes everything will be replaced at runtime. You can see over here we are getting the service ip will be replaced, the pod space, namespace, everything which we will change inside the value.yml and chart.yml, that will be replaced over here in this particular template. This is just an template which will be published on the console when you will deploy or release, and after the successful deployment these node will be published on the console. If you want change anything you can change in these particular nodes. Now let's get the deployment.yml file. You can see this is my deployment.yml file. Let me make it bigger. And this is the API version apps v1. The kind is deployment. Then I'm getting the metadata. Inside the metadata I'm getting include hello world dot full name. This is the name of my chart and this full name will be appended at runtime. Now we are getting the labels, right? We are getting the replicas. We are getting the replicas, and from where it is getting the replica, you can see it is getting the replicas from the values dot replica count. Inside the values we have the tag replica count where we have increased the replica, so it is taking the replicas from that particular file. Now it is getting the selector, the match labels. We have seen the match label, the templates, metadata, labels, specification, and everything. You can see everything which is present over here. This is just a template, and the values which are defined inside these particular double curly braces, they will be replaced at runtime from the charts.yml or the values.yml. The things which will be replaced from the charts.yml, they will be started with the dot chart, and the things which will be replaced with the values.yml, they will be started with the dot values. Some things will be replaced with the release name as well. So you can see over here we are getting the dot releases as well. So this is the basic template. You can see inside the specification we have a container. Inside the container name we are taking the name from the charts. Inside the charts we have a tag name, so that particular name will be replaced at runtime from that particular value. We are getting the image we are reading from the values image and repository tag, right? And with the image we are taking colon and we are reading the values image tag as well. We are also pulling the pull policy from the values image and pull policy. See, if I will show you the values dot pull policy, let me show you. Cd hello world get values.yml. See, inside the values.yml we have the replica count, right? Inside the image, this is the values.image. If I will make it smaller, see, the value is dot values. So this is the values.yml, then dot image, which is this tag, then dot repository, which is this tag. So over here, it will be replaced by the nginx at runtime. Then we are getting colon, and after this, it is reading from the values, which is the values.yml, then image, this which is this tag, inside the values.yml, and then dot tag, which is this particular tag from the values.yml. So all these things which is mentioned in this particular template, they will be replaced at a runtime. If you want to amend something, you can amend that accordingly. Let's clear out the console, put ls, and let's open the another ingress.yml, right? In the same way, all the things which you have mentioned inside your values.yml, they will be replaced in this particular ingress.yml, but we are not using ingress. In our case the ingress is false, so this will not be deployed. Let's clear out the console, and there's one more template which is called service.yml. Get service.yml. Over here we are taking the application version which is v1, the kind is services, Inside the metadata, I'm taking the hello world dot full name. Inside the labels, I'm taking the labels. Then I'm taking the service specification type, which is from values service then type C. Inside the values, we must have the service tag. See, we have the service then type. So type will be cluster IP. So this will be replaced from this particular type. If you will replace this cluster IP with the load balancer, this will deploy the load balancer as well. Then we are getting the ports, which again reading from the values.service.port, values.service.port. Then we are getting the target port, HTTP, protocol TCP, name is HTTP. If you want to replace it, you can directly change over here. Then we are getting the selector, which is again reading from the release name. So this is the another template. So we have seen the complete templates. Now let's do one thing. Let's clear out the console and go through some commands. So first command is helm lint. What this particular command will do? Over here you need to pass your complete path of your. This command is a simple command that takes the path of the chart and runs a battery of tests to ensure that the chart is well formed. So I will go to my root directory, put ls. You can see I have the hello world present over here. Let's execute a command helm lint and define your directory complete path. Right? If this is present in your current directory, you can define like this. Hit enter button and everything is working fine. If there is some error inside your chart, then this will show you the error. The next command is helm template and define your complete path of your chart. What this will do? This will generate all the templates with variable without a tiller server. It means it will not execute the commands on the tiller server and it will generate the template, and inside the template values will be replaced with the actual values which we have defined inside the charts and values YAML, right? And it will show you the output as well. Let's execute helm template and define my chart name, which is hello world. Hit enter. You can see the complete templates are being generated and mentioned over here. See, the first is service, and at runtime this will be my service. The service name will be release name hello world. It will take the labels like hello world 0.1.12. You can see we have replaced this particular string inside the charts.yaml. This is the version of my application. Then the release version, you can see the same thing we have replaced inside the charts.yaml. This is my release version. Managed by tiller. Then it is saying type is cluster IP. The cluster IP we have mentioned inside the values.yaml file. The port as well we have mentioned there, right? Then it is taking the target port, target protocol and all. It is taking the app name and the release name as well. The second is showing the port, that it will create a pod with this particular template. The version will be v1, kind will be pod. This will be my pod name, release hello world test connection. These will be the tags which we have already discussed. This will be the annotation and this will be the container. Name will be wget, image will be busybox, command will be wget and the release name. Then I'm getting the deployment. You can see the API version is apps v1. We are getting the deployment, release name hello world. This will be my deployment name. These will be my tag, which is same. Then I'm getting the replica count is 3. You can see I have modified this particular count inside my values.yaml file. Then we are getting the HTTP. This will be the name of my container. This will be the image which I will use, nginx table. This is the image policy, the port and all these things. Let's clear out the console. And now if you want to install your release, then you can execute a command helm install -- name, define your release name and define the full path of your chart. So I will execute this helm install -- name. I will define my release name like test nginx and define my complete chart, which is hello world. Hit enter. So you can see we are getting the message last deployed at this particular time, namespace is default, status is deployed. The resource which are being deployed at the part of this particular release are, this has deployed one deployment, name is test nginx hello world, which is this, and hello world is my release name. Ready 0 of 3, up to date 3. This has deployed 3 pods, which is this test nginx hello world, then some random ID, and this has deployed one more service as well, which is on cluster IP type and accessible on port 80. Over here we are getting the nodes. These are the same nodes which is being defined inside the node.txt file. I told you that these nodes will be published after the successful deployment. And over here we are getting that get the application URL by running this particular command. If you want to get your application URL, you need to execute this particular command. Let's do this. Export port name and this particular command. I will copy this and execute this particular command and see. This has exported the IP of my service in this particular variable. If I will echo this, echo dollar port underscore name, you can see I'm getting one of my port name. If you want to forward the port of your deployment, I will execute this particular command kubectl port forward port name hyphen 8080.80. Hit enter and see port forwarding is being executing, and it is saying forwarding from 1.27.0.180 to 80 to 80. Now traffic is being forwarded from port 8080 to 80. Press Ctrl Z, execute this process in background. You can see this process is being running in the background, and execute curl curl on this particular IP and address. And you can see I'm getting the HTML page. Handling connection for 8080 doc type. Welcome to Nginx. Right? The Nginx page is being displayed. Welcome to Nginx. If you see this page, Nginx web server is successfully installed and working. Let's execute FG for the foreground and press Ctrl C to stop this process. Clear out the console. Now let's do one thing. Let's modify this particular deployment. So I will go to the hello world and I will open the charts, and over here first I will increase my application version from 1.12 to 1.15. Save this. Now I will do one thing. I will modify the values. Over here I will decrease the replica count. Suppose I am just executing 2 replicas. Also, instead of the cluster IP, I am defining load balancer over here. Just save this, and to upgrade my service, I need to execute the command helm upgrade, define my release name and define the path of my chart. I will go to the parent directory, execute helm upgrade. Why I am upgrading my system? Because I have done some changes. And over here I will type command helm ls hyphen all. This will list out all my releases. This will list out all my releases. So test nginx is running, right? This is my release name. Revision version is 1. Application is version is this. Now what I will do, I will upgrade my helm application. Helm upgrade. Why I am upgrading? Because I have changed something inside my application. I have changed the number of replica sets. I have changed the cluster IP to the load balancer. Then I will define my release name, and then I will define my path of my chart, which is hello world. Hit enter and see. If you done some mistake, then you will get the error as well. And error is saying service test ng hello world is invalid because unsupported values I have mentioned called load balancer. The value must be this. Right over here you can see the L in the capital and B is also in the capital. So I again need to go to my hello world. So again need to modify a file hello world values.yml, right? And over here I have defined my load balancer. I need to amend this particular load balancer. Just save my file again and execute the upgrade command again. And you can see the deployment is being upgraded, and inside the node we are getting some nodes. Get the application URL by running these commands. It may take few minutes for the load balancer IP to be available, and after this you can execute these particular commands: kubectl get namespace default svc hyphen nginx hello world. This will return you the status of your command. And if you want to get the IP of your load balancer, you can execute this particular command to get the load balancer IP, right? And once you will get the IP, you can access your application on this particular URL. So let's clear out this and get the status of my application and see. This is the load balancer DNS which is working. If you want, you can simply copy this load balancer DNS, go to your browser, paste the DNS over here and hit enter, and you can see welcome to Nginx. This is so simple. We don't need to maintain the complete YAML files. We just need to change few things, right? And after that particular change, all things will be work and deployed on the fly with the help of the helm. Helm is maintaining the complete packaging of my system. Also, it is maintaining the complete execution and the deployment of my system as well. So Helm is a complete tool which you can use in the production if you want to work with the complex application in the production. Let's go back to terminal again and press Ctrl C. Execute a command helm ls, and you can see over here we are on the revision 3. The chart is also being updated with 0.1.5. The app version is 1.0.1, but revision is being changed. And after this, if you want to delete your release, you can simply execute a command helm delete and define your release name. Just give it some time and it will delete all the things from the Kubernetes cluster. Let's execute a command kubectl get all. Oh, there's a mistake in the command, and you can see nothing is running, right? Just a service is running. If we will go to the Amazon account as well, and we will go to the EC2 dashboard, then you can see the cluster is running because that load balancer which I just spent, that is being deleted. So there no load balancer is running, right? And you can see everything is being deleted over here as well. So this is the way how you can use the Helm to deploy your application and create the charts. So thank you team, thanks for your time. Hello team, welcome back. And in the last lecture we have seen how we can create the Helm chart and how we can deploy the application with the help of the Helm. And today we will see how we can package our application in a Helm chart and how we can upload that particular package on S3 bucket. So let's start with. So I'm on my terminal and first I will check is there any release running or not. So I will execute a command helm ls, and you can see one release is running which is test ng revision 2 and status is filled. So team, there's a bug in the helm as well. If you will execute helm delete and define your release name, then you will get an error message. See, it is saying the helm release named nginx is already deleted. But again, if you will execute helm ls, it will list out this particular release. So why this is happening? This is happening because this release in the failed state. So generally Helm is not remove the failed state release. This is a bug in the Helm. For this you can execute one more command helm delete hyphen purge, then define your release name, and you can see this time it's being deleted, right? So team, if you are facing these kind of issues, then we need to make sure that we are passing extra parameter hyphen purge when we are deleting the releases. Clear out the console and let's go to the Amazon AWS account. So here I'm on my AWS account. 3 instances are running, which are my Kubernetes cluster node. 12 volumes are running. Now in this particular task, we are going to create an S3 bucket and we are going to upload my Helm release inside the S3 bucket. So I will search for the services S3 bucket. And right now, only one S3 bucket exists in my account in which my Kubernetes cluster is being deployed. If I will open this, then you can see level360degree.uk Kubernetes cluster is being deployed over here, and we have the complete logs, package, add-ons and other thing related to the Kubernetes cluster being present over here. Now what we will do, I have created a document for this particular lecture where I have mentioned all the commands and the scripts which we are going to execute as a part of this particular lecture. So let's go through that particular document and let's see how we can upload the Helm release in the S3 bucket. So here is the document, right? The document name is upload chart s3.md file. I will commit these particular commands as a part of the code as well. Also, I will attach this particular as an article in the next lecture as well. So before starting this particular lecture, first we need to make sure that AWS CLI credential must be set on the machine from which are executing the Kubernetes cluster. And to verify that, you can execute this particular command AWS sts get caller identity. You need to go to your terminal and execute this particular command. This command will show you the three input. One is the account name, second is the secret, and third is the ARN. I'm not going to execute this particular command in a lecture because this will display my credential, right? So you can execute this particular command. If you are getting the error, then you need to revisit the old lecture where I have explained how you can set up the AWS CLI, right? And if you're not getting the error, then you will get the three inputs in a JSON form, the ARN, the secret, and the account ID. Once you will execute this particular command, you need to execute this particular shell which I have created for this particular lecture. So let me open this particular shell. I will attach this as a attachment of this particular lecture. Let's see what this particular shell is doing. First we are setting the error expression, then I'm generating a random string. See, cat dev random, this is the regular expression, and then I'm printing that particular random string on my console. After this, I'm setting my default region AP South 1. In my case, my region is AP South 1. You can see if I will go to the services, go to the EC2, I'm on my EC2 dashboard and you can see over here. My default region is AP South 1. These are the zones A, B and C, but my region is AP South 1. In your case, you need to define your own region over here. So this is the input which you need to modify when you will execute this particular script. Now what I'm doing, I'm creating another variable called AWS region, and where I'm appending this particular default region over here. Like, so this will be like AWS region colon the default region. Then I'm exporting this particular AWS region, right? I'm comparing my AWS region with the region AP South 1. You can mention your region over here. And then I'm executing a command AWS S3 API create bucket. And what will be my bucket name? My bucket name will be helm hyphen a random string which I have generated in this particular variable. So this command will create an S3 bucket on my Amazon account, right? And the bucket name will be helm hyphen a random string, a 5-digit random string. If this particular reason will not match this particular value, it will ask you to specify the correct reason. After this, it will install the Helm S3 plugin. Once this will create the bucket, it will install the Helm S3 plugin on my machine. Once it will install the S3 plugin, it will initialize the S3 bucket by this particular command, Helm S3 init S3 Helm, then my bucket name. See, this is the same string which I have defined over here. And then it will create a folder called chart inside this particular S3 bucket. After this, it will add repository to the Helm repo add Anshul charts. It will add a repository called Anshul charts and at this particular location in my Amazon S3 bucket. So let's do one thing. Let's copy this particular script, go to the terminal, call S3 create bucket.sh. Put this file here, save out file. Now put the executable permission for this particular script. Chmod 777, define your file name, right? And after this, I will execute this particular shell. So what this will do, this will create a random string like this, and now it will create the location like this helm then random string s3 amazon aws.com. It will download the helm s3 plugin, checksum is valid, install plugin s3, helm plugin is being installed. Now initiated empty repository at this particular s3 bucket, right inside the charts, and Anshul chart has been added to your repository. Now if you will go to your AWS account and go to the services, type for S3, open the S3, then you can see a new bucket is being created, Helm JSX89OIE. This is the same bucket which is being mentioned over here, JSX89OIE. If I will open this, then this have the folder charts which is being created as a part of my this script. See over here, and inside this chart I have added a repo Anshul charts. So if I will open the charts, I will see the repo index.yaml file. Let's open this, and inside that particular chart I have added a repo Anshul charts. So what this particular Anshul chart has been done, this has created an index.yaml file at this particular location. See, if I will open this, then an index.yaml file is being created over here. If I will open this, then here we have some tag, owner, standard and the size, right? And this is saying keys charts index.yaml. Over here we are getting the complete object URL, helm, my bucket name, AP South 1, Amazon AWS.com, charts index.yaml. Now let's move further. So we have done this much of work. Now execute a file helm repo list. So you can see a new repo is being present over here, Anshul charts, S3 helm and charts. This repo I just created. This is the stable Kubernetes repo. This is my local repo, and this is the repo which I just created, right? Now after this, I need to export the AWS Amazon region. So I will copy this command and paste it here, right? If you want, you can execute echo dollar and define this particular variable. This should print the name of your region, AP South 1. In your case, you need to define your own region. Once this is done, let's clear out the console, put ls, and you can see this is the chart which we have created, right? Now it's time to package this particular chart. And to package your chart, you need to execute a command helm package and define your chart. So I will execute it helm package and define my chart name, which is hello world. Hit enter, right? And we can see we are getting a message successfully packaged chart and saved it to the root. And the chart name is hello world dash 0.1015.tzz. If I will put ls, then you can see a new tar file is being created over here. This is my package and I can upload this package anywhere where I want. To upload this package on your S3 bucket, you need to execute your command helm s3 push tar file name, then your s3 chart name. So I will copy this. What is my tar file name? My tar file name is hello world dash 0.1.5. And what is my chart name? My chart name is Anshul charts, right? Which I have defined in my script. I have defined in my script over here, Anshul charts. I need to put this particular name over there. So I will put it here, hit enter, and it's done. If I will put helm search hello world, hit enter. Oh, this is helm. Then you can see one I am getting from the local chart and another I am getting from my S3 bucket. So this way you can upload your helm package on your S3 bucket. This will be very useful when you will work on a production and when you package your own component in your organization. If you will go to the AWS account and if you will open the charts, then we will see hello world 0.1.15 tar file is being uploaded over here. The total size is 2.8 kilobyte. So now let's do one thing. This particular thing is available for all, right? Anyone who have the permission to access this particular bucket, they can install this particular package. If you want, I can show you. Helm install and define this name, Anshul charts hello world. Hit enter and you can see this is being done, right? You can see a deployment is being created, two pods are being created and one service is being created as part of this particular release. Over here you can say a load balancer is being created, right? If you want, you can get the load balancer name or you can directly go to the AWS account. In the AWS you can go to the EC2 and on EC2 you will see one load balancer is running. And if you will open the load balancer, then this is the DNS of this load balancer, A3FFEF8A. You can see same will be open in the terminal as well. If I will execute this particular command, copy this, clear out the console and execute this, I'm getting the same load balancer A3FFEC8A4 and the same is here A3FFEC8A4. If I will copy this complete name and open in my browser, this will open the Nginx. See, so team, this is the way how can you upload and deploy your helm package on the S3 bucket. So thank you team, thanks for your time. Hello team, welcome back. And in this section, we are going to discuss about serverless functions on Kubernetes. So we will see what are the serverless functions and what is the use of the serverless functions. So let's start with. So team, till now we have discussed about the containers, we have discussed about the pods. Until now on Docker and on Kubernetes, we have seen that to execute any job, any event, any task, we need the container, right? It means to execute any kind of code, we need the containers. But serverless technology is completely different from the container based system. So we will discuss in brief that what is the serverless technology and how it is different from the containers but is still usable on the Kubernetes. So the first thing is serverless technology is not a Kubernetes native technology. Public cloud providers like Google, Microsoft Azure and AWS, they are providing the serverless capabilities in which user can deploy the functions. So instead of deploying the container, instead of deploying the pods, user can directly deploy the functions. Serverless capabilities doesn't require to deploy the containers or the instances for these particular containers. We don't need to deploy the machine on the cloud and we don't need to deploy the container on these particular machines. If we are using the serverless capabilities, we can directly use the public cloud providers native serverless capabilities and we can directly execute our application on the serverless capabilities. So these are the serverless capabilities which is being provided by the different cloud providers. If you are working on the AWS, then we have the serverless capability AWS Lambda. If you are working on the Google Cloud, then we have the Google Cloud Functions as a serverless capabilities technology. And if we are using the Microsoft Azure, then we have the Azure Functions in Microsoft Cloud. So they all three are the very famous public cloud providers, and they all are supporting the serverless capabilities on their cloud platforms. AWS Lambda is very functional rich and very easy to understand. On the same way, Google Cloud Functions are also very functional rich and very easy to understand. Plus, there is a native advantage with the Google Cloud Functions that Google Cloud have their own Kubernetes engine. Although the AWS also have their own Kubernetes engine, but as Kubernetes is an open source and developed by the Google Cloud, so in Google Cloud you will get few more extra features in a Google Cloud Kubernetes engine. On the other hand, Microsoft Cloud is also providing very good and native functions for the serverless capabilities. Serverless functions doesn't need infrastructure to run on. If you are executing your application as a serverless, then definitely you don't need to set up the complete infrastructure to execute your code. This is the big plus point with the serverless, that function can be scheduled and only invoke when required. If you are using the containers or if you are using the instances, then definitely once you will start the container, that container will be always running until you will stop it, right? And that will cost you. But in case of serverless functions, you can schedule your functions and you can invoke your functions directly by some gateway calls. Serverless function is not like that particular function will always execute once you will start it. No, function will start, it will do their job, and then it will terminate itself, right? It is not like container that we can start the container and we have to execute that particular container until we need to destroy that. The next thing is the serverless movement and the container movement share the same version of simplifying developing and managing your application. So basically the basic idea of the serverless and container is same. On the container side as well, what we are doing with the help of the containers, we are making the developers life more easy so that they can forget about focusing on the infrastructure, right? DevOps or the cloud ops guys, they will focus on the infrastructure, and developer just focus on developing the code and fix the bug in that particular code. On the same theory, the serverless movement is also working. We know that on front we are not executing any container, we are not setting up any infrastructure, but behind the scenes serverless functions are already running on the containers. When you are using the Lambda functions, you are using the Google Cloud function, or you are using the Microsoft Azure functions, you are just hitting the function. But what is happening on the Microsoft infrastructure, what is happening on the Google Cloud infrastructure? On their infrastructure, they are basically spinning up a container to execute that particular function, right? And once the function job will be done, they will terminate that particular container. So although you are not executing any container, you are not executing any pod, but the cloud provider have their own implementation. Once you will execute some function, it will spin up a container, and on the termination of the function, that container will also terminate. Although to execute the function from the user point of view, there is no orchestration required. But from the cloud point of view, there is an orchestration required which will work behind the scene. It means the developer doesn't need to know any orchestration, any container management, right? They just need to create the function, deploy that function, and build that. The cloud provider on which you are executing the functions, they will manage your function, they will manage the orchestration, they will manage the container. It's their part of job. Serverless function allow you to build application at a high abstraction level so that you can focus on developing your application, less on the infrastructure underneath, right? It means with the help of the serverless functions, you can deploy multiple abstraction function and you can use them as a bundle. You don't need to take care about the containers, about the working model of the containers, the working model of your infrastructure. You just need to manage the data flow between your functions and your functions functionality. The big plus with the serverless is like serverless on public cloud reduce the complexity, operational cost, and infrastructure setup. If you're using the serverless technology, then definitely you don't need to set up your complete infrastructure. It will also reduce your operational cost because the cloud provider will charge you for the function running time. It will not charge you for the instances which is running 24 into 7 hours, or the container which is running on that particular instance. If my function is running for 5 seconds, for 5 minutes or 10 minutes, then the cloud provider will charge me for that particular 10 minute only, or that particular 5 second only. So this will manage the operational cost as well. And in terms of the complexity, definitely we are not setting up an infrastructure, we are not setting up the communication between the containers, so complexity is also being reduced. With the help of the serverless functions, user don't need to manage the OS distribution, right? You just need to mention you need the Windows, you need any particular Linux distro, right? And serverless function will manage that for you. You don't need to manage the OS distribution to execute your functions. User also don't need to build the containers. That's the part of the cloud providers who are executing your functions. User have to pay less only for the time the function is running. As I just told you, if my function is running for the 5 second, then I just need to pay for that particular 5 second. I will not be charged for the particular time until I will stop my container. No. If you are using the serverless technology, serverless capabilities, right, then developer just need to push the code without knowing the infrastructure. Developer doesn't need to care about the infrastructure, what is the infrastructure and how the networking or application data flow will be managed. The cloud provider will take care of the particular infrastructure to execute a particular code. But developers need to manage the operational issues with the code. This is something which is related to your own application. Cloud providers can provide you the infrastructure, but they doesn't know the functionality of your application. So to manage the data flow, to manage the operation of your function, that is the job of the developer need to take care all the issues which is operational issues or which is the functional issues in that particular code. We have few most popular serverless framework, or you can say the serverless project. The first is Fission. Fission is an open source framework for the serverless technology which will work with the AWS, with Google Cloud, and you can set up this particular on your laptop as well. The second is Kubeless. Kubeless is especially designed for the Kubernetes native serverless application. The third is OpenWhisk, and fourth is OpenFast. So these are the very famous project or very famous serverless frameworks which have their different characteristics and different features. So if you are planning to move on the serverless capabilities, then I believe that first user need to evaluate these particular project, that what is the drawback of the Fission, what is the good things with the Fission, what is the drawback of the Kubeless, what is good thing with the Kubeless, or these projects are providing the functionality which is required for your application to execute. User need to install these projects on the Kubernetes cluster to use the serverless functions. But administrator still need to manage the Kubernetes infrastructure. The serverless function will easy the developer's job, but as an administrator of the Kubernetes cluster, you still need to manage all the things which is happening on your Kubernetes cluster. That could be related to the network, that could be related to the resource limit, that could be related to the bad node or master nodes, right? Everything we have discussed till now, as an administrator, you need to manage each and everything on your cluster. Now let's discuss why serverless on Kubernetes. Let's see some few bullet points. Accelerate time to value with Kubernetes. So basically serverless functionality allow you to quickly develop Kubernetes based apps with no need of Kubernetes expertise. Just need to develop the application, right, and all the things will be managed with the help of the framework which we are using to execute my application. Focus on code, not on the infrastructure. Definitely we don't need to take care about what container I need to use, how it will communicate to the container, how container will communicate to the other container. You just need to develop the code and deploy that particular code as a function, and rest of the work is will be handled with the Lambda or the Google Cloud or the Microsoft Cloud. Simple, inexpensive, low maintenance. Definitely we don't need to take care about the networking and the infrastructure, and we are just paying for the time. For that particular time we are using the functions, so it is a inexpensive as well, and maintenance is also low. We don't need to take care about the Kubernetes infrastructure, we don't need to take care about the container health, right? Everything will be managed by the cloud provider. So in this particular way, serverless technology is a beneficial technology for the engineers who are working on the Kubernetes or the developers who are executing their application on the cloud, right? But still, there are few drawbacks with the serverless, which is a big plus with the containers, and there are few drawbacks with the containers, which is big plus with the serverless. In the coming lecture, I will show you what is the kubeless and how we can install the kubeless and manage the application on the kubeless. So thank you team, thanks for your time. Hello team, welcome back. And let's discuss how we can execute the serverless functions on Kubernetes. And to execute the serverless functions on the Kubernetes cluster, we need some framework which support the serverless functions. So we are going to use the kubeless. We will see what is the kubeless and a very short introduction of the kubeless. I'm not going to explain the complete kubeless and the complete functionality of the kubeless. I'm just going to provide a short brief of the kubeless and the functions of the kubeless. So kubeless in Kubernetes is a Kubernetes native serverless framework that lets you to deploy a small bit of code, we can say the functions, without having to worry about the underlying infrastructure. Which means if we are using the kubeless on the Kubernetes and we want to execute something, then definitely we don't need to create the infrastructure to execute that particular functions. We can directly deploy that particular functions with the help of the kubeless, and kubeless will manage all the things on the Kubernetes. Kubeless is deployed on the top of the Kubernetes cluster. So before using or installing the kubeless, Kubernetes cluster should be established. First, we will establish the Kubernetes cluster, and on the Kubernetes cluster, we will deploy the kubeless. Kubeless enables the functions to be deployed on Kubernetes cluster while allowing users to leverage Kubernetes resources to provide auto scaling, API routing, monitoring, and the troubleshooting. So we just need to deploy the functions with the help of the kubeless, and all the benefits, or you can the functionality of the Kubernetes will be managed by the kubeless to support your functions. Kubeless will automatically manage the auto scaling if API routing is required, if monitoring is required, or the troubleshooting is required. Anything we are triggering as a kubeless function, that is execute as regard of the event on the framework, right? When you will execute a particular functions, kubeless will create an event for that particular function and execute on the Kubernetes cluster. So if you want to use the kubeless, then definitely kubeless is an open source framework. This is not the licensed one, right? And you can use it without paying any cost to anyone. Kubeless also have the UI available for the developers to deploy the functions. If you want to use the kubeless UI, you can also use the kubeless UI to deploy some functions which will be helpful for some developers. But I always prefer to work with the CLI, but it again depend on the individual preference, and I always prefer to work on the CLI instead of the UI. Kubeless basically support all major languages. You can write your code in any language. You can use the Python. You can also use the Ruby on Rails. You can use the Node.js. You also can use the PHP and Golang. Apart from this, we also have some other scripting language, but these are the major languages which is being supported by the kubeless to code the functions. One more thing, that kubeless CLI is compatible with the AWS Lambda CLI. Once the function is deployed, user need to find out how to trigger these functions, right? Although you can create the functions easily, but we need some way to trigger these particular functions. So currently below mechanism are available to support the functions. The first mechanism is pub/sub triggered, which is being used as a Kafka and the nets. Then we have the HTTP triggered, which is to expose as a Kubernetes service. And we have the schedule trigger, which is a cron job. So these are the ways how we can trigger the function inside the kubeless. So thank you team, thanks for your time. In the coming lecture, I will show you how we can install the kubeless on the Kubernetes and how we can create some function and deploy these functions on the Kubernetes. Hello team, welcome back. In the last lecture, we have discussed few application of the kubeless, and today we are going to install the kubeless and we will deploy some functions on the kubeless and trigger them. So let's start with. So as a part of this particular lecture, we are going to execute the kubeless or install the kubeless on the Kubernetes. And what is the prerequisite to install the kubeless? And the prerequisite is Kubernetes cluster should be in the healthy state. So first we will check what is the health of my Kubernetes cluster. We will also check if RBAC is enabled or not. If RBAC is enabled, then definitely there is no problem. But if RBAC is not enabled on your cluster, then you need to enable the RBAC on your cluster. After this, we will install the kubeless on the Kubernetes cluster. So let's do this much of work. And to execute this much of work, I have created a document, and I will post that particular document as a text direction after this particular lecture so that you can also refer the commands and the files which we are using. I will validate my cluster by a command kops validate cluster -- state and define my S3 bucket. You can see it is executing the kubectl in context of my cluster name level360degree.uk, and my cluster is in a ready state. Now I will check the RBAC status on my cluster. For this, I will execute kubectl API-versions. And you can see the RBAC APIs are enabled on my cluster. When you are executing kubectl API-versions and if you are not getting the RBAC authorization K8s, Vita and V1 API enabled on your cluster, then it means you need to enable this particular API on your cluster. We have already discussed about this. Let's clear out the console. Now let's go to the document which I have prepared. So here is the document which I have prepared to install the kubeless on your cluster. First, we need to validate the Kubernetes cluster health, which we have already done. Now we need to download the kubeless release on my machine. So this is the URL which we are going to hit to download the release. So let me open this particular URL. So we are on github.com.kubeless and you can see this is the kubeless public repository. If you will scroll a bit and you will go to the releases, then we have total 41 releases available. And this is the latest release what we have over here, right? Let me open this particular release. When you scroll a bit, you will get some documentation, some commands, and then we have the zip files. So as we are using the Linux system, I'm going with this particular zip. If you are using any another kernel, then you need to download another YAMLs as well, right? I'm going with this particular zip, kubeless linux amd64.zip. I will click this and copy the link of this particular zip. Now I will go to my terminal and type wget and provide the URL which I just copied. You can see it will download the kubeless linux amd64.zip. Clear out the console and hit ls to list out the files and see kubeless linux amd64 zip is over here. Now what we need to do, we need to unzip this particular file. I will execute a command unzip, then define the kubeless zip file name. Hit enter. It is saying unzip is not available. It means the unzip package is not installed on my machine. First I need to install it. I will install it. In your case, it may possible you will get this error, or it may possible you will not get this particular error, right? If unzip package is installed or available on your OS, then you will not get this particular error. I will clear out the console and again execute the unzip command. You can see it has created two files: bundles Kubernetes Linux AMD64 and bundle Kubernetes Linux AMD64 kubeless. Now put ls and you can see we have the bundle directory over here. I will go to this particular directory, put ls. We have the kubeless Linux AMD64. I will go to this particular directory, put ls, and over here we have the kubeless binary. Let's clear out the console again. Execute pwd. So we are inside the root bundles kubeless Linux AMD64. Now we have done this much of work. We have unzipped the latest download. Now what we will do, we will move the kubeless binary to the bin directory of my OS. For this, you need to execute the command sudo mb, define the complete path of your binary. In some cases it not be like this, right? You need to define the complete path of your binary where your binary is present. In my case, it is present root bundle kubeless Linux AMD64, right? And after this, you need to move that particular binary at this particular location on your OS, user local bin, where all the binaries present for your OS. So I will execute the command sudo mb for the move, right? Then I will put root bundles. Inside the bundles I have the kubeless, and inside the kubeless I have the binary kubeless. I will put this particular binary at user local bin. Hit enter. Let's go to the user local bin, cd, and this particular directory, put ls, and you can see the kubeless binary is being copied over here, right? Let's clear out the console. Now what we need to do, we need to remove the bundles directory. So let's go to the root directory, ls. We have the bundles over here. What I will do, I will execute rm-rf bundles. Hit enter, put ls again, and you can see the bundle is being deleted from this particular location. Now what I need to do, I need to create the kubeless namespace. I will execute my kubeless in the another namespace which is called kubeless. So I will execute this particular command on my Kubernetes cluster, and you can see namespace kubeless is being created. If I will execute a command kubectl get ns, hit enter, then you can see I have three default namespace and another namespace is being created 12 seconds ago, which is called kubeless. After this, we need to execute this particular command. And what this particular command will do, use one of the YAML manifest found release page to deploy kubeless. It will create a function, custom resource definition, and launch a controller. So what we need to do, we need to execute any YAML which is present on the release page. So let's go to the release page again. And over here we have few YAMLs. Kubeless version 1.0.4 YAML, kubeless OpenShift, kubeless non-RBAC. So if you are using kubeless on non-RBAC mode, you need to execute this particular YAML file. If you are using kubeless with OpenShift, you need to execute this particular file. And if you are using Kubernetes with the RBAC, then you need to execute this particular file. I will copy this particular location, copy link address, go to my terminal and execute a command kubectl create -f and then provide the URL of my YAML file. What this will do, basically this will create all the things which are present in this particular kubeless version 4.yml. If you want to see, we can download this and open this as well. So I will do one thing, I will download this on my host machine and I will open this. So this will look like this. This is the YAML file which is RBAC authorization ktest.io. First, it will create a cluster role. Cluster role name will be like this: kubeless controller deployer. They are the rules: API group none, resources, services, and config map, verbs create, get, delete, list, update, patch, API group apps extension, resources deployment, and these are the verbs which will be applicable for the deployments. Then API group is nothing. We have the pods. On the pods, list and delete. Then we have the resource name kubeless registry credential, and it will use this particular credential, right? If we will go a bit, then we have another which is cluster role binding. Over here we are binding the role. Then we have the customer resource definition. We have multiple customer resource definition, and over here we have a lot of things. You can see runtime images are this. So this is the pre-configured YAML file. What you need to do, you just need to execute this particular YAML. Hit enter. This will take some time, and you can see this has deployed this much of thing. First, it has deployed RBAC authorization, kubeless controller deployer. Then it has deployed cluster binding of the kubeless controller deployer. Then customer source definition of the functions kubeless, customer source definition of the HTTP triggers, customer source definition of the cron jobs, right? You can see the HTTP triggers and cron jobs are the triggers, how we can trigger the function, and function is itself a function object which is being deployed. Now we have the config map called kubeless config. We have the deployment called kubeless controller manager, and we have the service account called kubeless account created. So these are the things which is being deployed as a part of this particular YAML file. If you want to see, you can execute a command kubectl get all define namespace kubeless, because all these things has been created in the namespace kubeless, right? Hit enter, and you can see one pod is running, right? And three replica of running this particular pod. Then we have the deployment apps, one is running. Then we have the replica set, one is running. Clear out the console. So we have done this much of work, right? Now what we will do, let's go to the slides again. So now we will create some sample functions inside the kubeless. So here is the sample function which is in Python. You can see inside the Python I'm defining a function with the help of the def. The function name is hello. It is accepting two parameters, event and context. First, it is printing the event, then it is returning the data which is present inside the event. So every time whenever we are defining the kubeless function, we must need to define the event and the context. So functions in the kubeless have some format regarding of the language of functions or the event sources. It means the functions in the kubeless have some format. It doesn't matter that they are written in the Python, in Node.js, or in some other language. Functions will receive an object called event. You can see over here we are already receiving an object called event as their first parameter. This parameter include all the information regarding the event source. In a particular, the key data should contain the body of function request. Over here, when we will execute this particular function, all the things which we will supply to this particular function, the data key will handle that particular information for me. It will also receive a second object called context with the general information about the function. So inside the context, you will set the general information about the function, but the structure should be same. right? Every function which you are defining inside the kubeless, they must have the event and the context, and it will return the string or object that will be used as a response for the caller. You can return anything, either you can return the string or you can return the object itself, so that that particular object or string will be used further by some other application or being consumed by some other functions. And to execute this particular file, what user need to do? User need to save the above code file and can deploy that with the below command. The command which you need to execute this particular function is kubeless function deploy. Define your function name hyphen runtime, then define the runtime environment. As this particular function is a Python function and I want to execute this particular function with the Python 2.7, then I will define hyphen from file. I will define the file name of my function, in which particular file I have stored that particular function. Then I am defining the handler which will handle this particular function. So this is the command which we need to execute this particular function. So let's do one thing. Let's go to the terminal. Over here I will create a directory mkdir and I will call it kubeless functions. I will go to this particular directory kubeless functions. Over here I will create a file vi hello.py, right? And over here I will write down that particular code which is def hello event context. Then I will print the event, and after this I will return the event. And the key what I want to return is the data. So this is my complete function. I will save this particular file, put ls hyphen lrt. You can see this particular file just have the read and write permission. I need to provide this particular file as a executable permission. I will push chmod 777 to my hello.py file. Again ls-lrt, and you can see this has the read, write and executable permission for user and group. Let's clear out the console. Now to execute this particular function, I need to execute this particular command, right? I will copy this particular command, and this command is saying kubeless function deploy, which means deploy a kubeless function. The function name will be hello. You can name it anything. If you want to change it, I can change it as well. So let's change it hello python. Then I'm defining the runtime environment, and for runtime I'm defining python 2.7. If you want, you can define any other python version as well. And from file I will define the file name over here, which is hello py. If you are executing this particular function from some other directory, you need to define the complete path of your file. You need to define the complete path where your particular file is present. Then I will define the handler, and handler is test.hello. Why I am not defining the complete path? Because I'm executing this particular command from the directory kubeless functions which already have this particular file. Hit enter, and you can see we are getting the message deploying functions hello python submitted for the deployment, and check the deployment status executing this particular command. It means my function deployment is being created. If I want to check it, I simply need to execute this particular command kubeless function ls hello python. I will execute this. Then you can see hello python function is present, the namespace is default, handler is test.hello, runtime environment is python 2.7, and this is the status which is not ready. So we have executed this particular command. Over here the hello is the function name, the runtime python is the environment which I want to supply to my function as a runtime environment. The from file is the file name, right? In my case my file is present in some other directory. Then I need to provide the complete directory path of my file, and handler is the handler name that is exposed to the function, and it will receive the request. If you want to describe the function, you can execute a command kubeless function describe, then function name. If you want to call this particular function by the kubeless CLI, you can execute the command kubeless function call, define your function name hyphen data, and define the data which you want to supply to your function. If you want to list out the function, you can execute the command kubectl get functions or kubeless function ls, right? You can see we are using the both CLI. We can use the kubectl as well, and we can use the kubeless as well. So let's go to the terminal again, and if you want to describe this, let's execute a command kubeless describe function and define my function name, which is this. Oh, there's a mistake. The function should be present before the describe. Hit enter, and you can see over here my complete description of my function. The name is hello python, namespace is default, handler is this, runtime environment is python 2.7, label is being created by kubeless, function name is this, event variable is null, memory is 0, dependencies is nothing. Now if I want to execute this particular function or I want to trigger that particular function, then how can you trigger it? You can trigger it by command kubeless function call, define your function name. I want to define my function name, define the data, and you can pass the data which you want to supply to your function. So suppose I'm supplying hello, this is Anshul from Udemy and I want to talk to you. Hit enter. You can see this is printing my result. Hello, this is Anshul from Udemy and I want to talk to you. Why it is printing my result? Because as per my Python function definition, you can see I am printing the event. All the values which I supply to this particular function, this will print that particular function on the console. If you will again execute a command kubectl ls, then function name, you can see the function is ready. Earlier we was getting the status not ready. Clear out the console. If you want to supply some other data to your function, and suppose we want to supply hi function, we are playing around kubeless, and next we will see the microservices. Hit enter and you can see it will print all the data which will supply to this particular function. Hi function, we are playing around kubeless, and next we will see the microservices. So this is the way how can you deploy the function and directly call your functions, right? You can see I'm not executing any container to run this particular code on my machine. Kubeless is managing all the things by itself. If I will execute a command kubectl get all hyphen namespace, then you can see internally a pod is running which is called hello python. A service is also running which is called hello python. This is being exposed on port 8080 TCP protocol. A deployment is running hello python and a replica set is running hello python. Although we just deployed a function on my machine, but internally it is deploying and managing all the things by itself. As I told you in the earlier lecture that serverless is also work on the same manner. It will deploy the container on the fly, right? But it's not your responsibility. As soon as this function use will be done, this will terminate all these containers and all these deployment or the resources which is being created in reference of this particular function. Let's clear out this. If you want to list out all the functions, you can execute a command kubeless function ls. There's a mistake in the command. This should be function, right? So we have just one function hello python. If you want to see the same thing with the kubectl CLI, you can execute a command kubectl get functions. Hit enter and see it is executing, and see it is returning in the function name. Over here we have the kubeless function, and over here we have the kubectl get functions. This is a small difference in these particular commands. Now if you want to delete that particular function, you can execute a command kubeless function delete, define your function name, hit enter, and it will delete your function. Let's execute the list command again, and nothing is over here, right? So you can deploy all the things, all the functions on the fly. You can use your functions and you can simply terminate your functions. This is called serverless technology on the Kubernetes. All the cloud providers, AWS, Google Cloud, Microsoft Azure, they are providing all kind of facilities to execute these kind of functions on their cloud. So thank you team, thanks for your time. Hello team, welcome back. In this section, we will discuss about the microservices. We will see what are the microservices and how we will handle the microservices on the Kubernetes cluster. So let's start with. First, let's discuss about the microservices. So in Kubernetes, we can deploy a variety of the application. We can deploy the services which are the standalone application. It means the application which are working in itself. The application don't need to interact with the other application and they are doing their job as per the user requirement. Now we have the other kind of services which is called microservice. Microservice is something where small services are making an application. In an application you can have a number of microservices. So till now we have seen that how we can work with the standalone application. We have executed the MySQL, we have executed the WordPress, we have executed the Nginx, and there is a lot of application we have executed in the Kubernetes lectures. But till now we have not executed any microservice, or we have not seen the microservices part as a application. So we will see how we can deploy the microservices and how microservices will work as a unit to create an application. We also need to discuss why the microservices requirement is important on Kubernetes, because microservice architecture isn't very popular in these days, right? And the microservices architecture is being adopted with the many firms. Microservices facilitate developer to split application in multiple chunks and individual processing capacity. It means if we have a big application, then it is allowing developers to divide that particular application in multiple chunks, and every chunk will work as a single unit, and when they will club, they will create an application. So we can see that microservice is a distributed architecture which will decouple your service and execute your service in some parts, and every part will work as it will be requested. We can understand the microservice architecture with this particular diagram. You can see in the green box we have the client, and client is sending the request on the Kubernetes Ingress network. Now Kubernetes Ingress network is basically accounting the request, and it will sending it to the pod account service and pod customer service. You can see over here we have the two pods, and both of the pods are running few containers. One is the MongoDB, another is the account service, and in the customer service pod we have the customer service and the MongoDB. Over here MongoDB service is the separate service for both of the microservices, which is called customer service and account service. We can see this is a single application, but it is working in multiple applications. See, account service is creating their own MongoDB, and customer service is creating their own MongoDB. So in a single application we have the two DB instances, although these instances is being managed by the separate services, right? Inside a particular pod we are creating a single unit to manage these particular services. So this is the simplest microservice diagram where few microservices are working and Kubernetes are handling this. But what we need to do if we have the service diagram like this? Over here you can see there are multiple boxes and multiple database, and we have a single interface for the user interaction, which is front end web UI in the left side of your screen where we have the Chrome icon. So this is a typical service based diagram of the Google Chrome or some another browser. I just take an example of the Google Chrome, although the actual implementation is not like this, but I'm assuming that the Chrome is working in this particular manner. So we can see we have the different boxes, and in each square box we have two things, the pink box and the blue box. Inside the pink box we have the similar kind of service which is called envoy proxy. So just forget about the envoy proxy, we will discuss it later. Just concentrate on the box which is in the blue color, microservices, right? So suppose user is opening the browser, then what user will see? User will see an web UI. That web UI being presented by the microservice called front end web UI, which is in the Angular. Once user will open the browser, user will type something and send the request to the Google Chrome server, right, for the search result. Then Google Chrome will send that particular request to the microservice A, which is maybe written in the Go language, right? And on the basis of the microservice decision, it may possible that it will send the traffic to the microservice C, which is working with the service C database in MongoDB, and service C will send back the request to the microservice A. Microservice A will decide that it need to respond to the user or send the request to some another service, which is microservice B. And then microservice B will send the request to the either microservice E or microservice D. If service request is going to the microservice E, then microservice E will send either request to the microservice G or microservice H, right? If request is going to the microservice H, then service G database will be called, else service H database will be called. If the request from B is going to the microservice D, then it will go into the message queue, which is a rabbit message queue, and rabbit message queue will send the request to the microservice F, and then it is going to the service F database. So over here you can see there are multiple database, there are multiple microservices, but for the user there is a one interface which is web based interface which is running on the Angular, right? So this is a typical microservice diagram. I believe actually this is more complex as it's being stated over here. In real, this is going to be more complex. It's not like that as simple as I have put it over here, right? I'm not saying that the Google Chrome is working in this kind of structure. I'm just explaining an example that how microservices are connected and creating a single application. So over here you can see we have the multiple microservices and they are creating the multiple services. Till now we are not discussing about the envoy proxy. We will discuss about it, but First, let's discuss about the problem with this particular kind of architecture and what are the challenges with the Kubernetes with this particular architecture. So if we are deploying the microservices inside the Kubernetes, then these are the few challenges which you will face. That between the microservices there is no encryption. So data is not encrypted when it is communicating from microservice A to microservice B or microservice D to microservice F. There's no load balancing as well. No failover or auto retries. If some microservices will stuck or they will crash, then there is no failover or the auto retries for the microservices. Routing decision, there is no routing decision that where it should route, which similar to the load balancing. There is no load metrics or the logs that what is happening inside the microservices, what is the load statistics of the microservices, and there is no access control to the service. So these are the few challenges when we are working with the microservices in the Kubernetes cluster, right? How these challenges will be sorted out. So let's go to the previous diagram again. So these challenges will be sorted out with the proxy. Over here you can see with each microservice I have deployed an Envoy proxy. See, all the microservices are being attached with the pink color box, which is Envoy proxy. Envoy proxy will manage all the things for me, either that is a load balancing, that is a network routing, that is encryption, that is authentication, that is access control. I have implemented all the logic inside the Envoy proxy, and each microservice will be attached to the Envoy proxy. How we will do this? If we will implement all these things in a single application, and if our developer will start developing this kind of structure, then it will be more difficult to our developer that it will develop the load balancing, the access control, encryption, and there is a lot of features. There are just few things which I mentioned over here, and tomorrow if there is new requirement, then it will deploy that particular thing as well. So from developer point of view, it will creating your application more heavy, right? And it is consuming the developer unnecessary time. And from the application point of view, it may possible that your module or microservices will start responding slow. So first let's discuss how Envoy proxy is solving our problem. So when the traffic is routing between the microservices, that traffic is not directly landing on the microservice. That traffic is directly landing on the proxy. And then proxy will decide what they need to do with that particular traffic. So proxy is encrypting the data. Proxy is also managing the access control. Proxy is managing the failover. Proxy is managing the load balancing. And there's a lot of features what proxy is managing. And all these proxies are basically connected with then single interface, which we will discuss it that what is that particular framework and how it will work. So we have listed out all the problems with the microservices in the Kubernetes cluster, and we also know the solution, right? We need some proxy which will manage all these things for me for the microservice. But the question is still open, who will implement these proxies? So if it's my application, then I definitely not agree that my developer will do that particular job, because it's another project for the development, and definitely this was not my goal in my application. So to solve this particular problem, we have a framework which is called Istio. So Istio is a framework which will provide service mesh several capabilities for traffic monitoring, access control, discovery, security, resiliency, and other useful to the bundle of your services. Why I am calling it service mesh? Because you can see in that particular diagram we have a multiple service, and as a single unit we call it service mesh. Istio deployed for the microservices without any change in code of the microservice. It means if we are using the Istio framework in the Kubernetes with the microservice application, then we don't need to do a single line of code inside my microservice. Istio will manage all the things for you. And to make it possible, Istio deploy an Istio proxy called Istio sidecar next to each service. This is the thing which we are doing over here. Earlier, we know that we need to enable the proxy, but who will enable that particular proxy? Who will deploy that particular proxy in front of my microservice? Istio will do that particular job. Istio will deploy an Istio proxy on front of my microservice, and that particular proxy will manage all the things for me. This is called Istio sidecar. So the proxy name which Istio will deploy, this is a Istio sidecar proxy we can call it sidecar proxy. That particular sidecar proxy will manage all the things for me. There's a lot of features, as I told you, the access control, monitoring, discovery, security, resiliency, and there's a lot of things in that particular proxy. All the traffic meant to assistant is directed to the proxy first, which uses policy decide how, when, or if the traffic should be deployed to the service. And the same thing which I told you, that traffic first directed to the proxy, and proxy will decide how they want to handle that particular traffic, when they want to handle it, in what way they want to handle it. Either they want to submit to the traffic to the next microservice, or they just want to respond to the customer back. Let's discuss how Istio works with containers and Kubernetes. So Istio service mesh, as suggested, uses sidecar container implementation of features and functions required mainly for the microservices. This is the high level diagram of the Istio. You can see we have an array of services, right? In the bottom we have two array of services which are using HTTP, gRCP, TCP without TLS protocol. These array are the pods, right? You can see over here, and in a single pod we are running a single microservice. We have two box, service A and service B. Inside a single microservice we are deploying the Envoy proxy, and we can also call it sidecar proxy. These sidecar proxy are managing the traffic and all the things between the microservices to the microservices, or application to the microservices. You can see this is a two-way traffic. In a single unit, you can handle that particular sidecar with the help of the HTTP, gRPC, TCP, or without TLS protocol. Then we have the upper layer, which is called control plane REST API layer. In that particular control plane REST API layer, we have the mixer, which is basically working for me. So all the proxies are basically connected to the mixer. They will further connect it to the pilot REST API and the Istio auth. Istio auth will manage all the TLS certificate, or the certificate which is required to manage the proxies. If you are deploying the proxies in the production, then definitely you need to mention some kind of certificates so that you can keep your application and data secure, right? All the policies check and the complementary work is being handled with the mixer, and all kind of traffic redirection is being handled with the pilot. So Istio is working with a very simple architecture. With each microservice, it will deploy an proxy, and that particular proxy will directly communicate to the control plane REST API of the, and the control panel of the Istio have the three blocks: the pilot, mixer, and the Istio auth. So thank you, team. Thanks for the time. We have discussed about the microservices, the challenges in the Kubernetes with the microservices, and the solution for these particular challenges. In the coming lecture, I will show you how we can deploy the Istio on the Kubernetes cluster. So thank you, team. Thanks for your time. Hello team, welcome back. In the last lecture, we have discussed about the microservices, and we have seen the framework which we will use to handle the microservices challenges on the Kubernetes. And in this lecture, we are going to install that framework which is called Istio. So we will see how we can install the Istio on the Kubernetes cluster. For this, I have created a very handy document. So we need to follow the commands which I have mentioned in that particular document so that we can install the Istio on the Kubernetes cluster to handle the microservices on my cluster. So here is the document which I have created to install the Istio on Kubernetes cluster. And the first command is we need to deploy the cluster with the medium machine, right? So Istio will consume a lot of memory on your cluster. Until now, we are using T2.micro as a worker node. We need some more memory to work with the Istio. T2.micro have the 1 GB RAM, and Istio will not work on the 1 GB RAM. So we will deploy two nodes of the T2 medium size, which will have 2 GB per node. So at the end in my cluster, if we are working with the two nodes, then we have the 4 GB RAM on two nodes. So if Kubernetes cluster is already running, then you need to modify your cluster and you need to add few more nodes in your cluster, which will have T2.medium as a worker nodes. And if you have terminated your cluster to save the cost, then you need to deploy a new cluster with this particular command. So I will go to the terminal and paste this particular command. The command is kops create cluster, which is cluster creating command. I am defining my S3 bucket where I need to create the configuration of my cluster. Then I'm defining zone, AP South 1A, South 1B. You can modify your bucket and zone. Then I'm defining the node size, and you can see this is T2.medium. I can take the master as a micro because Istio will not work on the master. Then I have the master count 1 and node count 2. Authorization RBAC will be enabled on my cluster because I am going to use the Helm in this particular cluster as well. This will be the name of my cluster, and the yes to show the console logs of the cluster. Hit enter. This will deploy your cluster of 3 nodes, 2 worker and 1 master node. It will take up to 10 to 15 minutes, so we have to wait until the cluster will be deployed and it will be in the healthy state. So now we will check the health of my cluster. I will clear out the console and I will hit the command kops validate cluster and define my S3 bucket name. Hit enter. It is validating my cluster and my cluster validation is still failing. I have to wait for a few minutes. Till then my cluster will be ready. Over here we are getting the message as well. Please wait for 5 to 10 minutes for master to start, right? So we have to wait until my cluster will be ready. We will check the cluster health again. It is checking my cluster health and my cluster is ready to use. Let's clear out the console and go back to the document. So now we need to install the Helm on my cluster. I have created my cluster and checked my cluster. So I will download the 2.14.1 release of the Helm. I will copy this. Now I will execute this particular command to download the tar file. If I will put ls, then you can see Helm version 2.14.1 is being downloaded. What I will do, I will unzip this particular file. For this, I will execute a command tar hyphen xz vf and define my Helm version. Hit enter. So you can see it has been extracted all the things in a directory which is called Linux AMD64. Till now, no Linux directory is being present over here. If I will put ls again, then you can see Linux AMD64 is being created. I will clear out the console and as per the document, I will move Helm binary from Linux AMD64 to user local bin. Right? I will copy this particular command. But before this, let's go to the Linux AMD64 to verify the content of it. Put ls. You can see over here we have the Helm, tiller, license and readme.file. If I will go outside this and execute a command tree Linux AMD64, then this will show you the files and structure as well. The directory is Linux AMD64, then we have the licenses, then we have the readme.file, then we have the Helm and then we have the tiller. I will copy the Helm binary to the user local bin. Hit enter and it's being done. If you will go to the user local bin, put ls, then you can say Helm should be present over here. See, Helm is here. I will again go back to my root directory where Linux AMD64 is present. See, clear out the console. And now I will verify with the command helm-h. Because I have already appended the directory in my user local bin, so this command should work and this is working fine. You can see over here, if you want to verify the version, you can execute a command helm version, right? And this version of the Helm is installed on your machine. Although we are getting the error of the tiller because tiller is not initiated till yet, right? We have installed the version 2.14.1 on my machine. Now what I need to do, I need to initialize the Helm, but before initialize the Helm, I need to set up few rules and bindings on my cluster, which is with this particular command kubectl create -f helm rbac.yaml. See, rbac file is here. This is the RBAC file which will create the service account. The name of the service account will be Helm Tiller and it will create the service account in the namespace cube system. And on that particular service account, this will execute the role binding for this particular cluster admin role, right? So I will copy this and on my terminal, I will create a directory called Helm install. Go to that particular directory, Helm install. This should be Helm install. Over here, I will create a file called helm rbac.yaml. And in this particular file I will copy this particular content, right? So you can see I'm creating a service account and assigning cluster admin root to that particular service account. Further, I will attach this particular service account with my Helm. Now as per the document, I will execute this particular YAML file, hit enter, then you can see a service account is being created. After this, I will initialize my Helm with this particular service account Helm Tiller, which we just have been created. See, Helm Tiller service account we have created, so I will initialize my Helm with this particular service account, and this service account by default have the cluster admin role as per my binding. See, this have the cluster admin role. I will initialize the Helm and it is saying Tiller has been initiated on your Kubernetes cluster. If you will execute again Helm version, then you will not get that particular error. See, I'm not getting the tiller error right now. The client is this, which is version 2.14.1, and server is this, which is version 2.14.1. Server means tiller server and client means Helm UI client. Let's clear out the console. Once you will initialize the Helm, you need to verify that Helm pod is running or not. So you will execute a command kubectl get pods -n, which means namespace, and namespace is kube system because Helm will install inside the kube system namespace. And over here you can see tiller deploy particular pod is running on my Kubernetes cluster. So till now we have created the system, we have installed the Helm, and now we are going to install the Istio. team, although there is a multiple ways to install the istio, but I always prefer to install the istio with the helm, because helm is the package manager and it will deploy all the things for me. Otherwise, to install the istio, I need to execute a lot of command, I need to execute a lot of YAML files, a lot of zip files, right, which will not be sufficient sometimes, because this will be a long process and it required a more manual effort. So I always prefer to install the istio with the help of the helm. Over here you can see we are executing the commands on the terminal. If you want, you can simply create an shell file and that shell file do all the jobs for you. So to install the istio with the helm package, you need to execute this particular command: helm repo add istio.io, then define this URL. Storage Google APIs istio release, then releases 1.3.0 charts. What is this URL? So first let's go to this particular URL. I will copy this istio releases, go to my browser and hit enter. You can see this will list out all the releases which is present for the istio. If you will scroll back and go to the bottom of this page, then we are getting istio init tar files. If you will scroll a bit, then over here you can see the release version we are getting, and till date the release version is 1.3.0. If I will search for this particular text on this particular page, then you can see this has the charts index.yml, this has the chart istio 1.3.0 tar file, this has the istio cni file which is also a tar, this has istio init file which is also a tar, right? So these are the files which we have inside this particular release. Let's go to document again and hit this particular command. What this particular command will do, this command will enable you to use the helm chart into the repository called istio.io. So if you will execute a command helm repo list, so till now we have the stable, we have the local, and we have the unsure charts. If I will execute this particular command, you can see istio.io has been added to your repository. If I will again list out the repos, then a new repo is being added istio.io, and this is basically redirecting to this particular URL. We have seen that particular thing earlier when we have deployed our own repository, our own S3 bucket. So we have deployed this particular thing. This is also an URL for the repo. This time for the istio.io downloading, it is downloading the resource from this particular URL, and for my chart it will download the resource from this particular URL. I will clear out the console. Once this will done, I will check the repo list. This is done, and after this I will install the ECU customer resource definition which is called creds with the istio init chart. For this I will execute this particular command helm install name istio init namespace istio system, and in this particular directory I will call istio init. Copy this and put it here. What this command is doing, you can see by helm install it is installing some package. The package name will be istio init, and it will create a new namespace called istio system. And what it is installing, it is installing inside the istio.io repository we have the istio init. So there will be a multiple package of the istio init. It will download and install all the istio init packages. The same thing I mentioned over here. This command commits 53 creds to the Kube API server, making them available for use in the istio mesh. I will hit enter. So this will start downloading, and you can see this is done. So over here you can see what resource are being done. It has created a cluster role, then created a cluster role binding. It has created 3 config map. It has executed few jobs, which is init crd 10.1.3, 11.1.3, and 12.1.3. Then it has created some pods. It has also created an service account which is called istio init service account. Let's clear out the console. And if you want to check that all of the required creds have been committed, then you can run this particular command: kubectl get creds grep istio.io cert manager kds.io. Hit enter. It will list out all the creds. So these are the creds which are being basically deployed with this particular command. If you will put the count, if you want to see the count, you can execute wc-l, and over here 23 creds are being created. If you want to see all the resources which are being done, you can execute a command kubectl get all -n, which is the namespace. And what is the namespace I have created? I have created the namespace name istio system. Hit enter. Then you can see these are the pods which are running, and these are the job batch which are running in this particular namespace. Clear out the console. After the cred, now we will install the istio chart. and we will ensure that Grafana telemetry add-ons is installed on the chart. We will use set space grafana.enabled equals to true inside the configuration of the helm install command. So I will install this particular command to install all the charts of my Istio directory. And over here you can see helm install will install the Istio. The name of this installation will be Istio. Namespace it will use Istio system over which we have created the cred. It will set the Grafana enabled equals to true. It will download the charts from this particular repo and this particular URL. You can see if you will go to the browser again, then over here we have the index.yml. In this particular charts we have the istio.tar file. So this will download this particular thing, and Grafana will be the UI based application which will show you the monitoring of your Istio. Hit enter. This will take some time to download all the resources, and you can see over here we are getting the message namespace Istio system status deployed, and it has deployed this much of service. Few cluster roles are being deployed by this particular Istio installation: Istio credential, Istio system, gallery, Grafana, mixer, pilot, reader, sidecar injector, and Prometheus Istio system. Then few cluster role bindings for the above roles, which is Citadel, Gallery, Grafana, Mixer, Multi-Pilot, Sidecar, and the Prometheus. Few config maps are also being installed by this particular system. Few deployments are also being deployed for this particular system. Few pods are also being deployed, and few roles, role bindings, services. There's a lot of things which is basically installed by this particular installation. If you will clear out the console and again execute the command kubectl get all -n istio system, it means list out all the things which are running in this particular namespace. Then you can see these things are running in this particular namespace. There's a lot of things. See, these are the pods which are running as a part of this particular system. Some has been completed and some is running. These are the services which is running: Grafana TCP on this particular port, ClusterIP. There's a load balancer as well, right? You can see this is the load balancer which is running, which is Istio Ingress gateway. Then other services are only the ClusterIP. These are the deployments which are running. These are the replica sets which are running. And over here we have the few scalar which are running. Then we have few jobs which are running. So inside the Istio system namespace, there's a lot of things which are running in my cluster. And that's why I told you to create the T2.medium machine, because it will execute a lot of things in itself, and then we have the application load as well. If you will go to your EC2 dashboard, then you can see a load balancer is running over here. If I will open this load balancer, then this is the same load balancer which is being deployed as a part of this Istio. If I will copy this load balancer DNS, press Ctrl F and Ctrl V, then you can see I'm able to find it. And this has the port configuration. This has the multiple port configuration: port 80, port 443, 15020, 15029, 15030, 3132, 43, 31400. The same ports are being listed over here. You can see all the port configuration are over here, which are the TCP ports. None of these ports is the HTTP port till now. So why this way we can see the Istio is successfully installed on my machine. Now after this, if you want to verify the services which are running on your Istio system, then you can execute this particular command, get services. So these are the services which is running as a part of your Istio. If you want to see the pods which are running as a part of your Istio system, you can execute this particular command, and these are the pods which are running as a part of your Istio system. We have a note here as well. If you see unexpected phase of the status column, suppose some of the pods are in the failed state and some of the service in the failed state, then you can describe these particular pods and you can also get the logs of these particular pods. Now after this, what we need to do here is the final step, and in the final step of the Istio installation, we will be enabling the creation of envoy proxy, which will be deployed as a sidecar of service running in the mesh. So basically till now we have installed the Istio, but till now we are not providing any kind of permission on my Kubernetes cluster so that it will attach envoy proxy with each of the microservice. So we will enable that particular thing as well. There are two ways to accomplish this particular goal. One is the manual sidecar creation injection and another is the automatic sidecar injection. We will definitely go with the automatic sidecar injection, and for this you need to create the application object with the label Istio injection enabled, right? We will use the default namespace to create our application object, and we will apply that particular label on the namespace by the following command: kubectl label namespace default Istio injection enabled. By default, I am making that injection on my default namespace. And over here you can see this particular thing is being done. The namespace default is being labeled. If you will execute a command kubectl get namespaces -l stio injection, which we just enabled, hit enter, then you can see stio injection is being enabled on my default namespace. If you want to enable the same thing on the stio namespace, you again need to change the name over here from default to stio system, and that particular injection will be enabled on my stio system. But we don't need that particular thing because all the pods, all the services, all the microservices are going to deploy inside the default namespace. So this much of work we need to execute to install the stio on my Kubernetes cluster, right? And these are few labels which we need to attach with my default namespace or the namespace which I want to use with my Kubernetes pods and Kubernetes services. So team, that's all for the day, and in the coming lecture I will show you how we can deploy sample application and how we can use the Istio with the microservices in that particular application. So thank you team, thanks for your time. Hello team, welcome back. In the last lecture we have installed Istio on Kubernetes cluster, and today we will see how we can deploy the application and how we can enable the Istio on the application. So let's start with. So with Istio mesh in place and configured to object sidecar pods, we can create an application manifest with a specification for our service and deployment object. It means to apply the Istio on the configuration or the sidecars of the pods on the deployment. First, we need to create the deployment object. We will create the manifest file for the deployment, and then we will deploy the manifest file. So let's see what we are going to deploy in this particular exercise. So here is the manifest file which I have created for this particular lecture. The name is nodeapp.yml. You can see first I am creating an service. The service name is Node.js. It is also labeling an application which has the name Node.js. Inside the selector, I am selecting the app Node.js. This service will be accessible on port 8080. After this particular service, I am creating a deployment. The name of my deployment will be Node.js, and inside the specification I'm defining the match label app node.js, which is this. Inside the template I'm defining the template of my service, the version is v1, and inside the containers I'm defining the name node.js. Then I'm using my own image, Anshul DevOps Istio demo latest image. If I will go to my hub.docker.com, then I have created an image Anshul DevOps Istio demo. Let me open this particular image. You can see this is being pushed with the latest tag, the same image I'm using in my deployment, right? And this is executing on container port 8080. So this is the deployment manifest, right? We will deploy this manifest file later on this particular lecture. First, let's see how we can enable the Istio with this particular deployment. So to access to the cluster and routing to a service, Kubernetes uses Ingress controller and resources. But when we are working with the Istio use a different set of objects to achieve the similar end. Instead of using the controller to load balance the traffic, Istio mesh uses the gateways which function as a load balancer that handle incoming and outgoing HTTP and TCP connection. In the earlier lecture when we was installing the Istio, we have seen that an load balancer was installed and that load balancer was opened on multiple ports, right? So that will be work as a gateway for the Istio. The gateway then allow for monitoring and routing the rules to be applied to traffic entering into the mesh. That particular gateway will monitor and route the rule for the traffic that are going to access my mesh or the microservices. Specifically, the configuration that determines traffic routing is defined as a virtual service. So we will define a virtual service as well, and each virtual service include routing rules that match the criteria with a specific protocol and destination. So what we will do, we will define a gateway, then we will define a virtual service. We will depend the virtual service on the gateway, and with the help of the virtual service, we will manage the routing rules. To allow the external traffic into the mesh or configure the routing to our Node.js app, we will create the Istio gateway and virtual service. So in the similar way, first we will define the gateway manifest file, and we will deploy the Istio object manifest file as well. So here is the another file named node-istio.yml which I have deployed for this particular gateway and virtual machine of the Istio. You can say I'm taking the API version networking istio.io v1 alpha 3. I'm taking gateway, then I'm taking Node.js gateway, This will be the name of my gateway, right? Then inside the specification, I'm defining selector istio ingress gateway. This will be the default gateway for the istio gateway, because when we have deployed the istio cluster, and gateway with this particular name is also being deployed, right? And we know very well that what selector will do, a selector will match the resource with the default istio ingress gateway controller that was enabled with the configuration profile we selected when installing the istio. Then we will define the servers, and inside the servers we will define this particular detail, that is servers specification that specify the port to expose for the ingress and the host exposed by the gateway. In this case, we are specifying all hosts with asterisk since we are not working with the specific secured domain. So inside the host, we are defining asterisk. It means this particular gateway have the access to all the hosts, and this is going to access on port 80 and protocol HTTP. After this, I'm defining an virtual service. The API version will be same, which is as per the gateway. I'm going to define this virtual service name Node.js. Over here, I'm defining the specification of this virtual service. And what is the specification of the virtual service? We are defining the host, a host field that specify the destination host. So we are defining all hosts, right? In this case, we are again using the wildcard value asterisk to enable quick access to application in the browser, since we are not working with the domain. Then we will define the gateway, and over here we will define the gateway name which we have deployed. See, this is the same gateway name which we have deployed over here earlier, this particular virtual service. And then we will define the route network to that particular gateway. So we are defining HTTP route, and the destination is Node.js. Why the destination is Node.js? This destination is basically related to the service. You can see over here inside the application we have created a service called Node.js. The same service name we need to define over here. A destination field that indicates where the request will be routed. In this case, we will route to a Node.js service. So basically, when Istio will hit the gateway, it will hit the virtual machine, and virtual machine directly hit the service, right? And on service, my application is accessible. So we have defined two manifest files. Now let's go to the third manifest file. So once you have created the application service and deployment object along with the gateway and virtual machine, you will be able to generate some requests to your application and look at the associated data in your STO Grafana dashboard. Right now, we are going to define the manifest file for the Grafana dashboard. Till now, if you don't want to define the dashboard, you can execute both of these manifest file and you can access your service on LoadBalancer IP and port 80. But I would like to show you the dashboard as well so that we can see the traffic which is coming to my service. First, however, we need to configure Istio to expose Grafana add-on so that you can access the dashboard in your browser, right? And we have already exposed the Grafana add-on when we were installing the Istio in the command where we have enabled the Grafana. Now we need to create the manifest file for the gateway and virtual machine so that we can expose the Grafana add-on. So for the Grafana as well, we need to create another gateway and another virtual machine, right? For this, I have already created a manifest file. See, the manifest file name is Node Grafana. What we are doing over here we are creating an API gateway, and over here we are creating an gateway. The name will be Grafana gateway, and the namespace is Istio system. We need to make sure that Grafana gateway and virtual machine should be execute in the namespace Istio system, because Grafana add-on was enabled on that particular namespace, right? That was not enabled on the default namespace. Earlier we was running the gateway and virtual machine on the default node space. See, over here I'm not defining any namespace in this particular YAML file. So I'm going to use the STO namespace or whatever the namespace you have created during your STO installation. Inside the selector, I'm defining the ingress gateway, which is the same as per my last comment. And I'm going to open this particular gateway on port 15031, right? If you will go to your AWS console, log into your account, go to the EC2 dashboard. Here the load balancer is running, which is being deployed as a part of the STO. If you will scroll a bit, then you can see over here I'm mentioning 15031, right? The same port is being opened on my load balancer. See, and this is saying 15031 TCP forwarding to the 32099. This is the part of the STO installation. This is the part of the YAML services which is being deployed on this particular as a part of the installation. That's why I have installed the STO with the help of the Helm. Otherwise, I have to execute all these YAML files manually on my system. So we are opening the same port which is a part of my load balancer. The name of this port will be HTTP Grafana. This will accept the HTTP protocol, and host will be asterisk. It means it will accept the traffic on all the hosts. Then I'm defining the virtual service. The name of my virtual service will be Grafana VS. This will use the same namespace as being used by the gateway. Over here I'm defining the host, which is all. Then I'm defining the gateways, and over here I'm defining the gateway which I have created in this particular manifest file. This is this, and this is the gateway, right? Then I'm matching the port 15031 and routing the destination. Host is Grafana and port is 300. By default, Grafana will be listening on this particular port. So I will listen on this particular port. After this, we will create your Grafana resource. We will verify the Grafana gateway in STO system and namespace. We will also verify the virtual services. Once the Grafana resource will be created, we will create the application on cluster, get the application pods, describe the application pods, and create the application gateway and virtual host, right? So let's do this much of work. So I will go to my terminal and create a directory mkdir demo sto application. I will go to this particular directory demo sto application, put ls. There is nothing in this particular directory. First I will copy the grafana node file yaml, and I will create the file node hyphen grafana. You can take the name anything whatever you want. Hit enter and paste this particular content over here. You can see over here I'm creating the gateway and virtual machine inside the namespace sto system. So I will save this particular file. Now I will execute this particular file like kubectl create -f node grafana yaml. Hit enter. You can see gateway networking sto grafana gateway and virtual service grafana vs is being created. If I want to verify it, I can execute a command kubectl get gateway -n for the namespace and define my namespace name, which is sto system. Hit enter, and you can see grafana gateway is running. If you want to describe it, you can also describe it by a command kubectl describe gateway. See, this is the description of your gateway. The resource version is this. This will be accessible on port 15031. The name is this and protocol is HTTP. Clear out the console. If you want to access the service, you can execute the same command kubectl get, and instead of the gateway we will define vs or virtual service, right? So grafana vs or virtual service is running, and this is accessing the gateway grafana gateway. Host is asterisk, age is 1 minute. If you want to describe that particular thing as well, you can do this. So you can execute the above command, and instead of the get you can define describe. And see, this is the description of your grafana virtual service. See, it is matching the port 15031, accessible on the host grafana 30, and this is the API self link, which is namespace sto namespace virtual service grafana vs. Clear the console. Now we will deploy the application. So I will copy the application manifest, go to the terminal, create node dot application dot yaml, and I will paste my content over here. I am deploying my application in the default namespace. So I will execute a command kubectl create -f node application yaml. Hit enter. This will deploy the service and the deployment. If you will execute a command kubectl get pods, hit enter. You can see pod are being initialized, but we need to see that there is 2 copy of pods are being initialized, 2 copy of each pod. Although there are 3 replicas which I mentioned in my YAML. If you will see, I mentioned in my YAML that there should be 3 replicas, but 2 pod in each replica is being initializing, right? So why 2 pods are running per replica? Because one Envoy proxy is running with a particular pod. It means with each pod a proxy is being attached as a STO. If you want to get this, you need to describe any pod. Suppose I will copy this, execute a command kubectl describe pod and define my pod name. Hit enter. Then over here you can see this is the description of your pod. and see, this is my pod name. The namespace is default. This is the node where this pod is running. The label is this, annotations are this, and we can see there is a container attached which is sto proxy. See, sto init and sto proxy is already with this particular pod, right? The IP address is this. This is the container ID. This is the image which is sto init 1.3.0, which we have installed as a part of the last lecture. If we will go a bit, then another container which is sto demo, which is working with this particular pod, sto proxy, which is also working this particular pod. Then here is the readiness, the environment, node.js this, the conditions, the volumes, the OS class, and here is the event logs. You can see sto demo latest is being attached, proxy init is also being attached, then the proxy is already being running as a part of this particular pod, so that we are getting two copy with each pod, right? Because with each pod a single proxy is attached as a part of sto. Now what we need to do, we need to deploy the node sto yaml, right? So I will copy this, go to my terminal, create a file vi node hyphen sto dot yaml, hit enter, paste my content in this particular file, save my file, and execute a command kubectl create hyphen f node sto dot yaml, hit enter. And what this will do, this will deploy the gateway and virtual host. If you will execute a command kubectl get gateway, then it will list out the gateway. Then you can see it will list out a gateway node.js gateway. Why it is listing out? Because I have deployed that particular gateway in the default namespace, right? In the same way we can get the vs, and this is the virtual host which is running in the default as a part of this particular node sto yaml file. Now let's execute a command kubectl get svc, which means the services, in the namespace sto hyphen system. So these are the services which are running in the sto system, and here we have the sto load balancer. Now what we need to do, we need to copy the dns of my load balancer, which is this, or you can copy the ip of your load balancer as well, right? I will copy this, go to the browser and hit this particular dns, and you can see it is opening an web page. This is my node.js application web page, which is everything shark, home, sharks, want to learn about shark, are you ready to learn sharks, and this is the template indexed html which I'm getting over here. If you will click on any link, then it will show you the some information as well. So this is my application. The same load balancer dns you can get from here. You can simply copy this, hit the url, and it will redirect you on a same web page, because they both are same. The load balancer dns which is mentioned over here and the load balancer dns which we are getting on the terminal, they are the same. So this is my application. This is the application which I have downloaded from some community version, and I have created the image of this particular application. Now we need to see the Grafana dashboard as well. So I need to copy the same DNS, and you remember I have opened my Grafana dashboard on port 15031, right? You can see and refer the YAML file. See 15031 over here inside the gateway as well, 15031. If I will hit enter, then this will open my Grafana dashboard. This is my Grafana dashboard which I can use further. You can see over here I'm getting my services. You can see this is my home dashboard. Install Grafana is done. Create your first data resource is done. Create your first dashboard is also done. If you want to install the users, you can use this particular add user button. If you want to install some plugins or apps, you can use this particular thing. If you will go to the home, you are getting a sto folder over here. Let's explore this particular folder, and over here we are getting a multiple things like sto Citadel dashboard, gallery dashboard, mesh dashboard, mixer dashboard, performance dashboard. If I will open the performance dashboard, you can see I am getting the performance of my application. If I will hit my url again and again, then I will get the data over here. You can see we are getting the blocks over here. This is the memory which is being used. This is the cpu which is being used. The virtual cpu is being used. The byte data transfer being used. If I will hit this particular url multiple times, suppose I'm reloading my application and again from different browsers, you will see the spike on that particular performance. Just wait for a time, just wait for a few seconds, and you will see there are some spikes in the data byte transferred. You will see the spike in the CPU as well, and you will see the spike in the memory as well. So from this particular dashboard, you are getting the live monitoring of your application, right? Over here you can put multiple checks which you are required. You can do anything which is required as administrator for your application, right? And you can see all the things that where the load balancing should be done, where the request should be transferred, where what should be the access control of that particular request, all the things being managed from this particular grafana. You can see, right? If you want to open some another dashboard, I can show you that particular thing as well. Let me allow to open some another dashboard. Let's open the Citadel, and you can see over here we are getting this particular. If you will open some another dashboard like gallery kind of dashboard, you will get the data like this. If you want to manage your cluster, then you can go to the manage cluster thing. You have the STU to manage. You can open this and manage anything whatever required. You can set the alerts, you can explore your system, right? So these are the request rate which we are defining. This is the request latency, and this is the alert filtering. So here we have a lot of things inside this particular STO and the Grafana combination. So team, this is the way how you can deploy your application with the STO, and how you can configure the STO with your application. So thank you team, thanks for your time. If you have any doubt, any question, then please let me know. I will be happy to answer your questions. Hello team, welcome back. In the last lecture, we have seen how we can deploy the application on Kubernetes and how we can plug in the STO with the application. Today we will see how we can do the canary deployment. So first we need to understand what is the canary deployment and how it is useful in the Kubernetes. And we will also see how STO will manage the canary deployment and how STO will make it more easy to deploy the deployment in a canary way. So let's start with. So first we are going to discuss about the canary deployment. Canary deployment is to shift a controlled percentage of user traffic to a newer version of your service, which means canary deployment is a kind of deployment which will be used when you are upgrading the version of your product. So we can assume your product is running on some version, it is running on 8.0.0, and somehow you have done some changes and you have a new release and you are releasing the product 8.1.0. So once you will deploy the product 8.1.0, then definitely you don't want to reroute your complete traffic to the newer version, because if there is any bug inside the newer version, then definitely your complete user base is going to impact from that particular bug. Also there could be the multiple kind of factor of these kind of deployments or these kind of rollout plans, right? So canary deployment is related to the rollout plan, which is like then in this kind of deployment you can reroute a certain percentage of your users to a newer version of the application, and still the certain percentage of user or rest of the user are accessing your older version of your application, right? So suppose we are deploying the new version of application in the market, and we want that just 20% of the workload will route to the newer version and rest 80% will work on the earlier version, and that will be route on the random basis. So this kind of thing and this kind of deployment is called the canary deployment. Let's discuss about a case why the canary deployment is required, and what is the benefit of the canary requirement. So this is a case study on the Facebook, and I believe most of us are using the Facebook. So Facebook was launched in 2007 or 2008, right? And in 2011 Facebook has rolled out a very famous feature on the timeline which is called Facebook Music, right? Once that feature will be rolled out on the Facebook users started loving that feature, and all of the users suddenly started using that particular feature, and in result Facebook was not able to handle that much of traffic, and Facebook server started melted down. I know at that particular time Facebook have some outage as well. So in these kind of release plan or these kind of you can say the rollout plan, you can use the canary deployment, which will be help us to just redirect a few percentage of the traffic on the newer version, and still the rest of the users are accessing the older version, right? So this is called canary deployment, and we will see how we can manage the canary deployment with the STO. The Kubernetes cluster can operate orchestration, canary deployment natively and using labels and a deployment. Inside the Kubernetes, you can label your deployment with the new label, right, version 2, and you can deploy some port on the Kubernetes cluster. So suppose there is 100 pods are running inside your Kubernetes cluster, so you can deploy 20 pods with the newer version and still keep the 80 pods with the older version. But in that particular way, we need to deploy the new pod with the new version, right? And this is the manual effort. So how we can avoid the manual effort and how we can avoid the manual deployment of the pods, right? The way is STO. With the help of the STO, we can manage that particular thing on the fly. So let's see how we can manage the canary deployment with the STO. So deploying with an STO service mesh can address this issue by enabling clear separation between the replica count and traffic management. We'll see how STO will manage that particular thing. STO mesh allows fine-grained traffic control that decouples traffic distribution and management from the replica scaling. It means in the STO, we can define the rerouting rules very clearly, which will not hit the replica scaling or replica set. Instead of manually controlling the replica ratios, you can define traffic percentage and targets, and STO will manage the rest. So instead of defining the few replicas with the newer version and keep the old replicas and keep the few number of replicas with the older version, what you need to do, you just need to define few traffic percentage rules and the targets inside your STO, and STO will manage all the things for you. You don't need to manually deploy the new replicas, new pods inside your system. So with the STO here, we will deploy two versions of the demo Node.js application and use the virtual service and destination rule resource to configure the traffic on both of the versions, on the new version and the old version. And when I'm saying we will deploy the new version, it means we are not going to manage the replica count or the replica percentage manually. So as a part of this new and old version deployment, what we will do, first we will modify the node application manifest file, the manifest file which is running my application. And as a part of this particular update, we will update the version in the deployment manifest, update the image in the manifest, and we need to make sure that we will not touch the manifest labels. Why? Because my service is still referring the same manifest, and we will also not do any kind of change inside my service, because I'm not going to configure the service manually that this particular service will roll out to the newer version and that particular service will roll out to the older version. So I will not change the service. And second thing, I will not change the label inside my manifest, which is basically attached inside the service. So let's go to the Visual Studio and we will see what changes we need to do. So here is a folder which I created. The folder name is Canary Deployment, and here we have the two files, NodeApp.yaml and NodeSTO.yaml. First, we are discussing about the NodeApp.yaml. Let me open this particular file. So here is the NodeApp.yaml of my Canary deployment, and I will open the NodeApp.yaml from the earlier deployment as well. So here is from the Canary deployment, and here is from the earlier deployment which is already running on my cluster. So what I will do, first, I will not change anything inside this particular service. Why I am not changing my service? Because I don't want to reroute the traffic on the basis of the service. My service will still point to the existing deployment. I am not going to change the deployment in this particular way, right? Then what I will do? First, I will change the version of my earlier deployment, which is Node.js v1. Earlier, this was the Node.js. I will rename it and I will call it Node.js v1. That's it. This is the only change in the existing manifest. Now I will scroll a bit. I will copy this complete manifest of the deployment and I will append here. Over here, I will call a new deployment called Node.js version 2. I will define the version 2. Right over here, you can see the match label is same, the label is same. I will take the version 2, and over here I will take the container name same as a Node.js and I will change the image. In the existing deployment, I am using Anshul DevOps STO demo latest, and over here in the new deployment I will change this to Anshul DevOps STO Canary demo. Over here you can see I am on my hub.docker.com, and here I have the two images. One is STO demo and another is STO Canary demo. What is the difference between both of these images? Let me show you some example. Over here, this is the image which is already running on my cluster, right? And this is the new image which I have created. In the new image, there is a one difference, that background color is green. Rest all of the things are same, right? So that we can identify that this is the version v1 and this is the version v2, right? So this is the node app YAML of my Canary deployment. You can see this particular YAML is the same. One more thing, team, I'm not going to change the name of this particular thing. So team, you can see there is only two changes. First, I have versioned my earlier deployment which is running, right, Node.js, and then I have added a new deployment with the version 2. Rest all of the things are same. In the newer deployment I'm using the newer image, and in the existing deployment I'm still using the existing image. So this is the single change which we have to done inside the node app manifest file. Now to route the traffic on the newer version and the earlier version, we need to do some changes inside the node STO gateway and virtual service, right? So as a part of the new deployment, we will modify the node STO manifest file to update the gateway and virtual service rules. And this particular thing, we will add a subset rule inside the virtual service rule to define the additional version based policies to routing rules applying on your application service, which is a version based routing policies which will be apply on your application service, right? And as per that subset rule, we would like to configure routing rules that 80% traffic will served by the original application and 20% will be served by the newer version of my application. And after this, I will add a new destination rule inside my manifest file to apply the subset rule which we have defined inside my virtual service. So there's a two change as well inside my node STO manifest file. You can see here is my node STO manifest file. Let me close the YAML app. This is the node STO of the canary and this is the node STO of the earlier version, right? So over here we have defined the destinations and I have defined the destination host node.js. Inside my newer version, inside the canary version, I have added few things. You can see I have added a subset over here which is version v1 and I have defined the weight with that particular version. 80% weight means 80% traffic. Then I have defined another destination. The host is same node.js. The subset version is version 2 and it is carrying weight 20%, right? If you want, you can modify this as well. You can modify to 50-50, 70-30, 20-80, 30-50, whatever you required, right? So we have added this much of data inside my node STO YAML file. Rest of the things will be same. And then I have defined a new destination rule over here. The kind is destination rule. The metadata, the name is node.js, host is node.js, and over here I have defined the subsets, which I have declared over here. Inside the destination rule, I have defined the subsets. The name is v1, labels is version v1, the name is v2, and labels are version v2. These labels are being picked from my deployment over here, right? v1 for the existing application and v2 for the newer image. So these are the two changes which I have done inside my node app YAML and node STO YAML for the canary deployment so that I can reroute my traffic on a percentage basis. So at this particular point, we have application manifest are updated, but we still need to apply these changes on my Kubernetes cluster. So the question is, how can we apply these changes on my Kubernetes cluster? Team, I don't want to terminate my existing deployment. I just need to push these changes on my running deployment. For this, you can do one thing. We will use the kubectl apply command to apply our changes without completely overwriting the existing configuration. If we will apply the changes, then it will not overwrite the existing configuration. It will just push the new configuration which we have changed inside the YAML files. And for this, we will execute a command kubectl apply -f node app YAML and node STO YAML. So let's go to the terminal and over here I will create a directory canary deployment. I will go to the canary deployment and I will create a file called vi node application.yaml and I will copy these changes and paste in my node application YAML file. If you want, you can also update the existing node application YAML file, right? But to make it more clear, I am creating a new file. In the similar way, I will create another file node sto.yaml and I will copy this particular content in my file. I will save this. Now I will execute a command kubectl apply -f node application.yaml. Hit enter and you will get a message like service node.js unchanged because we have not changed anything in this particular service. Deployment node.js v1 is created because we have updated the version v1 and deployment node.js v2 is created because we have added a new deployment definition inside my node.js application. In the similar way, I will execute a command kubectl apply -f node sto yaml and you can see we are getting a message that gateway is unchanged because we have not changed the gateway. Node.js virtual service is configured and a new destination rule is being created. Now if we will go to the browser, go to the load balancer, copy this DNS and head this DNS multiple times. Then 2 times out of 10 it will redirect to my newer version. Paste it, hit enter. It is redirecting on the older version. Reload the browser, older version, reload the browser, still older version, reload the browser, it's still older version, and reload it. And you can see this time it has been redirected me on the newer version. If I will reload it multiple times, 1, 2, 3, you can see the third is on the newer version. If I will again reload it multiple times, 1, 2, 3, 4, see this time on the fourth attempt. So as per the rule, we have defined 20% traffic on the newer version, 80% traffic on the older version. So as per my rule and as per my configuration, STO will redirect 2 requests out of 10 on the new version and 8 will be same on the older version. If we will go to the Grafana, which is running on port 15031, we'll go to the home STO, open the STO folder, open the STO services dashboard. Over here, if I will choose the service Node.js default SVC cluster local, this is my service. Scroll a bit and you can see we are getting a incoming request by the source and response code. We are also getting incoming request rate 5xx and response code. And over here, if we will see this particular graph, then this two response code is going through with this particular gateway. One is 200, which means request is successful, and another is Ingress ratio system, which is responding 304. 304 means there is no change inside the request and response. It means the yellow line is being responded from the older version, and here is the newer line which is in the green, which is being redirected from the newer version, right? If you will refresh multiple times, you will see the new jumps on the graph. And you can say blue screen response is too fast, but the green screen response is taking some time. There's a fraction second time difference because this is redirecting the request to the another one, and you can see the graph is being presented over here, right? So this is the way how can we redirect your traffic to the newer version of your application, and this is called the canary kind of deployment, and this kind of deployment is called the canary deployment. This is also justifying a point which we have discussed inside the STO installation, that STO will manage the complete traffic redirecting and load balancing of my Kubernetes cluster. So the proxy which is attached to the pod, that is managing the complete access control, the traffic rules, the resources and monitoring as well, right? So STO is doing a lot of things for me, right? What we need to do, just we need to create a more heavy machine. It will take around 1 GB and 1.5 GB memory to execute the process. So thank you team, thanks for your time. In the coming lecture we will see some new things. Thank you. Hello team, welcome back, and today we will discuss the retry logic in STO framework. So let's start with, so we are executing the Kubernetes on the cloud, and Kubernetes is executing my application on the cloud, right? But in dynamic cloud environment, there could be the scenarios when the intermittent network connectivity errors occur, and they will cause the service to be unavailable. In that particular case, what are the scenarios to recover from these particular scenarios? So to handle these kind of errors, you need to design your microservices architecture in a way that will handle the transient errors gracefully. But this thing can also be managed by a simple retry mechanism. After a small delay in the request call, you can retry your request again. STO provides an inbuilt retry mechanism for the request call, right? Just you need to define the retries and retry policies, and STO will automatically retry the call as per the defined policy. Retry design pattern state that you can retry a connection automatically which have fails earlier due to the exception. Load balancer might point you a different healthy server on the retry and your call might be successful. So it may possible when you are requesting some resource and that call is going to a particular resource, a particular pod which is already doing some kind of work or which is not available. In that case, your request will be failed, right? But with the help of the STO, load balancer will automatically send that particular request to the another pod or the another resource so that STO can handle the error and your call will not be fail. Retry pattern can stabilize your application for intermittent network issues. Also, it will reduce the burden on the application for handling the failure in such case of the transient errors. User can specify the number of retries attempts in a virtual service. right? And you can mention the interval between the retries. So when we are defining the virtual service manifest, we can define the number of retries, that how many times I want to retry my services before throwing the error message, and what should be the interval between each retry. If the request is unsuccessful after the retry attempts, the service should treat it as an error and handle it accordingly. For this, you just need to do a small change of virtual service manifest, and you need to apply that updated manifest on your cluster. So suppose this is the virtual server sample manifest. We are defining the API version. We are defining the kind, which is virtual service. The metadata service A, inside the specification, I'm defining the host. This is the HTTP request, route and destination, which is host. We have seen this much of work, right? After this, we are defining a simple block inside the route, which is retries. After this, I'm defining the number of attempts, how many times that particular service is going to hit the server, and the time gap between each try, right? So if the service will fail to contact to the pod on first time, then it will try four more times, and after this particular gap, the 2 second gap is here, right? And if the call will fail in each five attempt, then it will throw the error on the application, and application will handle it. Otherwise, if any call will be successful, then it will return the success message to the customer and request will be proceed further. So this is the retry mechanism in the STO framework, which is very helpful for the microservice architecture, and which will reduce the number of errors in my services, right? So team, this looks like a very simple, but actually this will help a lot in the microservices architecture. So thank you team, thanks for your time. Hello team, and congratulations to all of you to complete this milestone. So that's the last lecture of this particular course, and after this you would be able to download the certification for the Kubernetes and Docker course. In this particular course, we have discussed in details about the Docker, Docker Swarm, Docker Compose, Kubernetes, Kubernetes administration, and Helm. We have discussed a lot of things, which was around 28 to 29 hours long lectures. So now we have a very sound knowledge of the Docker and the Kubernetes. So congratulations you all for your achievement. You can download your certificates, and you can share this particular course with your friends so that they can also get the benefit. If you want to enroll any of my other course, you can let me know. You can message me, and I will share the coupon code with you so that you can get it on the discounted price. So thank you team, thanks for your time, thanks for your effort, and thanks all of you.